Do you know, according to Indeed.com, the average salary of a MERN Stack developer in the US is $120,000 per annum, and it can go up to $200,000 per annum. Today's video will be a full course on MERN Stack for 2023, starting from the basics to the advanced topics. We will start this full course with React, which is a front-end development tool for creating web applications. We will cover from basic topics like components, props, states, and advanced topics like methods in React, and finish it off by creating a beautiful portfolio project using React.js. Next, we will cover Node.js, which is a JavaScript runtime that allows developers to write server-side code in JavaScript. In Node.js, we will cover topics like NPM, which is a node package manager. Then we will see REST API, Node.js Authentication with JWT, and many more topics. Once we are done with Node, our next step would be to learn Express.js. So Express.js is a lightweight framework that allows developers to create server-side web applications quickly and easily. In Express, we will learn about methods like error handling in Express.js, how to connect server-side to the client-side, and many more. Once we are done with all three, the next logical step would be to understand MongoDB, where we will cover MongoDB from basic to advanced. We will discuss data modeling, operators, projection, indexing, aggregation in MongoDB, and many more. Towards the end of this full course, we will cover interview questions on each of these four technologies to make you interview ready, and you can land a great job in the domain of MERN Stack.
Hey everyone, I'm sure you're all aware that every application that we use today has something called the front end, which is the user interface, and the back end, which is the software that accesses data for us, and finally we have the database to store the data. Now these three together form something called as the full stack. So hi guys, welcome to this video on what is full stack by Simplilearn. But before we begin, if you haven't subscribed to our channel already, make sure to hit the subscribe button and the bell icon to never miss an update. So here's what's in store for you. First, we'll have a look at what front-end development is. Then we'll see some of the front-end languages. Then we'll move on to some front-end libraries and frameworks. Then we'll see what back-end development is, understand some of the popularly used back-end languages and frameworks, and finally we'll have a look at the database. So now what exactly is front-end? Every time you open a website, it has several UI components. And once you click on a particular icon, say sign in this case, you get navigated to the sign in or the login page, right? So what happens is that all of these items facilitate navigation and utility. These are collectively called as the front end. So the front end is the visible part of the website or the web application which is responsible for user experience. The user directly interacts with the front end portion of the website or the web application. So now let's have a look at some of the front end languages. So I'm sure you've heard of HTML, CSS and JavaScript. So these are collectively called the front end languages. When it comes to HTML, it defines the structure of websites and formats the web pages. It also defines text documentation. So let's look at a simple example.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So here I've made use of the h1 tag, which is the heading tag in HTML, and I've displayed the message hello welcome. So correspondingly, my website displays the same message. So HTML is responsible or it defines what is being shown on the website. Next up is CSS. Now CSS is a style sheet that allows you to alter and style different web components, be it size, font, spacing, etc. It makes the content on the website look more decorative, correct? So now if you have a look at the code here, I've added some styling. I've changed the font style to italic. I've made the text bold and I've changed the color to red. And again, correspondingly, all the changes are seen on the website. Moving on, we have JavaScript. Now, JavaScript is a very powerful client-side scripting language, and it is mainly used for enhancing the interaction of a user with the web page. So again, if you have a look at the code here, I've created a form wherein the user can enter their name. And I've also displayed the message, please enter your name. As a result, an input box is made available where the user can type in their name. Now this is facilitated by JavaScript. So as I mentioned earlier, it is used to make web pages interactive and bring the web applications to life. So next, let's have a look at some front-end frameworks and libraries. Now most of these are JavaScript frameworks and libraries. First we have React, then there's Angular, there's Vue, there's jQuery, and then there's Bootstrap. Now all of these help develop the front end of the application. However, when it comes to React, Angular, and Vue, it's not necessary that you must know everything to create a website. One of them will be sufficient. However, the usage of React is on the rise and most of the developers prefer using React. jQuery and Bootstrap are also powerful frameworks that can be used to create interactive web pages. Now that you know what front-end development is, you must be wondering how the data is being fetched and how this data is being presented in front of you on your screen. Correct? Now this is all facilitated by the backend of the application. So let's understand what backend development is. Now backend basically refers to the server-side development of the application. It is responsible for managing all the database with the help of queries and APIs. So every time the user makes a request, it queries the database and retrieves the data from the database and presents it to the user. And lastly, it ensures data consistency. So now let's have a look at some backend languages and frameworks. Firstly, we have Node. Node and Express.js are packages provided by JavaScript. Then there's Python, which is a very popularly used language. Python frameworks like Django and Flask are popularly used to create the backend of applications. Then there's Java, and Java provides Spring and Java Server Faces, which are also used for backend development. Then there's C#, which provides frameworks like ASP.NET Core and ASP.NET MVC. And other popularly used backend languages are PHP, there's Perl, and Ruby. Database is the collection of interrelated data which helps in efficient retrieval, insertion, and deletion of data from database and organizes the data in the form of tables, views, schemas, reports. Now some of the commonly used database management systems are MySQL, there's PostgreSQL, there's Microsoft SQL Server, there's Oracle Database, and then there's MongoDB. But how can we at Simplilearn help you? If you wish to make a career as a full stack developer, then a certification will come in handy. For that, you could head to our official website and look for full stack development courses. Now we offer the full stack Java Developer Masters program. We also provide the postgraduate program in full stack web development, and we also provide the full stack web developer MERN Stack Masters program. You can go ahead and click on the program and have a look at the overview. If this suits your requirements, you can go ahead and purchase the course. Hey everyone, welcome to another video by Simplilearn. In today's video, we're going to be comparing two commonly used technology stacks, that is MERN Stack and MERN Stack. But before we begin, if you haven't subscribed to our channel already, make sure you hit the subscribe button and the bell icon to never miss an update. So first, let's begin by understanding what exactly is a technology stack. Now, a technology stack is a combination of programming languages, frameworks, and tools that developers use to build a web or a mobile application. Now, the two main components of any app are the client side and then the server side. And each layer of the application is built atop of the other, thus creating a stack. Now, the server side is not visible to the user, but its programming languages power the user side and create the logic of websites and applications. When it comes to client side, now this is everything that users can see on their screens and where the interaction is happening. The three main technologies that fall under client side are HTML, CSS, and JavaScript. So now that you know what a technology stack is, let's go ahead and understand what exactly is MERN Stack. Now, MERN Stack is defined as the collection of JavaScript technologies that assist in building complex websites. Right? Now, MERN is basically an abbreviation that stands for MongoDB, Express.js, AngularJS, and Node.js. Now, this framework provides quick and easy development of web and mobile applications. It also provides popular plugins and reduces time on system administration. So if you want to speed up the process of web and mobile application, MERN Stack is an appropriate choice. Now, while talking about the components, MongoDB here is used to store the data of backend applications like JSON files. Express.js is a backend application that runs on top of Node.js. You have Angular, which is the front-end framework that runs the code on the browser. And then you have Node.js, which provides a runtime system for JavaScript on the backend web application. So this was all about MERN Stack. So let's go ahead and understand what MERN Stack is. Now, MERN Stack, like MERN Stack, is also an abbreviation. So it stands for MongoDB, Express.js, React.js, and Node.js. Now, this framework also provides quick and easy development of web applications using Java as its main component. Now, it is used for development of websites, and it makes use of libraries, databases, and frameworks. Now, MERN Stack ensures a smooth development process and is becoming increasingly popular in the development market. Then again, MongoDB here, it is a document-oriented NoSQL database that is used to store backend data. Then you have Express.js, which is a layered framework built on top of Node.js, and it takes care of all the website's backend functionality and structure. You have React.js, which is a JavaScript library that creates user interface components for web applications. And then you have Node.js, which is a runtime environment capable of running JavaScript on a machine, right? So this was MERN Stack. Now you must be wondering what exactly are the differences between MERN Stack and MERN Stack. So let's go ahead and look at them. First up is the obvious difference that in MERN Stack we use Angular, while in MERN Stack we use React.js. Now, Angular is obviously a JavaScript framework used to build single-page applications, while React is an open-source JavaScript library used to render components for a smooth user experience. Next up, MERN Stack uses TypeScript language, while MERN Stack uses JavaScript and JSX. Now, JSX is a combination of JavaScript and HTML. Now, since MERN Stack uses Angular, the flow of data is bidirectional. That means any changes made to the view part of the application is reflected in the model part as well, and vice versa. But in the case of MERN Stack, which uses React, it uses unidirectional flow of data. Meaning, first the model state is updated and then all the changes are rendered to the view part of the application. Next up is that MERN Stack has a better learning curve. You need to know all the concepts of Angular like data binding, services, routing, bootstrap, etc. And in case of MERN Stack, it offers excellent documentation, making development extremely smooth. So now you must be wondering which one to choose. Now you know what MERN Stack is, you know what MERN Stack is, you know how they function, what the stack comprises of, what are the different types of concepts that can be used, etc. But if you're wondering what to choose, then this section will help you clarify the doubt. So there are many companies that readily use different types of stacks for web development. So companies like Accenture, Raindrop, Wungle, among others use MERN Stack, while companies like Uber Eats, Instagram, Walmart use MERN Stack. Also, both the stacks provide an incredible user experience, and stability and scalability are the objectives of both these stacks. Now, enterprise level projects require MERN over MERN, and MERN makes rendering the user interface simpler, and both of these are quick for front-end development. However, MERN Stack is good for large-scale applications, and MERN Stack is used for faster development of smaller applications. So, in conclusion, one isn't necessarily better than the other, but choosing the right stack for your software process depends on the front-end framework or related tools that you would like to use. Right? So if a developer or team prefers using Angular, they may choose to work with MERN Stack. Meanwhile, a developer or a team that enjoys using React will gravitate towards MERN Stack. So it's basically just your choice and your requirements. In today's video, we'll be learning all about React.js. So let's jump in and see what's in store for us. So we'll be covering topics on what is React, why React, features of React, React prerequisites, and its industry trends. Let's go ahead and begin with what is React. React is a JavaScript library used to build fast and interactive user interfaces for both web and mobile applications. Now, one thing that makes React extremely powerful is the fact that it's open source. Any user can access its source code, modify it, and enhance it. In a typical model view controller architecture, React defines the view part of the application. It is also responsible for how the app looks and feels. Fun fact, React was built by Jordan Walke, an engineer at Facebook. Now let's go ahead and see how React works in real time. Consider a typical web application, say Instagram. The entire UI of the web page is divided into several components. We have the search component, a profile description component, stories component, and a post list component. These components make the code easier to debug and always remain discrete. Components also make development and maintenance of web applications faster, as multiple developers can work simultaneously on different components of the same web application. Now let's see why React is so popular these days. React helps in creation of dynamic web applications. It also provides performance enhancements. Now there are several performance enhancements like virtual DOM and one-way data binding. We'll learn about these topics a little later in the video. React uses reusable components. Now this helps decrease the development time. React involves unidirectional flow of data. React also has a small learning curve. Compared to other frameworks like Angular, React is much easier to learn. React can also be used for mobile applications. React recently released an extension called React Native that is used for developing mobile applications that are cross-compatible. It also has dedicated tools for easy debugging. Now let's dive in to the features of React. First, let's understand JSX. JSX is a syntax extension to JavaScript. Using JSX, we can add HTML to the JavaScript file. All coding in React is done using JSX. It also helps in making the code easier to understand and debug. Ultimately, JSX is a combination of JavaScript and HTML. Now let's consider a small example. Const simple here is a JavaScript notation. H1 tags indicate HTML. Again, the semicolon indicates JavaScript. Note that the semicolon is not mandatory. However, it's a good practice to include it. Moving on, the next feature is virtual DOM. DOM, which is an acronym for Data Object Model, actually defines how documents are accessed and manipulated in a web page. It represents the entire structure of the web page in the form of a tree. Now let's see how this actually works. React creates a virtual DOM that is the exact copy of the real DOM. Traditionally, whenever something changes in the web application, all objects in the real DOM are updated. This makes it extremely slow. Let's see how React counters this. Now consider two objects whose states have been changed. React now compares the virtual DOM with the virtual DOM snapshot that was taken right before the update. By comparing the new virtual DOM with the pre-update version, React figures out exactly which virtual DOM objects have changed. Now React only updates those objects on the virtual DOM. This makes a big difference when it comes to speed. Coming to the next feature, performance. React uses virtual DOM. As discussed earlier, virtual DOM impacts the speed of the web applications. We also took an example of Instagram and learned how multiple components can affect the development time. They help improve performance drastically. The next feature is one-way data binding. This means information flows in only one direction. One-way data binding is specifically used when information is displayed and not updated. Remember that the components of React are functional in nature. That is, they receive information through arguments and pass information via their return values. The next important feature is extensions. React has many extensions that we can use to create full-fledged front-end applications. It provides server-side rendering, which means that the application is rendered on the server rather than in the browser. React Native, which is a React extension, is used for developing mobile applications. There are many other extensions that React provides for every scenario in web development. Now let's look at a few of them. React Native lets you build mobile applications using only JavaScript. A React Native app is a real mobile application and not just a web application running on your mobile devices. Thousands of applications like Facebook, Instagram, Pinterest, Skype use React Native. The next popular React extension is Flux. Flux is the application architecture that Facebook uses. Flux implements a unidirectional flow, which makes it easier to understand what actually is going on. Now let's see how it works. When we trigger an action, the dispatcher will get notified. The dispatcher receives actions and dispatches them to the stores. A store is what holds the data of an application. Stores will register with the application's dispatcher so that they can receive actions. Data from stores is displayed in views. Actions define the internal API of your application. They capture how anything might interact with your application. The last feature of React is debugging. React applications are easy to debug thanks to the large and active developer community. You can practically debug React codes within your browser. Now notice the small React extension icon at the top right corner. This developer tool allows the user to inspect the code and also easily debug it. Moving on, let's learn about the building blocks of React. Components, state, and props are the essential concepts that one should know before implementing React. They are the foundation on which React is built. Now, what exactly are React components? Components are the building blocks of any React application. React divides the user interface into multiple components, wherein each component defines how a particular element is viewed in the application. React components remain discrete and are processed independently. Another feature is reusability. Components can be reused multiple times across the application. This reduces the development time. Consider the following code snippet. A component is implemented as a JavaScript class having some state and a render method. State is the data which we want the component to render. The render method is responsible for how the UI looks and feels to the user. The next concept is state. State of a component is an object that holds some data. This data influences the output of a component. Every time the state of an object changes, the component is re-rendered onto the screen. Now let's see what props are. Props, or short for properties, allow us to pass arguments or data to components. Properties help make components more dynamic. It is important to define all the properties, their types, and their default value. Props are passed to components in a way similar to that of HTML tag attributes. Now consider the following code snippets. This shows exactly how properties are passed to components. Also, detailed illustrations on components, props, and state will be shown in the upcoming videos, so stay tuned for that. Moving on, let's go through some of the things that you should know before you can actually start working on React. You should be familiar with programming concepts like functions, objects, arrays, and classes. One should also have a basic knowledge of JavaScript and a familiarity with HTML. Don't worry if you feel like you're not good at them. Once you start working on them, you'll get a good hang of it. Finally, let's go through the impact of React on the IT industry and get insights into the salaries of React developers. Statistics show that React developers earn way more than other web developers. According to PayScale, the average salary for a React developer in the United States is a whopping $91,000. The average salary for a React developer in India is 7.25 lakhs per annum. Over the recent years, React has gained immense popularity and is being adopted by many companies. According to the data by Google Trends, React has had a better growth scale compared to other frameworks like Angular and Vue. Statistics show that front-end developers have wholeheartedly adopted this lightweight framework, foregoing other available options. If you are skilled and have a knack for front-end development, React can help you gain fantastic career opportunities. Lastly, talking about a few companies that use React devotionally, we have Facebook, Instagram, Netflix, Dropbox, WhatsApp, among others. In today's video, we'll be learning all about React installation on Windows. So without further ado, let's get started. To set up the React development environment, we need two things installed: Node and a text editor of your choice. So let's begin by installing Node.js. We can head to the official Node.js website, say download Node.js. So here you can see the Windows installer. Depending on your system, you can either download the 32-bit version or the 64-bit version. So I'm going to go ahead and click on the 64-bit version. Since it's already installed on my system, I'm not again installing Node. You can follow the installation guidelines and download it. Once you're done with Node installation, you can go ahead and download a text editor of your choice. So I'd suggest VS Code. So let's head to the VS Code page. Say download VS Code. Click on the first link and download the 64-bit version for Windows. Once you're done with the installation of both Node and your text editor, you can start creating your first React application. So for that, let's create a folder. I'm creating it on my desktop, while you can create it in any of your drives. Let's call it first React. Now open your command prompt. Now you can type in the path for the folder that you just created. So say cd users first React. Now go ahead and type in the command npm install -g create React app. Okay, so this command installs all the necessary React.js modules. Now to check if the version is correctly installed, you can type in create React app version. So you can see the version here. Now let's continue and develop your React application. Type in the command create React app and you can give a name to your application. So I say my app. Now this should take a couple of minutes. Okay. Once you've successfully created your application, they say to begin by typing the following commands. So let's do that. Say cd my app and npm start. They should typically start your application, and here we go. Alright. You can also open your application in the text editor that you've downloaded. So let's go ahead and open VS Code. VS Code, file, open folder, go to your desktop or the drive that you've saved your folder in. First React, my app, and I say select folder. So as you can see, all your modules have been imported. You can click on app.js and start editing. In today's video, we'll be learning all about the most basic infrastructure of React.js called components. Without delay, let's begin and look at what's in store for us. So we'll be touching on topics like what are components, types of components, nesting components, higher order and pure components, and a brief description about component lifecycle. Alright, to begin with, what exactly are components? Components are the building blocks of a React application wherein each component represents a part of the user interface. Now to make it more understandable, consider the Facebook homepage. The entire UI can be broken down into several elements. Say we have the credentials component, the sign up component, the image component, and the logo component. Notice that each component adds something to how the homepage looks. Alright, reusability is one of the salient features of React components. One component can be reused several times across the application, and this improves the development speed. Components can also be nested. One component can internally consist of several other components. In its minimal form, a component must define a render method that specifies how exactly the application looks and feels. A component can also receive properties from its parent components. Also, you'll get a better understanding of all of these when we start working hands-on, so don't worry. So, moving on, let's look at the different types of components. First, we have the stateless functional components, and then we have the stateful class components. Now, functional components are typical JavaScript functions that return HTML. Now, they can be contained in a .js or a .jsx file. Coming to class components, these are regular ESX classes. However, it's mandatory that they contain a render method that in turn returns HTML. They can also be contained in .js or a .jsx file. Okay then, let's go ahead and build our first React application using components. Alright, so I've opened my text editor, that is VS Code, to build my application. Also, I suggest you watch the React installation on Windows video to help you get started. The video briefly explains how to install Node and how to start building your first React application. In my case, I've opened a folder called React Component Tutorial, and here in my source folder, I have app.js. Now, app.js is the main component that gets rendered to the DOM. Let me show you that. Here in index.js, you pass app.js, which is a component that gets rendered to the React DOM. So app.js consists of several other components that can be nested. So as you can see, app.js is a functional component. And before moving on, let me get rid of all the unnecessary code. So let me delete all of this and return an h1 tag that says hello, welcome to Simplilearn. Let me save it, and if you look at the browser, you'll have hello, welcome to Simplilearn. Now let's go ahead and display another message. Say h1, this video is about components. Right, let me save it and let me check the browser. It gives you an error. So JSX uses a conventional rule which states that all HTML tags have to be enclosed within a div tag. So for example, I say div and I enclose it. So let me save and check my browser again. Here you go. So multiple HTML tags have to be enclosed within the div tag. Moving on, let's create our first functional component. To do that, I'll first create a folder in my source folder, say components. Within that, I'll create a file, say functional component.js. Alright, so the first thing we have to do is import React. So I say import React from React. The general syntax for a functional component involves the keyword function and say functional component. Now you say return an h1 tag, or I've already used h1 tags, so I'll say paragraph and I say this is a functional component. Alright. Before explaining to you how these components are exported and imported, let me show you the general syntax for a class component. So I create another file, say class component.js. I again import React from React. The general notation is using the class keyword followed by the name of the class extending from the base class React.component. So going ahead, I say class component extends React.component. Now the key feature of a class component is the usage of a render method. So I say render, within braces I say return a paragraph tag saying this is the class component. Alright. So moving on, let's see how these components can be nested into the main component, that is app.js. Components can be nested into the main component using import and export keywords. So as the name suggests, export feature is used to export a particular file or a module, and import is used to import a particular file or a module into the current existing module. So we have two different types of exports. You have default export and just export or named export. So a default export is used to export just one object, be it a function, a class, a variable, from the file, and there can only be one default export per file. And when you're importing it, you can specify the address and use the word import before it. So let me show you how it works. Let's go back to our editor and then functional component. And here I say export default and the name of the functional component, that is functional comp. So let me save this, and going back to my app.js, I say import name of the functional component, that is functional comp from, and I pass the path, this components/functional component. Also, let me get rid of these unnecessary files here. Now let's define functional component in our app.js component. So here I say functional comp. Let's compile it and check our browser. Here it says this is our functional component. Moving on to my class component, it's the same syntax here as well. I say export default name of my component, and in my app.js I import it. Import class comp from the path, and again I'll have to define it in my return method. I say, so let me compile it and check my browser. It says this is the class component. One unique feature of default export is that I can rename the file while I'm importing it. So for example, I can rename it as say FC, and while I'm defining it, I'll have to make sure I use the same naming conventions. So I say FC again. And when I check it, it says this is the functional component. There's literally no difference. The next type of export is the named export or just export. So a named export can be used to export multiple objects, be it functions, class, etc. from a file. Now there can be several named exports from a single file. One hack is that while you're importing, it cannot be renamed. So let me show you how this works. Okay, so let's create another class in our class component. So I'll just copy paste this. Let me give it another name, say class comp1. And the message that I want to display is, hey, I'm another class. Alright, so when I'm exporting it, I don't want default. So let me take it off and say export here. Alright. In my app.js, while importing it, I want to import both the classes. So I'll include them within curly braces here. I say class comp, comma, class comp1. And then again, I define it here, class comp1. Let's compile it and run it, and here we go. Here you can see, hey, I'm another class. So we've successfully exported both the classes from the class component and imported it back in our app.js component. One advantage of using named export is the fact that I can choose to import the classes that I want to. Now say for example, I do not want to import class component here. So let me take it off, and here let me comment this. Now let's compile and see. Hey, I'm another class. The second class got imported while the first class I was defined earlier is not imported here. Alright, so next up we have higher order and pure components. Now I won't get into the nitty-gritties of it because they're advanced topics, but to give you a brief insight, higher order components are basically functions that take in a component and return a new component. The whole ideology behind higher order components is to facilitate the reusability of component logic. Okay, so let's see how this works. Let's go back to our code editor. Let's create a component in our components folder. Let's call the component click.js. Alright, so here we define a class. I use this snippet RCE. Here we go. We get the entire format using the small snippet RCE. And here I'm going to make use of a button. Now say I use the tag button and I'll say clicked one time. Every time the user clicks on the button, the value gets incremented. So for this, I'm going to use a variable say count, and I'm going to use the concept of states. So let's go ahead and define our variable count and initialize it to 0. So for that, I'm going to use another snippet called rconst. And here, this dot state equals my variable count, initializing it to 0. So let's define the count variable in our render method. So I say const count equals this dot state. So every time we click on the button, the count value has to get incremented, right? So we make use of an event called onClick equals this dot update click. Now update click is going to be another method that we have to define now. So every time the button gets clicked, this method is called. So let's go ahead and define the function. So it is update click equals, it's going to be an arrow function, and I say this dot set state is nothing but count this dot state dot count plus 1. Okay, and here we say count times. Alright, so once this is done, let's import our component in app.js. So here again, I say import click from components click, and let's define it here. So let's check our browser. Every time we click on the button, the value gets incremented. Alright, so let's go ahead and create another component, say counter.js, wherein every time the user hovers the mouse on the button, the count value increases. So let's go ahead and do that. I say counter.js. I'm again going to use the snippet RCE to create a class component. And here in my div tag, I define a button and say incremented to, for now I say X. So now let's go ahead and add the event. Say button on mouse enter. I'm going to call the method this dot increment count. Okay, so once you're done with that, let's go ahead and define the increment count method. I'm going to copy the same code that I've mentioned in my click.js. So I say copy this. Alright, so one change is that I'll change the name of the method and call it increment count. Again, let's define the count in our render method. So I say const count equals this dot state. And here I change X to count. Now let's go ahead and import it in our app.js. So I say import counter from components and counter. And let's define it here. Alright, let's save it and let's run the code. Okay, so as you can see, you see another button here incremented to 0, and every time I move my cursor on the button, it increments. Mind you, I'm not clicking, I'm just hovering my mouse. Okay, to learn how higher order components work, we'll have to pass counter.js and click.js as parameters to give birth to an entire new component. So for that, let's go ahead and create another component for our HOC. Let's call it higher order.js. Okay, so I say import react from react. After that, I say const updated component equals original component. That's going to be an arrow function again. And within curly braces, I define my class. That is class say new component extends react dot component. Inside, let's define a render method that returns the original component with a modification, that is, I want to type the user. I want to append the user before the actual message is displayed. Alright, so let's go ahead and close the tag and return new component, and let's export this. Say export default updated component. Now we import higherorder.js in our counter.js and click.js and pass these components as parameters. So let's do that. Let's go to our counter.js and here I say import updated component from ./higherorder component. And here while exporting I say updated comp and pass this as my parameter. Let's do the same to click.js. Here I import updated comp from higher order component and here I pass this as a parameter. Now here in our higher order component, we've defined a property name and initialized it to the user. So we'll have to include this in our other components, that's counter and click. So let's do that. And here right before incremented to, I say this dot props dot name. Let me save it. Let me do the same thing here and say this dot props dot name. So if you go back to our browser, here you can see it says the user clicked 0 times and the user incremented to 0. Okay. So this basically shows how React implements reusability of components. Moving on, our next topic is pure components. Now another way to create class component is by extending pure component from React. A pure component avoids unnecessary re-renders. Now how does it do it? It does not implement the should component update method. Now you'll learn about this method a little later in the video. Now this method enables re-rendering of components to the DOM. But a pure component on the other hand ensures a shallow comparison of states and props and checks if a re-render is actually necessary. Only then does it render to the DOM. A React component can be considered pure if it renders the same output for the same state and props. So let's take an example to explain pure components. So let's go back to our VS Code and create 2 component classes, one for a regular component and the other for a pure component. Now using this example, I'll show you exactly how pure component is more helpful. Okay, so let's create a pure component.js file. I say pure comp.js. So here I'm going to use a snippet rpce that is going to create a pure component class. Let me get rid of this export. And here in my div tag, I'll display the text, say, I'm the pure component. Alright, now let's go ahead and create a regular component. I may call it regular component.js. And here I'm going to use the snippet rce. And the message that I'd want to display is, I'm the regular component. So to draw a comparison between the regular component and the pure component, let's create a parent component for the two. So let me create one here. I'll call it parent component.js. And this is again going to be a regular class component. And here I display the message, I am the parent component. To change the state of the component, we're going to make use of a constructor. So let's use the snippet rconst. And here let me create name, you can give anything, and I say Simplilearn. Now we make use of the component didMount lifecycle method to set a time interval. Now don't worry about this, we're going to learn about it a little later in the video. So moving ahead, I'm going to make use of the method and say component didMount. And here I say set interval. And the first argument is going to be an arrow function and the second will be the time interval. And I'm going to be setting it to 3 seconds. Now within the arrow function, I'll make use of the setState function to set the state of my property. However, I do not change the name. I keep it Simplilearn itself. Moving on, let's import pure component and the regular component into our parent component and then pass name as a property. So to do that, first import pure comp from pure component and then I say import regular comp from regular comp.js. And here let's say regular comp name equals this dot state dot name and I say pure component name equals this dot state dot name. Now let's include the property name in both our regular and pure components. So to do that, let's just say this dot prop dot name and here I again say this dot prop dot name. And finally, let's import parent component into our app.js component. So here I say import parent comp from, okay, and here let me define parent comp. So now if you look at the browser, we have I'm the parent, I'm regular component Simplilearn, and I'm the pure component Simplilearn. We've got the result as expected. Now to check if the pure component is actually re-rendering or not, let's include simple console.log statements. So here I say clg snippet And here I say pure component render. And in my regular component, I do the same thing. I say console.log regular component render. Now let's do the same in our parent component as well. Here I say parent component render. Alright, so let's go back to our browser and inspect it in our console. First the parent component gets rendered, then the regular component, and then the pure component. After that, for every 3 seconds, only the parent component and the regular component is rendered. For the same state and prop, the pure component is not re-rendered. So in conclusion, pure components optimize React codes and also improves performance. So coming to the last topic, component lifecycle. So basically, component lifecycle explains the stages the component goes through. The entire lifecycle of a component can be divided into 3 parts. We have mounting, updation, and unmounting. So the first thing that gets invoked in the lifecycle is component will mount. It is invoked right before the initial rendering occurs. Then we have the rendering method. Now once a component is inserted into the DOM, component did mount gets invoked. Coming to the next phase, we have updation. When a component receives props, component will receive props gets invoked. Set state is called when the state of the property changes. So every time there is a change, React decides whether the next component's state should trigger a re-render or not. To do that, should component update method is called. Component will update is invoked right before re-rendering. After re-rendering, component did update is called that makes updates to the DOM. And the last phase is unmounting. Component will unmount method does all the necessary cleanup and erases all the allocated memory and cycles. In our previous video, we learned about React.js components in detail. And now, moving ahead, let's learn about another striking feature of React.js called props. Props, short for properties, allow the user to pass arguments or data to components. A parent component can pass additional information to its children using props. Properties help make components more dynamic. Props are passed to components in the way similar to that of HTML tag attributes. Now we'll look at this a little later in the video. Props in a component are read-only and cannot be changed. One thing to remember is that props are sent by the parent to the children components. Hence, the children components cannot make any changes to these props. Now that we've learned about props in brief, let's go ahead and create our application using props. If you're new to this tutorial, I suggest you go to the React installation and React components video on our channel. So back in my code editor, that is VS Code, I've opened a folder called React Props. And now I'm going to create a component, a class component, and I'll call it class props.js. So let's create the class component. I give RCE, the snippet. And here I display a message saying an h1 tag basically. Alright. Now let me get rid of export here and import it in my app.js main component. Here I say import class props. Alright. Now we define the class component in our render method. Let's say. Alright. Now if we go back to the browser, you see hello learners, welcome to Simplilearn. Now let's say we want to individually welcome every student. Instead of retyping the message for everybody, we can pass their names as props. Now let's see how to do that. Now we pass the name as a property from the main component, that is app.js, to the child component and render this onto the browser. So let's do that. So here, while I'm defining my child component, I say name. I save it, and here in my child component, instead of learners, I use the keyword this dot props dot name. Let me save it, and if you look at the browser, we'll have hello learner 1, welcome to Simplilearn. Now let's go ahead and welcome learner 2 and learner 3. So I again say class props name equals learner 2. Alright, so if we save and look at the browser, we'll have all the 3 learners displayed on the browser. We can also pass multiple props to the child component. Now say for example, we want to welcome the student from a particular place. So we say welcome learner 1 from place X. So I can here define another property, say place, and say place. Similarly, I can do it for the rest too. Say place y. Now let's go back to our class props.js component and here say hello learner1 from this dot props dot place. Let me save it. And if you look at the browser now, we have hello learner1 from place x, place y, and place z. We can also display whatever we want between the opening and closing tags when invoking a component. Now this is facilitated using props.children reserved keyword. Now let me explain to you how it's done with an example. Here, let's split the self and closing tag into an opening and a closing tag. And in between them, let me display a message within the paragraph tag. Let me say, and in my child component, after my h1 tag, let me use a paragraph tag, and here let's use the reserved keyword this dot props dot children. So let's save it. And now if you look at the browser, you can here see the message displayed child component. So props.children can be used when components do not know about their children ahead of time. This is commonly seen in components like sidebar and dialog that represent generic boxes. So let's go ahead and create a button tag and check again. So here I'll split it and add a button tag and say click. And let's check our browser. Here we go. We get the output as expected. Alright, we saw the usage of props for class components. Similarly, we can use it for functional components. So let's go ahead and create a functional component. Let me call it, I say import React from React. And then I say function props. And here I return an h3 tag. I'll say this is functional component, and I'll return another h3 tag saying hello learner. So let me save this and let's export it. Export default function props and import it in our app.js again. Import function prop from function prop. And here in our render method, let's define it. Let me call function prop name. Let me give learner 4 and place say A. Let me close it. And back in our functional component, instead of learner, I say props.name. Let me save it. Now, if you look at our browser, it gives us an error. It says props is not defined. So let's go back to our code editor and pass props here to our functional component. Also, let me define hello props.name from props.place. Let me enclose it within the div tag here. Let me save it. And now if you look at our browser, here we go. We get the output as expected. So let's begin and learn what exactly is a state in React. Typically, a state is an object that stores the values of properties belonging to a component. Now, these values can change over a period of time either via user interactions or network changes. And the state helps facilitate this functionality. Every time the state changes, React re-renders the component to the browser. The state is initialized in the constructor. A state can also store multiple properties. A method called setState is used to update the value of the state object. Now this function performs a shallow merge on the new and the previous state. Conventionally, a shallow merge ensures that the previous state values are overwritten by the new state values. Moving on, in our previous video we learnt about props, and although props and state dictate and control the behavior of a component, they have significant differences. So let's go ahead and draw a comparison between the two. Firstly, props in a component are used to pass data and event handlers to its children, while state on the other hand is used to store the data that has to be rendered on the web page. Props are immutable. Once set by the parent, they cannot be changed. State holds volatile data and can be changed over time. Props can be used in functional and class components, while state is restricted to class components. Props are set by the parent component, while a state is generally updated by event handlers. Now that we've learned all about state, let's go ahead and build an application to see the working of state. Alright, so in my code editor, that is VS Code, I've created my application, say state, and here in my source folder, I have my app.js file. Now here, I'm going to get rid of all the unnecessary code that I'm not going to be using. Also, I suggest you go through the React installation on Windows video to help you get started with creating your first application. So let's create our class component, say class app extends react.component. And inside, I have a render method that returns an HTML tag. Let's display a message, welcome. Let's follow the JSX conventions and enclose all the HTML tags within the div tag. So I say div class name equals app. We also have to import the app.css file, import app.css. And so we save it, and if you look at the browser, we have welcome. Now let's beautify our code. To do that, let's add some styling. So here in my app.js class component, I say styles equals, and I say font style, and I set it to say bold, and I say color, say teal. And here in my h1 tag, I say style equals this dot styles. So let me save it. And if you look at the browser now, we have welcome in teal and it's bold. Now let's go ahead and create a class component to understand state. So first I create a folder and I call it components. And inside this folder, I create a class component and I call it new comp.js. And I use the snippet RCE to create the class component. To give you an insight into what we're doing today, we'll display a message asking the user to subscribe to Simplilearn. Once the user clicks on the subscribe button, we instruct them to click on the bell icon. And finally, we display a thank you message. Now to do all of this, we're going to make use of state. And as mentioned earlier, we initialize the state object in a constructor. So let's use the snippet rconst to create our constructor. Now in the state object, we initialize a property, let's call it message, and we display a message saying subscribe to Simplilearn. Let's save it. And here in our render method, let's say class name equals app, and let's create an h3 tag, and within the tag, I display the message. So I say this dot state dot message. Let's save it, and now let's import it in our app.js component. So I get rid of export here, and here I say import new comp from components and new comp, and let's define it here and say new. So we save it and look at the browser, it says subscribe to Simplilearn. Alright. Again, to make our code look more presentable, let's add in styles. So I'll just copy the same styles that I've added here and I paste them here, and instead of bold, I make it italic, and I change the color to say purple. And again in my h3 tag, I define style and initialize it to this dot styles. So let me save it. And now if you look at the browser, it's in italic and it's in purple. Okay. So moving ahead, let's create a button that reads subscribe, and once the user clicks on it, the button should read subscribed, and the message displayed above should instruct the user to click on the bell icon. To do that, let's first create a button. The message that I want the button to read is subscribe. However, this message gets changed once the user clicks on the button. So instead of explicitly mentioning subscribe here, I create a prop. I say sub and I say subscribe here. And back in my render method, I say this dot state dot sub. So let's save it. And if you look at the browser now, you have a button which displays a message subscribe. Now once the user clicks on the button, the message displayed should change to click on the bell icon to never miss an update. So let's create an event handler for that. So here, button on click, I call another method, and let's call the method button change. Okay, so this method should update the state and change the message and sub values. To do that, we make use of a setState method. Now a state can be updated in response to event handlers, server responses, or prop changes. Now all the updation can be done using the setState method. Now this is the general syntax used by the method. We'll however look at this further in the demo. Now the setState method conventionally enqueues all the updates made to the component state and instructs React to re-render the component and its children with the updated state. Now let's go back to our code editor and look at the working of this method. Now here I define the arrow function, button change. If you are not familiar with arrow functions, I suggest you read up on them. And this is the general syntax. And here I say this dot set state. And inside I change my message to hit the bell icon to never miss an update. And my sub value changes to subscribed. Let's save this. And now if you look at the browser, when we click on the subscribe button, the message changes to hit the bell icon to never miss an update. So moving ahead, let's use a bell icon so that the user can click on it. Once he clicks on the image changes and a thank you message appears on the screen. So for that, I have two images. I have bell A and bell B. So I drag and drop both the images in my components folder. Alright. Now let's import these images into our new comp.js file. Here I say import bell A from bell A.png, and again I say import bell B from bell B.png. Alright, let me save it. To display the image on the screen, we make use of the image tag. Now this tag has two attributes. One is the source attribute that specifies the URL, and the other is the alt attribute that specifies an alternate text for the image. So here in my component, I make use of a paragraph tag that will help display the image in the next line, and then I use the image tag. Now since my image changes once it's clicked, I have to define a property and pass the event handler click that will update the image. So here, before specifying the source, let's go back to our state and define another property that is image URL, and let's set it to bell A, since that is the image that I want to display first. Let me save it, and here in my image tag, I say source equals this dot state dot image URL. And then we have the alt tag, and I do not want to display any message, so I leave it as it is. Now let's save it, and if you look at the browser, we have a bell displayed. However, now let's change the dimensions of the bell. I do not want such a huge bell. So back in my VS Code, I define style with width, say 30 pixels, and a height with again 30 pixels. Let me save this. And now if you look at the browser, we have a smaller icon. So once the user clicks on this image, the image changes and the message displayed here gets updated. To do that, we'll have to define an event. So let's go back to our VS Code, and here in my image tag, let's say on click, I define a method, say this dot image change. And now we define this method here. I say image change. I make use of an arrow function again. And again, I use the setState method. I update the image. So I say image URL is now set to bell B. And the message is updated to thank you, happy learning. So let's save this now. And if we look at the browser, we see the image, and once clicked on it, the image gets updated and the message changes. So finally, let me refresh the browser once and show the full execution. Let me refresh. Following the instructions, let's click on the subscribe button. And now it says hit the bell icon, and once I do that, the image updates and the message changes.
So let's jump to the coding part and see what we are going to create. So before we jump, let's open our terminal to install some commands. Here I have already created my React project. You can also create a React project. It is very simple. Just type a command npx create React app and then the folder name. In my case, it's and just enter it. It will create a portfolio app for you. So I have already created, so I'm not gonna enter this. So let's cut this. After that, let's begin with our code. What you have to do is write a command npm react install first, install react router DOM, and then press enter. It will install React Router DOM in your system. But before install this command, you must have installed npm in your system. So let's move forward and enter. I have already installed this command, but just to tell you guys, I'm entering. Okay, meanwhile, it'll take a couple of seconds. Meanwhile, I'm going to create a folder inside this source, and let's name this folder and let's clear this terminal. Now what we'll install is material UI icons. So for that, the command is npm install add material /icon. You'll press enter and it will take a couple of seconds again more to install this command. I have already installed these commands in my system, but just to clear you guys, I'm installing them again. So let's start our development process. Inside this, okay, now let's open this app.js. Inside this, I'm going to import React. After that, I'm going to import the CSS file of this app.css. Import dot app dot scss. Okay, now let's close this. After that, let's create a function app. Inside this, let's return if class name app. After that, let's close this. Yeah, okay, fine. The main part is to export this file. So I'm going to write export default app. Let's save it. Now let's again open the terminal by just pressing Ctrl plus backtick, or you can just go here and just type new terminal. Here we'll write npm start. It will start the React project for you, but let me write here. Okay, it's working fine. So let me show you that it's create another. Okay, let's create h1 tag here. Here we'll write hello. Let's save it. Now let's open your hello from Simplilearn. So it's working fine. Let's just delete this part here. Now we are going to start with our first component, which is header.
inside this component we'll create a part header .js. Okay, let's create another folder. Let this components folder. Let's create another folder. Let's name it styles. Here we'll add all our CSS or SCSS files. So let's enter. Inside this, let's create a file header.scss. So I'm writing SCSS because I'm using this file syntax. You can also use CSS syntax also. So let's move forward with header.js. React. Okay. Now let's write const header here. Let me check that. Okay, fine. Add a function which will run and return of div. Create a div here to make it look. The most important part again is to export this file. Don't export these files, it will not run. So exporting file is very important. Let's save it. Now let's import our CSS file, which is header.scss. Got to add these. Styles, inside the styles it's header.css. Yeah, let's save it now. Okay, fine. Let's open this. Let's give the universal styling here first. So by writing star, it means it implements on everything. So we'll give margin of 0, top, or let's first padding 0, box sizing, the box, let's save it and do that. Add the pictures, so I'm giving every let's save it. Okay, fine. Let's work on this. Open your Node.js. Let's save it. Let's go to index.js. Here, as we have installed React DOM, so we'll write React. Okay. Browser router from as let's make use of router and routes. Okay, fine, everything's look good. Let's delete this Right. Router. This routes will write inside there. Let's save it. It's saying can't fetch the document part. Let's see and find the issue. Okay. Yeah. Let's save it now. It's working fine now. Okay. Node.js is defined as but never used. Okay. Yeah. Here we'll start later. But let's fix this part also. Let's give it a let's add here the home component. Let's add the home component. Right here the element. Let's save it now. Let's fix this issue. Route is not closed. Okay, it's working fine now. Yes. Now everything looks fine to me. Let's close this and let's work on the header component. Inside this header, let me just do this here. Okay, yeah, everything's look good now. After the header part, let's create another div, class logo, header. By the end of this tutorial, you'll love the output of this program. So just be with me and you'll see an awesome portfolio for you guys that you can use in your colleges, or if you're a professional, the CV app will be a boom for you guys. So we're creating the header part. So inside the header, what should be the positions that we are going to use here? So I'm going to add home, about, portfolio, pages, blogs, contact. These are the things that in a basic portfolio are mandatory. So we are going to use that only. So in this H1, I'm going to write my name. Let's save it, or let's write here let's save it. After that, I'm going to create another div. Okay, not div, navbar. Inside this navbar, let's create an ordered list. Inside this, now let's create a div of container, or let's name it as closed. Closed. Okay. Inside this closed, I'm going to use the function close class name as, let's name this as close. Let's close this. After see, I think fine. Okay. Okay. Now let's just not do like this. Let's just close. inside the header app.js. Inside this, let's add header. Let's import our header. Let's save it. Let's import manually here. Header from header component. Let's save it. So let's see now. It's saying okay, the close. We haven't imported this. Let's import this. Import close. Okay, let's save it now, and let's see everything looks fine. Okay, it's not working. It's taking time to install. Let's just move forward. After this, inside this ordered list, we'll create a live component. Inside this, we'll write link. Let's save it now again. Let's import this one also. Import link. We'll import from React routed down that we have installed. React routed down. Let's just save it. Okay, it's working fine now. Simplilearn X. Okay, fine. It's started to look good. We have to add things here now. Inside this link part, let's the link here. Define here too. So, and after that, let's write first part home. Okay, it's fine. Let's copy this component and reuse this. 3, 4, 5. Here we'll write the home, about portfolio, right blogs, and then contact page. Let's just save it. It is successfully compiled. So these are the things that we have added. Now the next step is, let's add the to do is, after this new bar, create a div. Inside the this, let's name it change. Let's add the DDUI icon here of menu outlined. Yeah. Inside this, let's give it a class name. Menu. Okay. let's close this. Okay, let's save it, and exporting is done. Yeah, okay, it's already been added. Now you can see the feature of React. This is where you use the material UI icon when you book outline, and automatically it's been called inside this. Let's now just run this and see. This is the icon that we needed. Okay, fine. Isn't it looking cool right now only? Okay, let's work on the header.css or SCSS. You can use whatever function that you like. Now, the first thing I'm going to do, inside this header, we'll give it a vector. %. Display, let's make the display flex only, because it should come on horizontally. So line item center, you can change the position. Let's write position absolute z index 1. Okay, let's now edit. The second thing is header, after that header logo. Okay, fine. Header, inside this header logo we'll give it a margin of, I guess, it's fine for it. Let's see. Okay, Simplilearn logo we don't need like this. We will make this like with the Simplilearn logo here. After that we'll make home, about, portfolio, blog, and contact here. So let's move forward with the code. Bar 0 and auto. We are making this profile as responsive, so that's why we have used. So I have also used UL ordered list. So we'll make display flex, and let's inside this only called for li. Let's give it a line style of none. So next we'll give it a margin 1 rem. After that it looks good. Yeah. Now after the li we have used, okay, fine, let's make it as 1 second, check. So let's write text. So one thing I forgot to tell you, that if you're using like CSS, here I'm using SCSS. If you're using CSS, you can just write after this UL tag, ordered list, then you can use like this UL li, and inside that you can write, or you can just write li, and inside that these commands. You don't need to write these inside the ordered list only. Okay, now let's add the text declaration. Let me give you introduction. Give me a couple of minutes to add it. Yeah, let's see. Okay, fine. Let's write text declaration 1. For that, text transformation. let's write transform uppercase, color of this word is I don't need. Let's add this. After that, what does it? It's not. Everything's local. Let's add it the part like there. Let's add dot ginger. After this, let's just open this like this. Ginger. Let's make the display flex. After that, let's give it a margin of right of like 1.5 would be enough. Dot, let's write min, which goes inside this, I guess. Yeah. So in CSS, if this was the case, like this, we have created here like another class of menu. In that we have written, you have to write all the elements, okay, but we are using this as CSS. So inside this is the syntax that they follow. Okay, let's write cursor, pointer, margin of right, yeah, 1 is enough. You'll also get the source code of this in the description box. You can check it out. Okay, it'll be helpful for you. Just follow me throughout this video, and in the end you'll see an amazing portfolio for you guys. Okay, right, close, closed, okay, close. Portfolios are really amazing for like freshers to get a job, because in these kind of projects you learn so many new things. Okay, so let's just save it. Okay, these are pointers. Yeah, everything's look good. We have to give like more space here. If that did this, then let's write. Okay, everything's look good. Let's see, it looks fine. Let's add the hover effects. So the hover effects will be created in this anchor tag only, but let me just get it for you guys, so it will be more clearer for you guys. Let me just add a bold tag everywhere. Let me just copy this tag. Okay, fine. You will see it will be very bold. Now let's save it. It's working fine now. Okay, inside this anchor tag only, and that should be fetched by and the keyword name hover. At this, let's give it the border button. 3 pixels would be fine. Solid in color, and the red is my color. Let's save it and see what's the effect. Okay, as you can see, it's looking beautiful, right? just be with me throughout this tutorial and you will love the results. Okay, so let's just make this clean. Code should always look clean. Okay, if it looks clean, it can be read properly, anyone can read it properly. So after this close, we're gonna go with our code. I don't know why this cross is still looking. Let's delete this close. I have written the function here, but let's see, it's not fetching it right, I guess. No issues. I'll do that for you guys. Okay, let's see what's the issue here. Go to another file. Close. Okay. Fine. Everything's look good. Let's see the issue here. Clear the close. It's fetching right. Let's find out. Is this cross is still here? Let's open the code. Let's make this like this. Now let's save it. Okay, fine. The cross is clean. And have fuel. See, we can inspect. Responsiveness of the page. So if it will be like this. Tablet mode. Okay, fine, everything's it's not coming right. Let's make this. Okay. We need to work on this part also. Okay. Let's see where the issue is coming. So done. Okay, fine. We have to still work on it. Let's write here. Let's write this code again. Let's just save this file for now. After that, going after the return, let's write a command like const active and make our app with active. So React function. So we'll close this bracket. It's looking, it's showing error now, but state hooks function false. Let's write a function now. Const show new. Inside this, let's give it a function, and inside this step always active. This will do is strictly active. This is the meaning of this. Let's save it and see the changes. It's showing active is not defined. Okay, active is not defined really. It's not active. It's one error is still coming. Okay, fine. you have to updates. Okay, fine, everything will look good. Let's see what's the issue here. Const show menu. Show menu, it's not together. That's why maybe it's showing error. Oh yeah, now it's fine. Compile with warning. What's the issue now? Let's see, because finding errors and resolving them is very important for a developer. Increase your knowledge into the specific language you're working on. So whenever you get any difficulties in your code, just take help from someone, Google it, and you'll find the answer, I'm sure. Okay, let's find out. Show menu is assigned value but never used. Okay, let us use the show menu here. Okay, fine. Let's use the show menu inside this. Close. One click inside this show menu. Okay, fine. Save it. Let's see the output. Now let's inspect it. Rolling. Fine here. Okay. The tools filter list load source map cloud not load content. Okay, it's for us. Let's make this as center. It's not in center. Let's center only. Logo. Okay. List, no? Yeah. Flex margin inside between them is one is fine. The margin is fine. Let's make it 1.2 here. In between them is 1.2. Fine. It's not the border box 3% solid. Okay. Okay. Let's first change this part. Right on click, and then we click on this. It will add menu. Okay. And save it. It's compiled successfully. Space between them, but we can already do that. Let's just this is working fine. Let's here write a function. Save this. It's right. Let's just complete this CSS file now, because it should be completed by now. Let's write media, and set this max height. Okay. Max height would be fine. Max would be okay. pixels only. We can increase it. Okay. Header, justify content, space between. Display flex on, let's run here. It should run inside that function. Okay, fine. Understood. Translation is important. Second with ease. Okay. Now bar is done. Now bar active is also important. It will get active. It should respond with some actions. So we'll write display flex. It's time. That flex direction should be column, not row. Whenever we go into mobile apps and all, it should be. These are the little things that you should understand while implementing any project or something. But it's very tricky also. There's so many things that you have to understand. Set instead 0, but like fine. Background color is very important. Let's write background. Set this. Let's write white. Okay. Transition is important also. Millisecond. Please. Now it's fine. Let's complete this. UL. Zero. Writing CSS is very lengthy process, but it's cool also. We'll learn so many new things by implementing. Okay. Let's give it a mesh RAM. Okay. Fine. Now let's see li. That's right. Let's give it a margin. Let's do 2 RAM. So that let's just open another one and end it. Let's make it more clean here. Okay, it's fine. Inside anchor tag, we'll write font size, which is 20 pixels. Color, which is black but not like. Okay, let's find black only. 8 folder. Let's save it. See. Now let's inspect. Now, as you can see, the mobile version of this is like this. Isn't it cool? Okay. Everything look cool and responsive. Coming back to our code. Let's complete this one. This is done. This is done. Let's work on the changes here. Changer. Yeah. Inside this changer, we'll write. And okay. Let's write menu display. Fine. Now we'll like closed one and close. Okay. Then display block. After this one, the block. Margin left point 50 rem. To this, let's write another medium. Okay, inside this, to do all these changes, let's just copy this from here. Okay, I'll just right here. Max. Would be 350 pixels. Now it's counting from here to here only, so 1 and here we have to copy. Just copy from here. Okay. Let's just paste it inside this. Everything look cool. The next thing we're going to do is like create another one. Changer. Inside this dot menu. Inside this display not inline block. Margin right. Let's save it and let's see the header now. Isn't it looking perfect? Yes. Going forward, having increased the margin from here to 1 or 2 to 25 rem. So now it will look like this. Okay. Now we'll work on this main part. For that, let's cut this part. Okay. Let's here add a new file called .scss. CSS, you can write just CSS. Okay. Inside this component part, we're gonna write another file inside this. Let's name it as main.js. Okay. Now we have created 2 files here. So let's open our main file. Yeah. Let's import React. Yeah. After that, let's write const basic function of React. It's just the syntax only. So at this, let's return the dev empty. Let's write empty dev. Okay, it's not this. That's why it's yeah. Inside this now, I'm gonna write start exporting default. Okay. Now we'll import one on the file, CSS file of this. So we're going to write styles, the folder path, and the file name. Save it. I'll look the same. Let's move forward with our app.js. In here we have to declare that port main from components. Yeah, let's save it. Now here we write main. Let's save it. Okay, it's compiled successfully. Now we'll do what? I'm going to add one folder pictures that I have created inside this, but let me just create one basic structure of that. Let me just open my main.js file here, and inside this main.js we have to write some code. Let's just add the assets part here. Okay, just do this, and inside this let's add it inside the source, or like assets inside the source. Inside this source part, it will be fine. Yeah, now I have added 3 pictures here. To write more pictures, so let me just copy some images. Okay, in a couple of minutes. Coming back, let's make this inside this main. Let's create another class main. Container. Let's close this. Container div. Class name of content. Let's just close this one. Another div of class name text, which will be used in this. Let's make it inside the p tag. Hello everyone. Another above. Above. Okay, let's create another paragraph tag. And PR symbol here to look more aesthetic, and designer. Okay, let's save it and see the output. Is it looking good? Right? Okay, so everything is lost because make it inside this header also. So let's see the thing we are going to miss. So we are missing here. It's app.js. So then I have called for this one. Okay. Inside this header, after this header, let's just move here inside the header yes. Let's out. Okay, tiles are done. Let's just focus on the thing which is we are creating. We'll resolve it in a while. Okay, so this is done. Let's just create another div inside this class name to add the icons. So let's make this class name as icons only. It will be helpful for us only to write all the CSS properties for this. So I'm gonna add the CSS directly, so it'll save your time. You'll find the code in the description also, and I'm going to show the code here also, so if you want, you can just copy it. Okay, let's write Facebook. The class name of Facebook is also on. And let's, okay, it's not that. Let's copy this from now. After Facebook, it will be link and fine. Okay, we haven't called it yet. It's being material UI icons. So yeah, let's call them Instagram, Facebook. Link is right. It's not been called up here, so that's why. Okay, and now it's the LinkedIn which is left. So now save it, and you'll find all the logos here. Isn't it looking amazing, right? Okay, I'm sure you're loving it now. Here we'll add the picture. So for that, I'm going to add, first let's just complete this part only. Let's add in here for like hire me. Whenever anyone will click on that hire me button, the CV will automatically gets loaded. Okay, let's just work on that part. Let's create another div class, and if you guys find any difficulties, you can just comment it down. I'll be happy to help in any you guys want in this front-end development. I am going to help you guys. Oh, just talking in there. HIRE. That'll be fun. Okay, let's just close this bracket now. To this, let's create another div class name buttons. Let's just add one more here. button. That's right. That's right. Connect on with me. That's right. That. Contact one we are going to write in that folder. So let's write C. It's fine. Okay, let's save it. Inside this buttons, I'm going to do links. Okay, now buttons is fine. Let's just delete it. That things look. Save it. See the output. Oh, fine. I'm loving it. Let's just move forward. Okay. See, you have me inside this. Let's add a div class name. Inside this class name, we'll write main. Inside this, we're going to add the image source. Let's write you. Okay. The error menu is not defined. Okay, we'll define it in a while. So I'll just complete the process to define this part also. So we're going to import anu assets. The spelling of that folder was ASS EDS. In the file name that we are, let's write the proper address. Let's write profile to .jpeg. Let's save it. Oh, it's coming very big. Let's add different picture here. Let's write no working, it would work. Gee, let's save it. It's coming fine. Make it here also, but let's save it. Everything's looking perfect now. We'll make it here like here. It'll be fine. Okay. I have already added the CSS part. You can just see here. Okay. It was same that I have showed you earlier. Just a few new things already. I'll tell you if I have added anything. Well, all look good. Two. Yeah. Okay. Things look good only. But the buttons is right. The image is here, so I'm gonna give it. It's 7. So some line is coming in the down, so that's why I'm doing this. A little up. From here to 45. Yeah, this is looking good. But the picture is here, so it's taking this part only. So it's right for us to just not intervene in this part. Okay, this is looking good, clean and good. Let's move forward. Okay, let's move forward and create a part here in this component file called section JS. Okay, inside this section.js, and let's just now only create new file called contact. Let me just write. Okay, contact.js. Let's save it. Okay, we have written, so we have to work on these two files also, but let's just start from here. I've also added these files in an order, so let me show you guys first. Here I've added these files, like contacts comes in the second. Okay, let's just cut it from here. First the header will come, main page, section, and then the contact. Like this is layer, right? Save it, cut it, we don't need this. Header file is done, main file is also done, in the section and contact. Let's start with the section part. Okay, let's complete this by just writing import React okay. Let's write styles section dot section dot css. Yeah, looks cool. Now we're going to import for one more feature, which is, let's write unknown2 assets, and inside that it will be, let's see the picture here. Let's add this picture. Yeah, profile, pg. Have to call this inside this function that we're going to write. First let's write, just cut it, const section. Inside this section we are going to create a function, add arrow function, set this return there, and export. Basic structure is and the file name. So the basic structure is ready. Okay, let's just write something. Let's see, it's working. Okay, let's just add these commands here so that we can see. let's write class name. Let's write the class name sections only. Let this sections. Let's create div. Class name sections container. To that div class name sections section image. Okay, yeah, fine. Now we're going to add the image with the source. What was the source? 2. Alter this image empty, then let's close this. Okay, let me just see here. That's fine. Okay, yeah, okay, fine. We are working on this part. Let's see. Okay, yes, let's write the index function now. That, yeah, but let's just work on this part first, then also we can switch to contact page, and we'll complete this part, then we'll do that. Okay, for now let's work on this section part only. After this section part, let's now add, okay, fine, let's create the div class name section, the content that we are going to see. After that, h1, this I'm going to write my name, a little description about me. Okay, that experience, backend development. After that, this only. Let's write some stuff like script development, like this only. So we'll copy it from here. Yeah, then you can write anything of your choice about yourself. I'm gonna write Java, Python. I'm also into project management and that, but it's like UI and UX designer. Okay, let's just save it. Moving forward, everything looks fine for this. Save it. Yeah, okay. With one warning, let's see the issue. State is defined but never used. Let's find out. Now that we have completed the rest of the part, let's complete the last part, which is contact.js part. In this, let's create the import React from React. Now, let's import the CSS file here. Let's write command.styles. Inside the styles part, it's my CSS which I have created just now. After that, let's not add anything else. It's fine for now. Okay, let's create the functions, fat arrow function. Now create, return, div, export, default, contact. Yeah, everything's looks cool. Yeah, now let's start with the class name contact. Let's say contact. You'll love the result in the end, I'm sure. Link to, just to link the app, I'm going to add the empty file path, so it'll get linked in the arrow back class name of arrow. Let's just close this. Okay, everything looks fine. Okay, yeah, that's the reason here. Yeah, but still we have to import this link from React router down. Link from React router down. Let's save it. Now, okay, yeah, we have to import the arrow back from material UI. Arrow back from at icons. Let's save it. Okay, fine. Everything's look good now. Okay, yeah, just create another div, class name inputs, where the user will input their detail, or if anyone wants to send a message or something, inputs. After that, I'm going to create one h1, which will be the header contact me. Okay, after that I'm going to create input types, which is input type, which is text, and the placeholder will come inside that with name. Let's close this and let's copy this few times. Copy, paste. Okay, the second thing that a user wants is email, and the third thing that I want is the message that they want to send or something, and the class name is messages, because this box gonna be the big one. No, the name one is like the row type, email one is also the same, but the message box should be big. So that's why I have written here the class name. So I'll go and edit it inside my CSS file. Inside this, let's create a button of send. Let's save it. Now I'm going to open my contact CSS file. Have to add some CSS. Contact. Let's give it a width of like 100%, height of 100%. Then the background color should be white. White would be fine. After that, let's write a tag. Inside that, the color should be gray would be fine. Yeah. Text decoration we don't need, so we're gonna write none. Dot input that we just taken. That was inputs, right? Okay. So let's write here width of 60%, height of 80%, margin of 0 and auto, and then display should be flex direction because of column, and alignment item should be center, and then justify content center. Yeah. Now what we gonna work on the h1 tag, right? h1 inside this, let's give it a color. I have noted down the color. Let's write it RGB 82, 76, dark red kind of color. Okay, let's work on the input tag now. Let's give it a width items center, padding should be 20 pixels, outline and the border should be also. Let's work on the last few steps of this application. Message, padding bottom 10 rem. After that, let's work on the button part. Padding will give of 10 pixels and 40 pixels. Background color, or just background only. Cursor always pointer. Chin, top, yeah, border of 1 pixel solid. We have to declare the color also, so we're gonna give it a color blue. Yeah, okay. Now color is defined. No, it's not defined, so let's give it a pink, but let's give it a little darker. Yeah, this is fine. Text uppercase. Let's forward, add media, max height, max width. width will start with 550 pixels. Inputs. Inside this input, I'm gonna take width of and then the input size would be padding and then 15 pixels. Let's save it, and okay, fine. Inside the app.js, let's see, we have declared the contact page here. Let's save everything. Now it's successfully compiled. So this is the final step of our application. So these are the header part, main part that we have created here. So you can see the hover effect. Is it looking nice now? You can just write a mail, email ID, message, and just send it. Isn't it looking amazing? You can always improvise the projects we have created. So you can also improvise this. So with this, we have reached the end of this video.
Now let's say you're using an Instagram application. Every time you refresh, new content is loaded onto your screen. You can like a picture, add new ones, search for profiles, and do much more. Although it provides a seamless user experience, there's a lot that goes in the backend as well. So every application typically consists of the front end, the backend, and the database. Together, they form the full stack. So what exactly is front-end development then? Now, front-end development is the part of web development that develops and creates the website's front-end elements or features. Now, a front-end developer in a sense is responsible for everything that you see. It could be text, alignment, navigation, colors, etc. Now, the main objectives of front-end development is responsiveness and performance. So now that you know what front-end development is, let's look at the skills that will help you land a job. First up is the foundation. So first things first, to become a front-end developer, you need to start with HTML, move on to CSS and JavaScript. Now these are the actual fundamental languages for front-end development. HTML is used to structure our web pages, CSS is used to make them beautiful, and JavaScript is used to make the program run and add interactivity. However, knowing just these will not help you. You will have to learn the second important skill, that is frameworks. Now there are several front-end frameworks that make development way easy. Now to name a few, or the most important ones, we have React, there's Angular, Vue, jQuery and Ember. Now I'm sure you must have heard of these frameworks. React is a UI development library written in JavaScript. Although React is just a library and not a framework, its usage is rampant nowadays. React goes beyond simple UI and has many extensions like Flux and React Native for complete application architecture support. Talking about Angular, again, this is an OpenScript JavaScript framework based on TypeScript. So as a framework, Angular offers advantages and it also provides a standard structure for developers in a team to work with. It allows users to create huge applications that are easy to manage. Talking about Vue, it is also an open source JavaScript framework and is again used to build user interfaces for single page applications. Now I'm sure you must have heard of jQuery, which is again a trendy JavaScript framework and an application development platform. It is leaner, it is fast loading and comes with features that make life of a JavaScript application developer more accessible. It is used more and more to be the foundation and the primary driving force of web development today. And lastly, we have Ember, which is again an open source JavaScript client-side framework. It comes with built-in environment with fast rebuilds, auto reload and a test runner. So these are some of the frameworks that you're expected to be proficient at. Now the third skill that is crucial is version control system. Now we use version control systems to track our code, history and work more collaboratively with others. That's why you will find it in every job description. Now there are multiple version control systems available in the market today. There's Git, there's Subversion, etc. So just focus on Git, which is the most popular one, and don't worry about other version control systems. Knowing these version control systems will definitely add more credibility to your resume. The fourth skill that is crucial is the CSS preprocessor. Now, to give you an insight into why we need preprocessors, CSS is an old language and it has its own limitations. If you write CSS for medium or large size applications, your code starts looking messy. So every time you want to change something, you end up breaking something else. Instead, you can make use of a CSS preprocessor. Now, a preprocessor is a program or a tool that lets you generate CSS from a different language that is better and more compatible than CSS. So instead of using plain CSS, you can use another language that looks pretty similar with CSS. We give our code to a CSS preprocessor that converts it into plain CSS which every browser understands. That's the purpose of CSS preprocessors. There are many of these available today. There's Sass, Less, and Stylus to name a few. And lastly, the most important skill required is testing and debugging. Now, a very important aspect of web development is to make sure that the end result is error-free, free of bugs, and seamless experience for the user. Therefore, the ability to test and debug a website is another essential skill that a front-end developer needs to have. There are various methodologies that can enable front-end developer to make sure that the websites or the product not only looks good but also functions smoothly. So although these are the top 5 skills that a front-end developer must possess, he must also have good communication and interpersonal skills. A good understanding of APIs and how the app needs to behave is crucial to make a good developer. So you must be wondering, how can Simplilearn help you with this? Well, you could get started by acquiring a Simplilearn certificate. All you need to do is head to our Simplilearn page and type in Full Stack Developer. You'll get a brief overview of the course and what it offers. If it suits your requirements, you can go ahead and enroll for it. Having this course certification will definitely boost your resume. So what exactly is Node.js? Now consider a scenario where a user interacts with a web application. The user only interacts with the front end of the application. But there's a lot of work that goes behind the scenes. Now in a web application, there's a front end, a server, and a database. The front end is developed using JavaScript and frameworks like Angular and React, while the server is built on Java, PHP, or Node.js, and the backend database that stores the data usually consists of MySQL or MongoDB. So Node.js is an open source, cross-platform JavaScript runtime environment for running server-side applications. It is used to develop I/O-intensive web applications like video streaming sites, single-page applications, online chatting applications, and other web applications. It is used by large, established companies and newly minted startups. Node.js was developed by Ryan Dahl in 2009, and at the same time of this session, its latest version is v13.3.0. Now that we know what Node.js is, let's go ahead and look at why it was so prevalent in the field of web development. Here are a few points. First up, Node.js is extremely fast. Being built on Google Chrome's V8 JavaScript engine, its library is extremely fast in code execution. Node Package Manager has around 50,000 bundles for developers. So whatever functionality is required for an application can be easily imported from NPM. All APIs of Node.js library are asynchronous, that is non-blocking. It means a Node.js based server never waits for an API to return data. Node.js dramatically reduces the processing time while uploading video and audio files. It is also an open source platform and is easy for beginners for web development. The above reasons more than justify the popularity of Node.js platform and why it is being adopted by a large number of organizations and businesses today. So now moving on, let's familiarize ourselves with the parts of Node.js. Node.js consists of several components. Now let's look at them one by one. First up, we have modules. Now modules are like JavaScript libraries which are used in a Node.js application to include a set of functions. Now we can use required function with a parenthesis to include a module in a Node.js application. Node.js application has many modules to provide basic functionality needed for a web application. Some of them could be HTTP, util, fs, URL, query string, stream, and zlib. Next up, we have console. The console module provides a simple debugging console that is similar to the JavaScript console mechanism provided by web browsers. Now the console can print messages to stdout that print standard output messages and stderr to print the error messages. The next component is cluster. Now Node.js is built upon the concept of single threading programming. A single instance of Node.js runs in a single thread. To take advantage of multi-core systems, the user will sometimes want to launch a cluster of Node.js processes to handle the load. A cluster can be added to an application in this way. Here's a small code for you. The next component is global. Now, global objects in Node.js are available in all modules. Now, these objects are functions, modules, strings, etc. Some Node.js global objects are mentioned in the table. You have dir name, that is a directory name, file name, exports, module, and require. The next component is error handling. Now, Node.js applications experience 4 types of errors. We have the standard JavaScript errors, system errors, user-specific errors, and assertion errors. Now, errors in Node.js are handled through exceptions. Now, for example, let's handle an error that would occur when we divide a number by 0. Now, this error would crash the Node.js application, and so we should handle this error. Here's a small code for you. Next up, we have streaming. A stream is an abstract interface for working with streaming data in Node.js. Streams are objects that let you read data or write data continuously. There are 4 types of streams. First one is the readable. These are the types of streams from which data can be read. Writable, these are the types of streams to which data can be written. Duplex, these are both readable and writable streams. Lastly, we have transform. These streams can manipulate the data while it is being read or written. Moving on to the next component, buffer. The JavaScript language has no mechanism for reading or manipulating streams of binary data. Buffer is a module that allows handling streams that contain only binary data. An empty buffer of length 10 can be created by this method. Next up, we have domain. Domains provide a way to handle different I/O operations as a single group. Domain module intercepts errors that remain unhandled. There are 2 types of methods that are used for intercepting these errors. Firstly, we have internal binding. In this case, the error emitter executes its code inside the error method. Next up is the external binding. Now here, the error emitter is explicitly added to a domain via its add method. The next component is the DNS. The DNS module enables name resolution. For example, it is used to look up the IP addresses of host names. DNS module is used to connect to a DNS server and perform name resolution by using the method dns.resolve. The DNS module is also used for performing name resolution without a network communication by using the method dns.lookup. The next component is the debugger. Node.js includes an out-of-process debugging utility accessible via a V8 inspector and built-in debugging client. This Node.js debugger is not feature-packed but supports simple inspection of code. It can be used in the terminal by using the inspect keyword before the name of the JavaScript file. In order to inspect a file, say myscript.js, you can use the following method. Now that we are familiar with all the major parts of Node.js, let's go ahead and learn about the Node.js Express framework. Express is a flexible Node.js web application framework that provides a wide set of features to develop both web and mobile applications. You can assume Express as a layer built on top of the Node.js that helps manage the server and the routes. Now let's have a quick look at some of the core features of Express framework. It is used to design single-page, multi-page, and hybrid web applications. It allows setting up of middleware to respond to HTTP requests. It defines a routing table that is used to perform different actions based on the HTTP method and URL. It also allows dynamic rendering of HTML pages based on passing arguments to templates. Now moving on, let's take a quick example of a simple Hello World program. Now this is developed using Express framework to gain a better understanding. Alright, first up we have the var express. Now this is used to import Express framework into our Node.js application. Now the app.get method is a callback function with parameters request and response. The request object represents the HTTP request and has properties for the request query string, parameters, body, HTTP headers, etc. The response object represents the HTTP response that an Express app sends when it gets an HTTP request. Now the application will listen to the defined port, which in this case is 8081, and variables host and port will contain the address and the port respectively. Lastly, we have the console.log, which is used to show the address and port in the command prompt. So this is what the command prompt would look like. And finally, the output is displayed on the web browser. Having learned about the Express framework, now let's move on and look at the Node.js use cases. Now it is no doubt that Node stands out for its speed and intensive data exchange. So top industry leaders like NASA, PayPal, Netflix among others incorporate Node.js. First up, we have Netflix. The world's leading internet television network with over 117 million users is one of the top companies that trusted their services to Node.js. The reasons why the company chose to use Node.js were application scalability and data-intensive application. Now you must be wondering what application scalability is. It is basically the potential of an application to grow in time, being able to efficiently handle more and more requests per minute. And data-intensive application allows millions of people to stream Netflix simultaneously. Next up is Walmart. Now Walmart is the world's largest company by revenue with around 514 billion US dollars according to the Fortune Global 500 list in 2019. Again, the reasons why the company chose Node.js were asynchronous I/O and efficient handling of concurrent requests. Now asynchronous I/O, which is a form of input-output processing, allows other processing to continue before the transmission has finished. Node.js is able to efficiently handle concurrent requests with the use of thread pool and event queues. Uber. Uber is an American multinational ride-hailing company offering services that include peer-to-peer ride-sharing, ride service hailing, and food delivery. The reasons why the company chose Node.js were asynchronous I/O, quick iterations, and active open source community. As mentioned earlier, asynchronous I/O permits other processing to continue before the transmission has finished. Now quick iterations. Now Node.js is continually being updated and added new features that help in further improvement in the performance of web servers. And finally, active open source community resolves many problems that an organization may face in a particular scenario. Next up, we have NASA. Now, NASA is an independent agency of the United States federal government responsible for the civilian space program as well as aeronautics and aerospace research. The reasons why the company chose Node.js were reduced access times, handling of data-intensive tasks, and the fact that the servers are active 24/7. Now, NASA has lots and lots of data, and using Node.js has really helped them in reducing the access times. It is also continuously handling and working with large streams of data. Node.js is highly stable, which helps in keeping the server active 24/7. Next up, we have PayPal. Now, PayPal is an American company operating a worldwide online payment system that supports online money transfers as opposed to traditional methods like checks and money orders. The reasons why the company chose to use Node.js were the fact that Node.js has extremely fast build times. It allows tasks to be carried out with fewer lines of code when compared to other server technologies like Java and PHP. And Node.js, being data intensive, efficiently handles a large amount of data. Next up is Medium. Medium is a popular online publishing platform developed by Evan Williams and launched in August 2012. The main reasons why the company chose to use Node.js were A. Data-driven applications. Now these applications are ideal for being interfaced with Node.js servers. B. To run A/B tests. Now A/B testing is essentially an experiment where two or more variants of a page are shown to users at random, and statistical analysis is used to determine which variation performs better. Lastly, Node.js server maintenance is simpler than its counterparts. Moving on to the last topic of this session, industry trends. Now, Node.js developers are in demand across the globe since many companies are adopting JavaScript libraries. According to Forbes, it is one of the top 10 most in-demand jobs. According to NodeSource, the total number of Node.js downloads increased by 40% in the last 1 year. The use of Node.js in production has increased dramatically since its release in 2010. With early adopters such as LinkedIn, PayPal, and Netflix, among others, Node.js has seen an exponential increase in its use in web development. The popularity of Node.js is also accounted to JavaScript. Now, since JavaScript is the most popular language, as evident from a survey conducted by Stack Overflow in 2019, many developers can start working on Node.js library with not much of a learning curve. Node.js developers are being offered better salary options than other web technology developers. According to PayScale, the average salary of a Node.js developer in India is around 6,13,000 rupees per year. The average salary of a Node.js developer across the United States is around $105,000 per year. In this video, we'll help you install Node.js on your Windows system. So without further ado, let's begin. The first thing you need to do is download Node.js from their official website. So go ahead and type download Node.js. Navigate to their official website, and here you can see the 64-bit version. So go ahead and download that. Once the download is done, go ahead and run the downloaded Node.js installer. Accept the license agreement. Keep the default settings as it is. And then say install. So with that, we finished the installation process. Once Node has been successfully installed, the next crucial step is verification. Now this process ensures that Node has been properly installed. To do so, we first open the command prompt and then type in a few commands. To verify the successful installation, we type in this command, node-v. Now this command returns the version, and if it returns the version, it means it has been successfully installed. So here we go, it returns the latest version. Now the final step is to update the Node package manager. Now this npm is bundled with Node.js, which consists of all the repositories and packages required for development purposes. So to do that, type in the command npm install npm -- global. Now that we're done with the installation of Node, let's go ahead and implement a small program. For that, we make use of a text editor. In our case, we've installed VS Code. So go ahead and download VS Code. Once you're done with the installation, this is what VS Code looks like. So go ahead and click on File and create a new file. It's going to be a simple program where you're going to print a hello world message on the web browser. To do that, we make use of HTTP modules. So Node comes with built-in HTTP modules to transfer data across it. So for that, we make use of a require method. We create a variable first, say var HTTP equals require, and just say HTTP within single quotes. Now the HTTP module can create an HTTP server that listens to the server ports and gives a response back to the client. To do that, we make use of the create server method. So let's go ahead and type the code. Say HTTP dot create server, and internally it consists of a function. Now the parameters to this function are request and response. Now the response is basically used to write to the client. So we say response.write, and here we type in the message. We say hello world, welcome to this tutorial. Once you're done with that, you end the response. So the server listens to a port number to display the message. By default, it listens to the port number 8080. So we keep that as it is and we end it. Save your file, say demo.js, maybe demo1.js, and say save. Now to run the program, you have to open the command prompt. So open your command prompt and mention the path to your file. So in our case, it's our saved on the desktop. So cd desktop. And now to run it, say node demo1.js. Now you navigate to your browser and say localhost 8080. And here we go. Our message is successfully displayed.
So let's talk about the Node.js architecture and understand why it's so good. So to begin with, Node.js has what's called a single-threaded event loop architecture, and this allows you to be able to handle many concurrent clients at the same time. It's just a very flexible way of being able to scale up your support for many clients. And then in addition to that, we have the JavaScript event-based model along with the JavaScript callback mechanism that allows you to have this standard approach to being able to connect with and talk and discuss interactions between the client and the server. It's good to have these kind of standards where you're not using something that's unique to a specific framework or a specific technology. This just makes it so it's more accessible for everybody. So if we look at the actual Node.js server itself, everything centers around the concept of the event loop. And the event loop has an event queue, an operation completed via requests, threaded pull, and then it'll actually do the actual computation or the file system interaction. All of this interconnects in a nice seamless loop. The great thing again with Node.js is that it's not new technology. It's been around for almost a decade. It's very well tried out. Many of the largest websites out there are running Node.js. So let's now dig into each of the parts of the Node.js architecture. So let's talk about requests. So the way that the request works is that you have your framework such as Angular on the client, and that will then send a request to the web server. And there's many ways that those requests can happen, through web workers, through forms, and through other interactions. But at some point, a request is sent to the server. And so these requests can be for data, they can be for deleting data, they can be for updating data, they can be for interacting with services as mentioned before, but the goal is to have some kind of request. Now, once that request actually hits the server, and then we start actually getting into the queuing and threading process that centers around the event loop. And this is where Node.js really excels, because it's able to use that single threaded model to be able to manage from just even a few requests to tens of millions of requests. So it receives the actual request and starts the event queue. And this is where that single threading process starts, is by queuing everything up appropriately. And then it then maintains the threads within a pool. So you have the queuing process as one action, and then you have a threaded pool which manages those threads as well. And then we have an event loop, which goes through and actually receives and processes those requests. And then finally, what we're doing is we're actually then going to be interacting with a system, and that could be a database, it could be a cloud system, it could be an API file system, but we're interacting with something that's outside of the Node.js server. So the Node.js server itself is doing some actions on the server, but then it's also interact with things outside of its own server environment. And so let's talk a little bit about that workflow. So requests come in, they go into the event queue, and they get spiraled through the event loop. And then we have non-blocking operators, which are going to be doing the input-output polling, such as KQ, ePoll, and other services. And from there, we're also going to be then interacting with the threaded pool, and we're using the blocking operations to manage that threaded pool. And that threaded pool is going to now then go outside of the server and interact with something beyond the server. So whether that is a database or file system or API or microservice, these are the things that can be interacted with. So let's go through what NPM is. So NPM itself stands for the Node Package Manager. No great shakes there. As the name says, it's responsible for all the packages and modules that are bundled within Node.js. So the Node Package Manager itself really has two key functionalities. The first is that it is a central repository for all packages and modules, which you can then search through online. You can go to search.nodejs.org and you can find all of the packages and modules that are out there. The second is that it's also a command line or terminal line utility that allows you to install those packages. So you can actually go through and you can see the version management and dependencies within those packages, and you can control the packages themselves. So why would you use NPM? So NPM is really useful for being able to extend the project you're working on. So when you're building out a project, one of the concepts I like to use is the concept of Lego bricks. Big fan of Lego. And what's great about Lego bricks is that they're all individually by themselves, very small, very specific functionality. But if you actually get a whole collection of Lego bricks together, you can build like crazy cool things. So think of when you're working with the Node Package Manager itself, is that each of those individual pieces that you're working with, each of those individual packages are their own Lego bricks, and by themselves you can then edit and update and maintain that piece separately from the whole environment. As long as your inputs and outputs, really the piece where you snap the Lego in or when you connect the Lego to something else, are interacted and open and well documented, then you can actually then use those modules effectively throughout your project. So you can actually then be able to do that. You can do version control on your codes and dependencies. You can do testing very easily. And then once you actually get to the point where you go, yes, I want to release a new module, you can do that effectively using NPM, and it will actually go through and do the actual deployment for you. So let's go through the NPM installation. So the actual package manager itself is included with the installation of Node.js. So if you've installed and you're running Node.js locally, then you've already installed the package manager. But you can also access it through command line or terminal window on your data server or in your server farm or via the cloud. If you haven't now downloaded Node.js, here's the website where you can go down to install it, and there's Windows and Mac versions of that code as well with the installers, which allow you to get up and going very quickly. You want to be able to run the installer and accept all the default settings. To begin with, you want to kind of have the standard setup so that you are most familiar with the normal settings before you start getting to the point where you're a master and you're tweaking things. There is a way that you can open up the command window or the terminal window. And once you've actually installed Node.js, to verify that it's actually installed, you can write the command node-version, and it'll actually then pull out the version of Node.js that you have installed, and then you'll be able to see that you've got it actually up and running. And then you can also do the same thing for npm. You can do npm --version, and it actually will then show you which version of the Node package manager you have running, so you can actually take full advantage of that program and verify that it's actually up and running. Now, so we're actually going to go ahead and actually run a demo of using npm. And to do that, I've got 3 windows in front of me right now. So I have this window here, which is my terminal window, where I'll be doing all of my instructions. Then I also have a folder which shows where I'll be putting all of the files. And then finally, I'll actually have a text editor. In this case, I'm using VS Code because it's free, but you can use any text editor you like to be able to go in and show what the code that's been created by npm in the JSON file, so you can actually see what it looks like. And then we'll modify it a little bit. So first thing we want to do is we want to go ahead and create a new project folder. So I'm going to go in, I'm just going to move into, do change directory, and go into the project folder, and we'll see down here that we have an empty project folder, but for this one I'm actually going to go ahead and I'm going to create a new directory in this one, and I'm going to call this one Simplilearn. And there we are, we've created a new Simplilearn folder, and we are going to move into the Simplilearn folder. And so we're now in the Simplilearn folder. There's nothing in there right now. So the first thing we want to do is we want to go ahead and initialize this folder as a project folder for working with npm. Now to do this, you will have to have already installed npm. If you have Node.js, npm comes with it. And if you want to see whether or not you have npm installed, so you can just do npm -version. And that will actually tell you what the version of npm you have installed is. And it also verifies that npm is installed. So I've gone ahead and I've been able to validate that I have npm installed. So what I'm now going to go ahead and do is I'm going to initialize this folder. So to do that, just do npm init. And you'll see that the path is that we're already in the Simplilearn folder. And then when you do that, it's going to ask you some questions. So what is the package name? We're going to go with the defaults for right now, and then I can show you how we can edit those in a little bit. We're going to go with, just say yes to all of these just by hitting return. And you'll see here that we're going to create a new folder called a package.json folder. This is the instructions that we have in the folder. Do we want to go ahead and create this? We want to. And it's going to go ahead and do that. And we can see now in our folder here that we actually have package.json. So we go ahead and open this up with VS Code. Here we are. We can actually see what all of the information is. We can go ahead and we can actually go and update this metadata if we want to. I'm going to leave it as is for right now because I want to show you a couple of other things. So a lot of times when you're actually working with npm, And the reason why you're using NPM is that you want to take advantage of packages that are freely available in the open source community that are supported by Node.js. And one of those is a package called Express. And Express is a lightweight framework for building out web applications, similar in concept to Angular or React.js. I like using it, and it's also a great way to be able to show how we can install this using npm. So to install this, you just start with the command npm, and then you type install, and then we type the name of the package, and we hit enter, and it goes ahead. And what you'll actually see is a couple of things. One is we have a dependency in our package above. We also have, so this is in our JSON package, that is now a dependency that's written in there. We can also go in, and under our node modules, we actually see that we have, we scroll down, we should see Express. There it is, Express. Now, if we decide that we don't want to use Express, we can actually just come in and we can write command npm uninstall. I can type Express. Oops, I did a typo there, so let's try that again. npm uninstall Express. And a couple of things can happen. One is in our JSON file, the dependency for the Express file has now been removed. And we can also see that under our node modules, there are no extensions there. So this is kind of cool. This allows us to be able to see that we can easily add and remove packages. So let's just go ahead, and I'm going to install Express again. So install Express. Oops. npm install Express. All right, so it's gone ahead and it's installed Express. Now, one of the things that will often happen is that when you're working with a package, the actual JSON package, so you'll receive this file, and you want to be able to go ahead and install all of the sub-modules that come with it. So you can go through and you can manually install them like this, or you can actually run an install command so you can actually install all of them at once. I can just show you what that looks like, because we're going to actually go ahead and simulate as if we're going to install Bootstrap, which is another popular framework. Bootstrap. And we're actually going to go with, and then we'll save that. And what we'll see is under the packages that Bootstrap isn't listed in there. We do have Express. There it is right there. So we now come over to our new commands. We can actually write the command npm install, and now slight typo, let's try that again. Let's do npm install. Okay, it does help to save your file, so let's go ahead and let's run npm install. And when you do that, what we'll now actually have is not just Express, but we'll also see that Bootstrap has also been added. Now, I don't recommend that you use the star symbol, which will install the latest version of Bootstrap, because you obviously haven't tested your application against that, but it gives you an idea of what's happened here. Now, if we want to, we can actually go in here and we can say uninstall Bootstrap, and it will actually remove that from your JSON package. So there we are. That's how you work with using npm, from getting started with a setup for a base initialization of your package, going through to creating the first package, being able to set up and control the naming convention for each of the items within the metadata that provides the instruction for the package, how you can then put in dependencies such as Express and Bootstrap, how you can install them and remove them, and actually do all of this through command line. If you have any questions, please let us know. So let's kind of jump into the Express.js framework. So Express.js is a really flexible Node.js and web application framework. It is just something you can spin up very quickly and build both web and mobile applications. Just a really great tool. I use it all the time for building up my own applications. The thing that's so great about it is it's really simple, so it's not going to be have all the functionality that you'd have in maybe a larger scale HTTP service. But with that said, it does come with a lot of functionality that allows you to not only create websites, but you can also do APIs and other routing calls. Very, very nice. So let's go through some of the features that Express.js have. So as I mentioned before, it allows you to build simple web applications, and that can be either a single page application or a multi-page application. It also allows you to do middleware requests and responses. So for instance, if you want to do an API and have that be part of your middleware, you can actually set that up real quickly. In fact, in the demo that we'll do later on, we'll actually be building out 4 different API calls that you'll be able to do, and you'll be able to see how you can use Express.js for that. And that in then turns allows you to be able to see how Express.js can help manage some of the routing of the different HTTP methods and that you'd be using via URL. And then finally, it's just a great way of being able to dynamically test the work that you are developing. So you can actually build out a solution and test it right away in Express.js, have it in a single packet, and then once you get to a certain point, you can then check in the whole packet, even have it as part of your container, and then check that into your main project. And then if somebody else wants to then take on the work, they can then just pull that in. So let's kind of go step through a basic example. So here we actually have a full script for creating a simple hello world. And this includes installing Express.js, defining the ports it's going to run on, as well as a basic piece of code. So the first thing you want to do is actually go ahead and define how you want to install Express.js. And this is called the very first variable, which is requiring that Express be installed as part of Node Package Manager. npm will then pull in the latest version of Express. If you need to define a specific version, of course, you can do that. In this example, we're just going to pull the latest one. And then we'll go ahead with the second line, which will then install Express. And when you do it once, you'll see how quickly it installs onto your local development machine. The next parameters are actually a callback function. So if something actually happens when you go to the website where we're going to run our web application, you want something to pop up. And in this instance, we'll say hello world will pop up. The third block is all about where you would actually go ahead and host your code. So in this one, you'll see that the server is going to listen to port 8081. So that's what that function actually there defines. And then you can either put in a specific host address. In the demo, you'll actually see how we define that for localhost, but you can actually then point this to a production host environment if you want. And then the final line here is a command that will actually send a script to your terminal window telling you that which port and which host that you are listening to. So let's see what that would look like. So here we have our terminal window, and we're actually able to then run the hello world JS script that we just wrote. And then once we do that, it'll actually then post that we have an example app listening at, and here we don't have a web domain address, but we do have the port 8081. And in our browser window, it says hello world. So that's a quick breakdown of Express.js. Now let's jump over and do a demo. So the first thing we want to do to get Express up and running on our system is we have to have Node.js installed. So we're just going to do a Google search to let you know where you can find Node.js. It's actually at nodejs.org. So we select that link, that will take us to nodejs.org. And there are two types of downloads. One is the current download, which has the latest features. And then there's a more stable version that if you're new to Node.js, I'd recommend you to download. Next, we want to find a text editor, and we're going to go with Visual Studio Code, or VS Code as it's known. It's an open source solution from Microsoft that runs across all the leading platforms. This will default to our Windows platform, but you can run it on Mac OS and Linux as well. I really like it. It's a great code editor. It comes with a lot of extensions, and it's open source. Next thing you want to do is, because we're going to be developing APIs, we want a way to be able to visualize those APIs quickly, and a great tool is a product called Postman. Again, open source, and so you can go out and go to postman.com. Top right hand corner, you'll see a bright orange download button where you can actually go ahead and download and install Postman, and that will allow you to be able to access all of your APIs that we're going to be creating in Express. You can actually use other tools such as Apigee as well for visualizing your APIs, but this one's just great to get you started. So let's go ahead and open up VS Code, and we want to go ahead and open a new folder where we're going to have our project. We're going to, just for our demonstration here, we're going to put this on the desktop. You wouldn't normally do this, but it will work fine here. And we're going to create a folder, and we're going to title the folder Node Express, and we'll select that folder. That now becomes the root folder for our project in Visual Studio. We don't really need the welcome screen anymore, so we're going to get rid of that. And one of the things that is great about working with VS Code is that you can actually have the terminal window up and running as well. So let's go ahead and open that so it's running at the bottom of our screen, and this gives us a little bit of space. And the first thing we want to do is actually convert the folder we're in actually into a project running Node.js. So we're going to use npm init, and that will actually initialize the project. We have another video that explains how to use npm or Node Package Manager, and you can go ahead and find that in our library here. But as we go ahead and we do that, you'll actually see that it will create the default package JSON file, which has the name of the folder is the default name of the package. But you can actually go in and edit any of these documents. We want to create a default file called index.js. This is where we're going to write most of our scripts that allow us to work with Node.js. And the first is writing a script that allows us to install Express, and we'll use the Node Package Manager to actually pull and install Express. You can default to specific versions of Express if you want. We're just going to go with the latest one, so we're just going to put in Express, and then we'll go down into terminal window and select npm install --save Express, and this will install Express so we can actually test out the code we're working on. And this will take just a moment to install. Great thing with working with Node Package Manager is that once we've finished with our package here, we can actually wrap it all up and send it over to any other developer that we're working with, and they can actually run the package and actually have exactly the same code installed. And there we are. We have everything installed and ready to go. We can see we actually have all of the modules installed. You see that we actually have Express installed as well. And we also want to then make this an app. And then we'll do app listen to port 3000. So this is by default, we're going to be running from our local host, which is HTTP server running on this test machine. And we're going to have Express for this project run on port 3000. And once we actually run the script, we'll actually post into the console window a piece of text saying server started on port 3000. So we're going to go ahead and save this file. A lot of Control S to save these files. So let's go into localhost in our web browser. So localhost localhost 3000, and you'll see nothing has been reached. That's because we actually haven't done anything to initialize the script. So we want to come in and we're going to go node index.js and hit return. And as you can see, now we have a message in our console window. That means that, yep, there we go. We actually have everything up and running. So we can actually see that the service is running. Not a very pleasant message. So let's go ahead and change that. So let's change that to app get and acquire res. And so if it uses the get message, let's change what we'll print, and we'll type hello there, exclamation mark. And we save that, and we refresh the screen. Oh, nothing happened again because we didn't run the script. So let's go back in and we'll run the script node index.js. And now what you'll see is if we refresh, there we are. We have our new hello there message. All right, well, let's actually start building some APIs in this environment. So to be able to build the APIs, we want to be able to pull content. So we're going to actually create a new file called users.js, and we're going to go ahead and create a users JSON packet. And a JSON packet is essentially an array. Consider it like a small database, and in this array we're going to have 4 objects. Each object is going to have 3 pieces of metadata. We're going to have an ID, name, and email, and there'll be ID 1, 2, and 3, and then you'll see that the names will be John, Smith, and we'll make up a couple of others, just kind of giving them arbitrary email addresses. It's just for our demo here. Let me grab this, copy it, and kind of speed up the script writing time. There we go. And let's just change what we need. One of the things that's nice with working with Visual Studio Code, VS Code, is there's lots of plugins, and so one of the default features is that if you select a variable, it'll actually look for the same variable in the script. So you can, if you need to, you can actually change them all at once. But we don't need to worry about that right now. We're just creating a JSON packet. So we have 4 items, ID 1, 2, 3, and 4 for John Smith and Jack and Chris. All right, so that's our array string, and we're going to then make sure that we can export that as users. So we can actually now, whenever we select the term users in our scripts, it'll actually pull in this packet. All right, looking good. Now let's go over to our main index.js file, and we're actually going to go ahead and we want to store where the API is going to be. So we're going to create a folder called routes, and then a subfolder called API, and then we'll call a file in there called users.js. So as we're updating our scripts, we know where to pull the data from. It's just a standard way of being able to pull out the values. So in here we're going to say, in this instance, express is required for our scripts. And we're going to also say that router within express, router correct naming convention, and the script is case sensitive. We'll also want to create a value later on that will have a unique ID. So we're actually going to pull in a UUID package that will actually then allow us to install unique identifiers. So we can use Node Package Manager to install UUID. Again, this is a great example of how you can go from nothing to something very quickly with Node.js, because we installed Express, we installed UUID, and we're off to the races. So let's have users require the path for where our API is going to be located. All right, so let's do a basic get, which will be to pull the records. I'm going to have it pull all the records. So router.get, and we're going to require it to pull all of the records in the JSON packet that we created. So there should be 4 items that come back. Save that. Looks good. Make sure that users is consistent. There's our JSON packet. And yep, everything looking pretty good. All right, let's go back to index. And we're going to switch out this function here from just a generic get with a generic statement to actually being able to pull in the users. So we have to go app use express.json app.use URL encoded extended false app.use API users, so we're going to be pulling them all from the same location. Require, and where we have our API scripts. Okay. And then let's go ahead and open up Postman, because we're going to actually use Postman to actually show us what the results look like, because right now the results won't show up appropriately in our browser window. So Postman, again, is just a API management tool. If you used Apigee or other similar tools that are on the market, MuleSoft, you'll see it's very consistent. Again, this is open source. And what you want to be able to do is you can actually go to the path where the API is stored, and then you can use all the different types of commands within your environment to be able to, test out the scripts. So let's go ahead and create a new project, a new request, and we're going to go with the default get, but there's actually quite a lot of different commands we can use. And these are just HTTP commands. And we're going to type in the request, and in this instance, it's going to be, let's run our script first. Do we need to run our script? I think we're good. Let's make sure we're exporting the data correctly. Okay, so we want to run our script, so let's do node index.js, and that will run the changes that we just created. So we can now come over to get, we can select API, localhost :3000/API users. And when we do, that brings back the JSON package with our 4 entry points. There we go, there's all 4 of them. So that's your first action. Now let's kind of get this a little bit tinier. Let's actually go in and see if we can filter by ID. So we're going to go in and we're going to modify our script. So it's going to be route, and then we're going to put in the filter, and in this instance it's going to be ID, which would allow us to be able to just put a backslash against the end of the URL string we just had and put in a number or a unique identifier, and then that will actually then allow us to pull in that unique record. Pass the data. Okay, so I found. I'm going to take the JSON and print it. So we're going to filter here against user ID and then publish the results. Else, if it doesn't work, then we'll just have a generic error message. We shouldn't see this though in the demos we're creating. This is just good practice. So save that. And let's go ahead and rerun our node index file against that folder. And now we can actually come in here and we do \1, and that will give us just one record. And we could change that to 2 or 100 in this instance. And if it's 100, we'll just get a bad request error message. There's 2. All right. So that's get. So we've been able to pull all of the records. We've been able to filter against one specific record against a specific parameter. In this instance, it was ID. So let's go ahead and create a new user. And so what we're going to do for this is we're going to use the post command from HTTP to actually push and post data into the data source. The data source is our JSON packet, which means that we'll have to then push a new record into the JSON package using our array statements, because JSON is just essentially an array. And so we're going to post, and when we do this, we have to create a unique ID. So this is where we have to reference the UID. I'm going to do a v4 unique ID, which will be 4 groups of 4, so these 16 characters. And then we'll have name and email we'll post. Okay, looks good. Okay, so if new user, and put .name and new user .email, and then we want to return the results. Okay. Right. And so users dot push. So we posted, which is a HTTP statement, and then pushing into the JSON packet array. Okay. Okay, it's looking good. All right, so I think we're good. Let's go ahead and rerun our script, node index.js. Now allows us to do that. So let's go over to Postman so we can actually connect to the URL. And we're going to change the HTTP statement to post, and get rid of that. We'll go back to users. Now, if we just do this, nothing's going to happen. So we actually have to go in and we have to update the body This will be the content that will be passed through, and we're going to go through with a raw statement here. And we're going to do JSON. This will be, that's the packet we're sending. So let's go ahead, and the records we want to update, we only have to update two, which is one is name and the second is email. We don't have to do an ID because we're using UUID to generate an automatic one for us. And we're going to create records for Steph, and her email address is steph@gmail.com. Yep, looking good. Okay, so let's go ahead and send that. We sent it. And if we look at the bottom, we can actually now see that we have 5 records. So a new one's been added. We have our unique ID at the top. And then we have name and email, which are the ones that we just created for Steph and steph@gmail.com. All right, so that's posting. Now the next thing we want to do is to update a record. So that means we need to select an ID and then be able to update the content. And for that, we're going to use the HTTP put command. So we'll use ID as our way to be able to filter. And then we'll be able to update against that filter. So construct found equals users, and then we'll have that going as users ID, so we know how to get the correct record, and then pass the record back onto the screen so we know what we're editing. So if found, I want to update the user, and I'm going to go that pull information from the body for what will be updated, and for each if user ID, and pass the integer, okay. So this is our values to pass against the ID. And in this instance, we'll make sure that we're updating the values of username. So if we are updating user and we're just updating the username, we want to make sure that that's the value that gets updated. And then we also want to do user email. We don't want to update the ID because it's going to remain unique and consistent. Okay, and we're going to make sure that everything is pushed to the JSON package. And then we'll also have a message saying that the field has been updated in the JSON package. Okay. All right, so we'll run that script again, and it looks good. So let's go to our folder. Let's change the HTTP post. Let's put it as get, just so we can see that we have all of the values in the array from the JSON packet. And now we want to select put, which allows us to update just one record. So let's go ahead and select one record. We'll select ID1. So we have one record. We can go ahead and for name, we can change this. So let's go ahead and change these. So now you see that the email has changed. So we have Steph as the new account. All right, our final API that we're going to create is to delete an account. And in many ways, it's actually a very basic API because all we're doing is we're grabbing the ID and then we're saying that all the associated records with that ID within that row, as it were, in the table, just to delete the whole row. And so we want to use, again, our ID as the unique value that we're pulling against. So we're going to, if users are found, and we're going to filter those users. I'm going to do that filter against user ID. Pass that. And then go and post a message to our JSON packet saying user deleted. And our generic message if things fail. Okay, let's save that, and we'll see. We're going ahead and we're just deleting the record now, and we're going to do it by filtering against a unique ID, and then it will then just eliminate that record, and we'll pass the message that it has been, the account has been deleted. Okay. So we save that. Let's go run our script. Node index.js. We're good. Okay, let's come over here and we're going to show that we can pull any of the accounts. So let's just take one of them. One, I think that's good. So let's go ahead and we're going to change the HTTP command to delete. And we actually have to select an account, so we just do one. When we do that, it'll actually delete that record. And here we are, it says that the user has been deleted, and we now only have 3 records in the JSON packet. And we can pull all the records, and you'll see that there's only 3. So being able to pull all the records from a JSON package, we've been able to create a record, update a record, and delete a record. And we can just step through. So here's our JSON package that we created originally. Again, this is just an array. It's just a different way of setting up the array. And then we have our index files, which identifies what are the apps that need to be installed and where are the APIs going to be serviced out of. And that we're going to be doing this on the port 3000. Again, these are additional tools that we need to make sure that we have up and running in our script. And so the first script was to get all the records. The second was to filter against a user ID for just a specific record. And then for creating a record, we actually went in and we used the UID tool to create a unique identifier, and then we posted in the data for the new records. We did something similar with updating the record. We didn't have to update the user ID. We just had to update the values in the two fields that we needed to be updated. In this case, name and email. And the final step was to go ahead and delete a record. So these are all APIs that you can now pull into your own applications. So you can use them in web applications, or you can actually go ahead and use them in other applications, such as mobile applications, local applications, other scripts. And this really allows your application to become more scalable and more useful. Hello, we're going to go through and do our demo of building a RESTful API with Node.js. So the first thing we want to do is go ahead and install all the correct pieces of software. We're going to start with Node.js. So let's do a Google search on Node.js, and you'll find that Node.js is at nodejs.org. So we select that link. And that's going to take us to the Node.js website. There are two versions of Node.js you can download. There's the stable version, and then there's the latest version. I'd go with the stable version. You'll find it available in Windows, Mac OS, and Linux as well. And if we go to the next piece of software, we want to go ahead and install the text editor of your choice. I'm going to use Visual Studio Code, VS Code. It's an open source solution. It works on all leading platforms. Works really well. I like it a lot. Microsoft did a good job with this. I also really like it that it's open source. But there's lots of extensions you can get for VS Code. So it's a great text editor. And we'll also need Postman. Postman is a tool that allows us to be able to view the APIs that we're going to create. So let's go ahead to postman.com. And again, it's another solution you can download for free. And so we're going to go ahead and select the download button. And it will automatically detect which OS you're on. So in this case, it's going to be Windows, but you can also get Mac and Linux as well. So we'll go ahead and download those. And once we have everything installed, what we're going to do is we're going to create a project in VS Code. And that's actually really easy to do. All you have to do is create a folder. And we're going to do this right off our desktop. And we're going to call the folder Node REST API. And we're going to select that folder. And you'll see on the left-hand column that we have the new folder that we created. We still have the VS Code welcome screen. We're going to get rid of that. We don't need that anymore. So let's go ahead. And one of the things I like with VS Code is you can actually toggle the terminal window. So let's go ahead and open up the terminal window so we can actually run that at the same time. And so we're going to move our cursor to the folder we just created. And there we are. You can see that. And what we're going to do now is we're going to initialize this with Node Package Manager to make this a package. And it's going to go ahead and we're going to ask for a name. We're just going to go with the default. So we're just going to say yes, yes to a couple of these. Yep, enter, 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 enter. And is this okay? Yep, enter. All right, so now we have a new file, and this is our JSON package. It has all the defaults in it. We can go in and modify these if we want to. No need to for this exercise, but you may want to for the solution that you're putting together. And we're going to create a new file called index.js, and this is going to be the reference file that's in the JSON package for npm. And here we're going to put in our solutions that we absolutely have to have for this to run. So we're going to install Express, and Express is a web service application, but it's very flexible, and one of the things that we're going to use it for today is build APIs. So in our terminal window, we're going to type npm install -- save Express. This will install Express locally on our machine. And it takes a few minutes, but it's going to go and download all the latest features. This is going to be the latest version of Express. You can, if you want to, specify a specific version of software. For these examples, there's no need to do that. So you'll see that everything has been installed. If we expand the Node module, we can scroll down and indeed, yep, there we are. We see Express has been installed along with some other pieces that are useful. All right, so that's our first piece. The next is we're going to define our app, and our app is going to use Express. And we want Express as a local host on our local machine on port 3000. So we've identified port 3000 as the default port for our application. And we are going to now create an array for some movies. And we're going to have ID, title, director, and release date. Inception, great movie. And director, Christopher Nolan. And that was released in 2010, yes, 10 years ago. Okay, so we're going to do a couple of items here, just so that we have some more than one entry in our array. And array is a JavaScript. You can think of it as a very simple table, but it allows us to have structured data. You can also do a JSON file. You can also connect to a database, MongoDB or something like that. 2019. Okay, so we have two movies in our little array. That'll be more than enough for right now. Key part is that we have a consistent structure for the array of ID, title, director, and release date. And so we're going to create two APIs. One's going to be a get API where we'll get the list of the items in our API, and the second will be a post where we'll be actually pushing in a new item. So let's go ahead and start with the get, and what we want to do is we want to select get/movie, and we are going to have this run as an API. And so what we'll do is we will test this in a moment. This will be running from our web browser. Actually, we'll probably open up Postman and run this through Postman. So, okay, that pulls all the movies. And we'll do another get in a moment where we'll filter by movie ID, but let's just get them all for right now. And we are going to listen on a server port. In this instance, it's going to be port 3000. And we already had defined the port as a variable earlier, so we're just referencing the variable, and the port number is listed at the top in line 4. Just a text string that's going to get put to the terminal window, and it is going to dynamically grab the port, the value from the variable from 3000, and place it in our text string. Easy. And we want to save the file, and now we're going to go ahead and run it. So we're going to do node index.js. That runs the script and tells us that we're listening on port 3000. That's great. That means now that we should be able to go into Postman and grab the data from an API. So here's Postman. If you've not used it before, it's a great tool for being able to manage APIs. Strongly encourage you to have a go with this. So we're going to get the get command. And if you've done any applications, web applications, you've probably used get and post for the data that you're pulling and pushing from forms online. Same principle. So we want to go ahead and we're going to go and I'm going to grab get. I'm going to type in localhost, and it's going to be :3000/movies, because that's the name of the file. And we're going to hit send, and what we get as a response is the data in our query. Sorry, in our array. Here we go. So there's our array, and the data values have been pulled back by Postman. That's great. So now we want to go ahead and add a movie to our array. And we're going to do that. We're going to use the post command, and get and post are HTTP commands. And so we're going to use movies, and in this instance we're going to push the value into our list. So construction movie requires, we're going to need a structure here, and that structure is going to be the information that's in the body, and then we're going to push to the log, our terminal window, and we're going to push. So here we're using push, and that's a term for arrays within JavaScript where we push the data into the actual array itself. There are lots of ways of being able to control data within an array. If you're new to arrays with JavaScript, I strongly encourage you to learn more about them. There's just an awful lot you can do with them. And then we want to have a validation message come up on the screen saying, yes, movie has been added to the list. So we'll save what we've just created. If we don't save it, it won't show up. And then we're going to rerun the node index.js file. You can see this is, we've created here already an API that allows us to pull and push data in and out of a variable. Okay, so let's go back, and we're going to change the header from being get to being push. So we're going to use, sorry, not push, post. So we're going to select post, and then what we want to do is the value inside of the body. And so let's go over, and we want to select body. And we're going to put in text and select JSON. So it's going to be structured. And so here we will essentially copy the structure we have here. So let's go ahead and just copy these elements. And we have to give it an ID because we don't have an auto-generated ID. So we're going to make this ID 3. And it's going to be a number 3. And then we want to put in title. New movie. And we'll put in director. And we'll have this as, I don't know, new director. Not very creative here today. And then we need to put in a date. So release_date. And let's just put in a date. Today's date will be fine. Just so you know that we're not formatting the date column. So let's go ahead and we'll select send, and this will actually go, and we can see below, boom, movie's been added to our list. And we can go back and let's go ahead and validate that. So we're going to change from post to get, use the same, and now we go to below. Oh, looks like we put an error in our formatting. So let's go to parse the JSON. And we will parse it using Express. And this will clear up any formatting issues. So app.use express JSON, express URL encoded, extended false. And this should help us pass our value. And then we'll rerun that script. Make sure you save the previous file, otherwise it won't run the new script. All right, looking good. So let's go back and let's go back to our localhost 3000/movies. And there's only two values here. So what we need to do now is change from get to post. We'll go to body. And what we're going to do is we want to have raw JSON, and what we want to do is capture the values that we have below and insert this file into this new JSON packet into our array. We can actually just copy that. It's a little bit cheating, but it's the main same. So let's go ahead and get everything consistent. And we're going to change the number to 3. We're creating a unique title. Actually, sorry, a new title. It doesn't need to be unique. Just the ID needs to be unique. So title will be new movie. New director. We'll change it to new director. And we'll change the date. I'm not doing any formatting on the date, so it can be any date, any number really. Hit save. Movie's been added to our list. Woohoo! So it's been added. But now let's go back to get and let's see if we can actually see the third entry. And scroll down, and there we are. We've actually pushed that JSON package into our array. So we now have 3 items in that have been added via our API. Okay, so now let's go ahead and search our movie database. Yes, we only have 3 entries, but we want to be able to. So we can do that by using the get command. And what we'll be doing is we'll be validating against a specific ID number. So we have 3, and we're going to validate against just the ID number. In this instance, the way to do it is through the URL. So beforehand, we had localhost :3000/movie. Now we're adding in /movie/ and then whatever number after that will actually filter against the ID. And that's essentially what we're doing here right now. So we're going to go into if movies.id. Again, we're using the ID value to actually pull from our array list. With my variables and arrays mixed up here today. And then once we actually have the value, we'll actually post back as a JSON packet. And If we have any errors, then what we'll do is we'll throw up a message movie not found. So there we are. We're going to pull against an ID, and we should be able to then pull that up through Postman into our terminal window. Again, the reason why we're using Postman is that this is actually just showing the values going back and forth. We're not having to render a whole web page. It's extremely fast, very efficient. All right. So we saved and reran our script. All right, let's go back. And what we're going to do is we're going to change the value. So we're going to hit send. Here we are. We see all of our movies using the get command. Now what we're going to do is we're going to use a look filter on just ID2, which is the Irishman. So do /2, and there we are. We have just the information on the Irishman. So now you can see how you can create a simple search. All right. So the final action we want to do is to delete a record in our array. And so we can go ahead and do that. And we're going to use the delete command to actually do that. So we'll be able to push in a record. We've been able to view records, filter against records. Now we're going to go ahead and do delete. And so we can do app delete, and then we're going to filter by specific ID number. And when we do this, we'll actually then, when we put in the URL path, which will be localhost:3000/movie/ and then the ID number. So in this instance, either 1 or 2, probably use 2. That will then delete from our array the record for the Irishman. Save our files. I do the shortcut, a keyboard shortcut of Control+S to save files on Windows, or Command+S on my Mac. And once we've deleted a record, we want to send a message saying that the movie has been deleted. All right, so we want to go ahead and let's just check our code. Looking good. Save our file, and we want to rerun the index.js file. Yep. Rerun. Okay, let's go to Postman and grab the delete. So again, we're filtering against a movie ID, and then we'll delete that ID. Okay, so we went against the Irishman, and we hit send, and there it is. Now we're going to change the command to delete. So we hit 1, we'll actually delete Inception. The movie has been deleted, it's great. And let's go ahead and grab use get to pull in all the movies that are listed. And it's not going to find movie number with the ID 1, it's not there anymore. And if we get all the movies, we see we only have one movie, and that's The Irishman. And so our delete function has worked. There we are. So we've installed Express. We're using Express to build all of our applications. We have our app running on port 3000. We are using Express to pass the JSON effectively back and forth. We have a simple array. That array is then being used to create an API to pull the details. Then we're being able to add a movie, then search for a movie, filtering against an ID. And then we can actually finally go ahead and delete a movie. All this using Express.js. Today we're going to be covering Node.js authentication using JWT or JSON Web Tokens. So let's get started. So why are we going to go down this path? So let's cover the key things that you need to be asking yourself, such as what is a JSON Web Token? What is the value of using a JSON Web Token? And then what does the actual structure of the JWT look like? And then let's go through some use cases of where you'd actually use JWTs, both in the enterprise and in the real world. And then finally, we're actually going to go through a demo on how you can actually install a JWT using Express and Node.js. So let's dive into what actually is a JSON Web Token. So a JSON Web Token is actually based on an open standard. It's one that you can actually go ahead and research, and it allows a definition of a compact, self-contained way of being able to securely transmit information between parties using a JSON object. And a JSON object is a JavaScript array, and it's very compact. It's a very tight way of being able to send data back and forth. The thing that's great about using a JSON Web Token is that the information itself is encrypted, and it can only be verified and trusted through a public-private key pair. And we'll get into that about how you can actually get to those. So, why would you actually want to go ahead and use a JSON Web Token? Aren't there other formats that you can use? Well, yes, there are other formats you can use, but what's great about a JWT is that it is a great way to be able to pass data from HTTP servers. So if you're building a web application and you have a web application where you need to pass authentication over, using a JWT is a great way to be able to do that. So for instance, you may have a number of enterprise applications that run across your cloud environment. You may have some enterprise applications that run in your data center, and you want to have people come in, such as your employees or your customers, authenticate once and then be able to have their ID transition from one to the next. JWT is a great way to do that. The content is extremely secure, and we'll get more into that in a moment, but it is the highest level of security you can have right now. And the final great thing about working with JWT is that the actual tokens themselves are very well documented, and so there's actually a lot of parsers that you can use. So being able to add in JWT into your application is very, very easy to do, which makes it very easy for you to actually implement at a large scale authentication and authorization. And so authorization is a key word there. That's something that you're probably coming across a lot. Instead of just being able to identify who you are, we want to be able to authorize what you have access to. So let's have a look at the structure of a JWT. There are several key elements. The first is the header, and that's actually going to break down what kind of token it is. By default, it's going to be a JWT token. And what is the signing algorithm? So SHA-512 is a very complex and secure algorithm. Certainly the one that I would recommend that you use. You can even go higher than that, but SHA-512 is a great place to start. And then you have the payload, and the payload is the information that's been actually encrypted within the web token. So in this instance, we have a name, the admin type, subname. Just really, you can put whatever kind of information you want in there, as long as it's applicable to the service that you're passing the data into. And then you have your signature, which is encoded header and payload with the algorithm that you've sent. So in this instance, it's SHA-512 algorithm. So let's look at some of the use cases that you'd have for JWT. So a couple of use cases would be authorization. So say, for instance, you have a application and you want to be able to authorize somebody to have access to different parts of the application. A JWT is a great way to be able to encrypt that data and be able to pass that data back and forth. Examples would be jumping from different parts of Office 365 and being able to have access to different features within the system. And then another area would be if you're doing information exchange. So if information is being securely exchanged from one person to another. So a blockchain scenario, a multi-distributed environment where you want to be able to have a way to be able to securely transmit data back and forth and know that that data is being encrypted is another good example. So with that, let's take a pivot and we'll go ahead and we'll look at creating a demo using our standard stack of Node.js, and we'll use Express and Postman. And these are tools that you may already be familiar with if you've seen other videos that we've created in this series. And we'll go ahead and create a JWT token. So let's go into our demo of how to create a JWT JSON web token. There's going to be some tools that we need to get started with. Node.js is the first, so let's go ahead and find Node.js at nodejs.org, and you can either download Windows, Mac, or Linux code. Obviously, you'd install the one that would be for your operating system. The next tool that we want to install is a text editor. We're going to use Visual Studio Code or VS Code. Go to code.visualstudio.com, download this. This will run on Mac, Windows, and Linux. Really great text code editor. And then we're also going to use Postman. Postman is a tool that allows you to access and view APIs that we'll be creating with Express. And you go to postman.com, hit download. And again, there's versions of Postman for all leading operating systems, and have those installed and up and running. So we're going to go ahead and let's open up Visual Studio Code. And we're going to start by creating our project. So let's go full screen on this, get rid of the welcome screen. And let's go and open up a folder where we'll actually have our project. I'm going to put this on our desktop for right now. Let's go create a new folder and we'll call this Node.js for JSON Web Token. Select that folder, and we're going to want to go ahead and use npm to initialize this folder for Node. And so let's get rid of the welcome screen again, and let's go ahead. And one of the things I love about VS Code is you can actually run the terminal window right from in here. So let's go ahead and select npm init, or knows to pull from the folder that we're in, and we're just going to select yes here in a second for our, let's go ahead and create that. And you'll see that the packet has been created, and there is a JSON packet with just default information about the npm package that we created for Node. And we're going to go ahead and create an index.js file. That's what we've been pulling from the package. And the index.js files, we're going to actually write all of our code. And what we want to do right now is install Express. And Express is going to be used to create the APIs that we'll be able to test our JWT against. And then we'll also want to install a JWT file. So let's call this JSON Web Token. And from our terminal window, we'll just go ahead and install both of those. And you do that by typing npm install --save. And then we're going to put Express and JSON Web Token. Express and JSON Web Token. And we'll just go ahead and let those install. It only takes a moment for those to get installed. All right, we're up and running. Okay. So let's go ahead and start bringing in some of our apps. So we're going to create an Express app, and we're going to use the get HTTP header to have everything go from the, we're going to actually have everything running on our local host, and we're going to run everything off port 3000. We'll do that in a moment here, but we'll have everything running off a sub folder called API. That's where our web application is going to be running from. And we'll put in a message that, hey there, to show that everything's up and running. Okay. And save that. And save. You can do Control+S to save your files, as you can with a lot of Windows applications. I encourage you to do that a lot. So let's go ahead and open up Postman. We're not even going to go to our web browser on this one. And we'll open up Postman. Takes a moment to run the first time. Here it comes. And Postman, again, is a tool for being able to manage API calls. So you don't have to write a script. So here we are. And we can go in here and that's where we're going to write our script. But we have to do a couple of things first. Let's get everything running. So we want to listen for port 3000. That's where we're going to run everything off of. And in the console log, we'll actually throw in a message to confirm that we are running on, everything is up and running. We'll just say, okay, server started on port 3000. Again, we're going to be running everything off localhost, so you'll be able to see this. And this is, as you imagine, just a test environment. So let's go down into our console. We'll run this script, node index.js to run the script. It runs really fast, not a whole lot going on there. And we're having everything running off the API file. So let's go and we'll type in under our get localhost :3000/API. And we hit there's lots of different HTTP headers we can use. We're going to use get for right now. We'll send that. And hey there, welcome to the API service. So to be clear, this is just an API we're creating right now. This is not JWT. We'll get into that right now. All right. So we want to be able to post data, and post is actually pushing data in. So we're going to go into, going to create a login screen. Again, this is all API, so it's not real, but you get the point. And then we can construct a user. And let's go ahead and what we're doing here is we're creating an array of a random user, and they can have a name of ID1. The user's going to have an ID value, which is 1, a username value, which is going to be John, and then an email value of john@gmail.com. And then we'll make this a JSON Web Token JWT sign-in, and they'll have to sign with their user. And this is going to use a secret key, which will be our hash 512 token. And we'll respond to the JSON with the token. Okay, so let's see now. Okay, and we're going to and this will be our post API posts. And what we're going to be able to do is we're going to jump from one app to another app, and you'll be able to see how we can move the token with it. And the message will read post created. All right. So let's just run that script. Index.js runs real quick. Okay. So if we come over here and we go to posts, and hit send, and say message post created. Good. So let's go ahead and try that again. And we want to go to the login. So we're going from one app to another app. Select post. And here in the login, we should be able to request the token. This should be our JWT token. When we hit send, we should get our token. And here you can see the whole token is encrypted. It's that huge long line. It's very unique. And now we want to be able to go in and say, okay, let's verify the token. So we've gone ahead and we've created the token, but now we need to, as we go from app to app, we need to actually verify the token. So we're going to get an error message if we don't verify the token correctly. So we're going to put in a function to verify the token. And we're going to create a bearer header value, which will be the headers and the authorization for that. And if type of bearer header, we're going to have it, if it's not correct, it'll be undefined. Otherwise, this bearer token, it will be split. And we're going to require the token for our bearer token. Else send status 403. Okay, so bearer token is what we're going to be calling against to verify our token. I'll show you how that works in just a moment. And this will be to authorize. And to authorize, we'll need to actually go ahead and use the token. So we can actually put in here. All right, so I think everything's looking pretty good. Oh, and if we get the error message, it means that we'll see the message forbidden if we don't put in the code correctly. So let's double check that everything is looking good. We're going to verify that the token is required. Okay. So if it is, then JWT.verify. And this will connect our token appropriately. And we'll be able to pull that in as a part of our secret key. And if it is successful, we'll put in that message there. And we're also going to pull in the authorization data. Yep, looking good. As you can see, a lot of the work is just making sure that everything is aligned up correctly. Okay, so let's run our code, node index.js. There we go, nice and fast. And we go in and localhost API posts. We'll change this to post. So this one API, which is the API posts, which is up here. We're going to hit send. And you can see that we have the error code forbidden has come up, which is what we were expecting, because we haven't been able to put in a secret key. And put in the comment there, forbidden, so as we're stepping through the code. But now what we can actually do is we can go back and we can grab the token. And here is our token below. And we just want the token itself, we don't need the wrappers. And copy that. Come over here. And if we write again, it's going to say forbidden, but if we go into our headers, we can put in authorization, and then the value, we'll do bearer, and then the key. And once we do this, we now get all of the data that we were asking for pulled back, which is exactly what we wanted. So you can see here how we can actually securely use a JWT to pass values back and forth across the application. Okay. And we hit authorization, and we select that and approve it. Yep, we keep authorizing. So if you don't authorize, then you don't get the data. Okay, so we have everything against the API. Then we have one application which is called API post. We have another application called API login, and we're able to move the data back and forth using our secret key in our JWT token. And we have everything running on port 3000 of our local host server. And that's our demo. So first of all, let's cover why you'd want to go through this tutorial. So we're going to cover what MySQL is. We're also going to tell you how we're going to connect with Node.js and why you'd want to do that with MySQL. And then finally, we're going to do a demo taking you through all the steps on how you can actually do that kind of connection. So what is MySQL? Well, basically, MySQL is probably the world's most popular relational database. So if you think of relational databases that are table-driven, MySQL is arguably the most popular database out there for RDBMS systems. It is by far the most popular open source relational database. The entire database is written in C and C++. It's been around for a really long time. Again, it's open source, which is great, which means that there are no licenses or costs for actually using MySQL. And you'll find that companies of all sizes, from small mom and pop shops all the way up to massive global enterprises, are all using MySQL. So, why would you want to then take that next step of connecting Node.js with MySQL? Well, fundamentally, it comes down to the basics of the differences between the two products. MySQL is a database, and Node.js is an architecture framework for building out web applications. And again, with MySQL, it's open source. It's free to use. You don't have to pay anything. There are no licenses, which if you compare it with other solutions out there is a big deal. MySQL, even though it is open source, is incredibly powerful. It's one of the more mature open source programs out there. I think Apache is probably arguably more, Apache web server is probably more mature, but MySQL is very close behind it. So it has had a huge amount of investment. This is not a solution that's only a couple of years old. We're talking about a solution that's more than 15 years old, very, very structured, very powerful, and you can do a lot of really good things with it. You can actually then build solutions with it using PHP, Java, really any kind of database, even other systems and other frameworks will allow you to interact with MySQL. And it just allows you to work with just huge amounts of data very, very quickly. So let's go through a demo of how you'd actually use Node.js and MySQL.
So we're going to go ahead and we're going to get started by putting our Node environment together. So let's start by selecting Node.js and downloading it. So we'll go to nodejs.org. And there you have your options for Windows, Mac, or if you want to go for the source code, you can go ahead and download and install that. The next is to install XAMPP. So we're going to go to XAMPP installers for a quick search, and that's on our apachefriends.org site. And here we have XAMPP available for Windows, Linux, and Mac OS X. And then finally, we want to go ahead and install Visual Studio. So Visual Studio is going to be our IDE, our integrated development environment. In this instance, we're going to use Visual Studio Code. If you don't use Visual Studio Code, it's a great free open source solution for being able to build applications. I'm a big fan of it, so I encourage you to use it. Go ahead and download, install that. And we have Visual Studio code up and running. So go ahead and we're going to open up a new folder. And let's go ahead and create a new folder. We're going to just put it straight off our desktop here. And it's just for kicks and giggles. So we're just going to type in Node MySQL for our source code. And we'll open up that folder and select that. And so we now have this folder selected in our Visual Studio Code editor. And what we want to do is we want to get rid of the welcome page. We don't really need that anymore. And we're going to terminal window so we can actually see the scripts that we're writing. We're going to be using terminal quite a bit in this. So for instance, we're just going to test that we have npm installed. We do, so that's great. And we're going to go npm init, and that's actually going to set up our own node package module. And we can actually see that the JSON file for that package has been created. So we go in there, we can see that all the defaults are selected. You'll see that index.js is the default file that will be created. So we're actually going to go ahead and we're actually going to create our own index.js file, and we're going to add in some instructions into that file to actually install the correct software from the npm package. And the first thing we want to do is install Express, which is a package that's great for building lightweight web applications, not mobile applications. I suppose if you're doing a responsive design, then I guess it would be mobile. But in this, it's a web application environment. So we're going to put in the requirements for that, and then we're going to also go and require that MySQL gets installed. And you'll see that for both of them, we're just going to use npm's default commands for creating that, and we'll go down to the terminal window and we'll do npm install, and it's going to install the Express and MySQL environment. And as that installs, you'll actually see on the left-hand side under the folder, you'll actually see the files starting to be installed. So for instance, we have the node modules, and underneath that will be all the subsequent files that we need. And there we are. Everything is installed. All right, so let's go ahead and validate some of these commands to make sure that everything is installed. So we're going to open up XAMPP, which allows us to go in and view and see that everything's installed. So we have MySQL installed, we have Apache installed. We can start and stop the services with XAMPP. Go ahead and do that. You can do this through terminal window as well, but the UI interface is really nice. So let's go into MySQL interface, and you'll see that we don't have any databases. These are all just the standard test databases, and so we have to go ahead and create one. And so let's get our SQL database connection created. So we're going to write const db equals MySQL create connection, and we want to connect to the local host in this instance, and user is just going to be a root user account, which is the standard user account that comes from MySQL. There is no password for the root user when you're running it locally, but I encourage you to change that as quickly as you can because you don't really want to have a password-free environment. And now we want to be able to then connect to the MySQL environment. So we'll write db.connect parentheses error, and we want to throw an error message if the connection isn't good. So if we do error, we'll throw the error message to the log window. And if we don't, then we'll write MySQL connected. All right. And then we want to connect that to our Express app. The next step we want to do after we made our connection is to go ahead and create a database. So we're going to do both steps at the same one. So we're writing the script right now, and then we'll run the commands in the terminal window so we can actually create the database. And so we're going to go ahead and we want to create a database. And let's write let SQL equals create database. And we're going to call the database Node MySQL. You can call it whatever you want, but this is just a Node MySQL script. The db query SQL error throw error message res.send database created. So we'll throw a message saying that the database has been created. Let's go save that to demonstrate that we've connected and we've created a database. So let's go ahead and we'll do node index.js to run that, and we've connected to MySQL. That's great. Good first step. And then we'll go to the window and we'll go to localhost 3000, which is the default connection. But what you'll see is that we've actually created the name of the database has been changed to Node MySQL. So we've got an error message, which we expected. And so what we're going to do is we're actually going to go ahead and we're going to say we want to listen. And if the error message comes up to 3000, then in the console window, we want to put a message of server started on port 3000. So let's try that again. Node index.js. Yep, and server has started in port 3000. We'll refresh that. Nope, still getting an error message. And what we want to see is, let's go ahead and see our database hasn't been created. So let's go and connect to database. The database is, let's go ahead and click create DB on port 3000. All right, so by doing that, we write that command and that function, and that goes ahead and creates our database. And we'll actually see that we have now Node MySQL has been created, which is a great first start. Now we have to go in and create some tables because we have no tables in there. All right, so let's go down and let's go ahead and create a table. So what you're seeing right now is that we're using the index.js environment within a package on Node.js to actually create and control everything that we want to see in our windows. So all of the work that we're doing for creating a table, for creating the database, for initializing the core files, is all being done through JS. And so here we are, we're going to create a new table. We call it it's going to be called the employee table. And so once we run the command create employee, it's going to create a table, has the employee fields, which is going to have an ID, which will be an integer that will go into auto increment. It'll have a name field, and we'll also put in a designation field. And we'll have a primary key as well. Keep it very simple for right now. And let's just put our DB connection so that everything connects effectively. Okay, so if everything goes correctly, then we'll have the message employee table created. So let's test this out. And Node.index.js. Make sure that the data we have now actually a database field that we can connect to. So we've got Node MySQL, so we're connecting to the correct database. Obviously, we get an error. And then we'll try that again. Yay, we connected to the database. So the database has the name. And because we've got Node MySQL, there's no fields in there yet. So let's go ahead and put in create employee for the fields, and let's run the function that creates the new table. And then voila, we have a new table. And so the next action we want to do is actually populate the table with a record. So this starts becoming familiar. So we're now going to put in a single record. We'll call it employee 1 for right now. And we'll write the function employee 1, and when we run that function, it'll actually go ahead and it'll actually insert the record into MySQL. And the name will be Jake Smith, and the designation will be a Chief Executive Officer. Certainly encourage you to put your own name into this, make yourself your own CEO, because why not? And we're going to make this as an insert record. We're going to insert into the employee table. And we're just using some basic SQL scripting here. And what you'll see actually with Visual Studio Code is that it's actually providing a lot of prompts to make it easier to write your code. Microsoft is looking to actually add some AI to Visual Studio Code to actually start auto-completing scripts, which will make it even easier to write your code. All right, so let's go run node index.js. We see we've got everything connected, and we'll grab the function employee1, and let's go over to our Express site. And let's just go and we'll insert the command employee1. Employee has been added, and we will just validate this by going back to MySQL and we'll refresh it. And you'll see, if we click on the employee table, we should now have an employee in there. Yep, there we do. Jake Smith. Well done, Jake. First record. All right, so we want to be able to now select the employee. So let's go ahead and do that. And we want to be able to easily get the employee list. So let's use our SQL command and we'll do select star, which is everything from the employee table. So we're actually pulling everything from the employee table. We're going to query the database. Let's throw a message to confirm that the query is successful. We'll put everything in the console log results. All right, let's give this a whirl. Okay, so let's go and run our command. For localhost 3000, and we'll put get employee, and it says employee details fetched. Now we go to the console window in Visual Studio. Yep, there we go. We have now all the packet information, including the ID about Jake Smith. Okay, so let's go ahead and see if we can actually update the employee information. So as you can see, now we're starting to run into just our standard SQL commands. And so we want to be able to update the employee from a browser. And as you can tell, we're not using any forms or any other types of records. We're just simply interacting between the browser, the server, and the database. And the new name will be updated name. And we have to make sure we're updating the appropriate record. And we will make sure that we're matching against ID 1. Right, so let's run that. And the Jake Smith is there. Now go and select Jake employee :/1. We've now gone ahead and updated the Jake Smith information. So let's click on employee table, and we now see it says updated name. I know, not very creative, but it allows you to see a change. And finally, we can go ahead and delete the record as well. So it's going to be similar to update, but I'm deleting instead. And we're going to delete the record from the employee table, where name equals, or ID equals, sorry, and ID. And then we want to be able to show that the record has been deleted. Yeah. Select delete employee deleted, and we go to database. We can actually see from the employee table that there are no entries. The one and only record that was there has been deleted. And so this shows you how you can very easily control everything from using your connection into MySQL right from Node Package Manager. You can create a table, you can select your records, you can then update any record that you selected, and finally you can delete any record that you want to be able to delete. So what we're going to do is, so what's in it for you? So in this presentation, we're going to go through three key things. What is MongoDB? How do you connect to MongoDB with Node.js? And MongoDB is part of the MERN Stack. So we're going to cover what the MERN Stack is and how it applies to Node.js. So what is MongoDB? So MongoDB is probably the most popular NoSQL database out there. It's cross-platform and very easy to scale. It's available on all cloud systems. You can also run it locally, which is what we'll be doing later on in our demo. But it's just a very flexible database environment for modern applications. It works on the concept of collection and documents. What you'll find is MongoDB was originally written in C++, and it is what's referred to as a NoSQL database. So this is different to a relational database, which is built up of tables with rows and columns. This is a NoSQL database, and it's simply a lot faster and more powerful for the work that you're doing. And you're able to use MongoDB very easily. You can actually go ahead and download it. We'll actually do that as part of our demo. So, why connect Node.js with MongoDB? Well, the reason why you want to do this is that
MongoDB is a modern database. It's not restricted by the challenges of scalability that older relational databases have. It's really designed for building mobile applications and websites that scale into the millions and millions of users. For MongoDB, probably the most important feature is scalability. The performance of the database is phenomenal, and it is extremely highly available for the solutions that you'll be creating. So when you push it out your solution to the cloud, you can almost guarantee it's always going to be running. You also have the ability to be able to scale to very large, complex, multi-site solutions. In fact, one of the very first MongoDB applications I built was a multi-tenant environment, and it just worked really well. And you'll be able to easily deploy your solutions across Microsoft Azure, AWS, Google Cloud, etc. So, why do you want to keep connecting to MongoDB? I think probably one of the other areas that probably is often forgotten with Mongo is just the concept around big data. And when you talk about big data, you're talking about absolutely massive databases, and MongoDB is front and center for all of that. You can do your effective content management and delivery. It has an effective mobile and social infrastructure, so by that it allows you to be able to build out solutions that can go to all modern day types of applications. And the data is actually very easy to manage through your central data hub. And then finally, being able to connect to MongoDB is very easy, particularly as there is a client called Mongoose that makes the connection extremely easy. So, finally, let's kind of look into how MongoDB is part of the MERN Stack. So MERN Stack is a JavaScript stack, and it's of JavaScript solutions that are built for modern single-page applications. And there are 4 key solutions in the MERN Stack. There's MongoDB, which is your database; Express, which is your server-side HTTP environment; React, which is the solution for being able to create your solutions on the client; and then Node.js, which actually manages the whole environment. It's really an environment that's designed to make it very easy to be able to build out modern day solutions. So MongoDB is the M in MERN, Express is the E, React is the R, and Node.js is the N. So again, as you start working with some of our other videos that we have here, you'll be able to see how all of these tools really complement each other. So we've done an introduction on MongoDB. Really, the best thing now is to get your hands dirty by actually doing a demo. So we're going to go through a demo. What I would strongly encourage you, however, though, is that this demo really does build on a lot of the other videos that we've done in this series. You really do want to spend some time on the Node.js video, the Node.js for Express video, the Node.js for APIs video. Really, all of those videos help complement the work that you'll be doing with this video here. You'll see some real strong correlations, plus a lot of new content as well. So with that, we're going to jump into the demo. So let's do our demonstration on how to use MongoDB with Node.js. First thing we want to do is go ahead and install Node.js. So you're going to go and do Google search Node.js, and that should bring up a result of going to nodejs.org. And here you can download Node.js for multiple platforms. So Windows, Linux, Mac OS, they're all supported. You can also get the original source code and recompile your version of Node.js if you want to. Now we're just going to install the Windows version. And the next thing you want to do is install your favorite text editor. I'm going to install Visual Studio Code, VS Code. It runs on all leading platforms, Mac OS, Windows, and Linux. It is open source. You can edit it. I like it because you can do an awful lot with it. Just a lot of extensions. It's just a great tool all around. So that's the next thing you want to install. And then we want to go ahead and we want to go to MongoDB.com so we can install the MongoDB database. So you want to go to Software, Community Server, and you want to then select the MongoDB Community Server, which platform you want, and where it's going to connect with, and you want to select the download to install that. And that'll take a moment or two for you to download and get that up and running. Once you've done that, we want to go ahead and we're going to open up VS Code so we can start editing and the code that we need for our new solution. So let's go ahead and create a folder off our desktop that we'll use for MongoDB. So I already have a folder created called demo. I'm just going to select that. And then inside of there, I'm going to put in node MongoDB. And select that folder, and that's going to open up VS Code. It's going to have our folder in here. So we're going to get rid of the welcome screen. We don't need that. We do want to, however, open up our terminal window. So we're going to run that. That's one of the things that I really like about VS Code is you can actually have your terminal window or command line window actually inside the development environment you're working in. So you don't have to be jumping from one solution to another. And then we're going to initialize our package. So npm init for the folder that we're in. It's going to create our Node package manager. It's going to create our default package. And we're going to hit return. That's going to go ahead and start the process. And we're just going to go with the default settings that npm is going to give. So just hit return, return, return a few times, and that will get up and running for you. And our entry point for the application is going to be index.js. That's our JS package, and there we have everything. This is just the JSON package that provides the instructions that npm would use to pass the program. Now you notice that we have index.js as our leading file, so we actually have to add a new file here, and we're just going to call this one index.js. So we actually have a file that can be referenced. And now we're going to go ahead and we're going to actually put in our default application. So Express is going to be required. So we're going to make sure that that is included in our first line of our instructions. And then we're also going to have a path that's required. And we're going to require handlebars. And these are all part of our Express environment. And don't forget to save your file as you're going along. And we're also going to have Express PHBS. And this is going to be our Express handlebars. And we're all going to allow insecure prototype access. You wouldn't normally do this, but because we're running everything locally, it just makes it easier for you to actually get all the code in. And then we're also going to add in our body parser. And these are all the required solutions that we need to be installed when you're running this package. And so let's save the file and then let's go ahead and run it. So we're going to do npm install, and we do --save, and this will install Express. And we're also going to have an install path, handlebars, Express handlebars. And this is where we'll install prototyping. And we'll also have the body parser installed, and we're just going to run that. This will just take a moment or two to install. All right, there we go. So we have everything installed, which allows us to now start working with our scripts. So we're going to create an app in Express. And we're going to listen on port 3000. And we're going to have a message, then go to our console log. And we're going to have everything running off our local host on port 3000. So let's go, and we're going to select node index.js, and it shows us everything's running, which is good. We can actually test this in our web browser if we wanted to. Okay, so let's start working on our app. So our app is going to use body parser. And we're going to encode our request. And the goal here is we're going to create a file that's going to go back and forth to MongoDB. So body parser is going to use JSON to encrypt the content. And we're going to do a get command to get our results. And if you've seen the API video, then we did that here. In fact, it's probably a good idea to actually sit down and look through some of the other videos that we've created, such as the Node.js for Express, Node.js for APIs, and Node.js for authentication. Before doing this video, we're going to create a default page, and it's going to say, welcome to the students database. The principles that we're putting down here, you'll be able to apply to any solution that you're creating with MongoDB. So we want to have a simple action that we're going to put on here, which is going to be click to gain access. Okay, we're going to put in the path and where to get the list from. Okay. All right. So here is our basic web page that we're creating. Nothing fancy, but it's going to take you to a place where you can actually get all the content. Now, what we're going to do is we're actually going to go and pull the content from Mongo. So we'll run this, and we can open up a web browser, and you'll see what it looks like. So let's go to localhost, close out these other tabs, don't need them. Localhost 3000. And there we see, welcome to the student database. Click on the database, and you click on, if we clicked on it now, nothing will happen. So, yep, nothing there. So let's make something happen. Okay. All right, so let's begin extending our app. So what we're going to do is we want to set the views. And we're going to do a join on our directory name. and app engine. So let's go for our views. We don't have an app engine yet, but let's go ahead and create a new folder. We can call that one views, and let's expand that. Actually, that should be okay. HPS. Express handlebars. And we're going to allow prototype access for our express handlebars. So with express handlebars, if this is new to you, it allows you to separate your content from your layout, which if you have developed with Swift for a mobile application on the Mac using Xcode, it's the same principle there, but for a web application. So we're just putting out here some of our default environment settings. And we're going to set our view engine for handlebars. And just checking through our code. It's looking good. Okay, so that provides that. So let's create a new folder under our views, and this one we're going to call layouts. So again, this is where we are splitting our layouts. And we're going to have a folder called models at the root of our application, and under models we're going to put in db.js. So the db.js file is going to be where we put our instructions for our database. And so here we're going to go ahead and we're going to require to import Mongoose. And Mongoose is a tool in Node.js that allows you to connect to MongoDB. So we're going to require the use of Mongoose. And so we're going to do npm install -save mongoose. And that's going to run and install on our local machine, so we can actually test this out. And once we've got this installed, what we're going to do is we're going to start connecting to a database that we're going to call StudentDB. Okay, we're already installed, so let's go mongoose.connect. And we're going to call it MongoDB. And we're going to run this off our local host. So we installed the community version that allows us to run off our local host. And it's going to run from the port 27017. And we're going to call this one StudentDB. So again, with our application, we're splitting out all the functionality. So if you want to reuse elements, you can. So we're going to have a user URL parser. And we'll make sure we capture everything correctly. Okay, so if error, then we'll send a message to the console log. And we have either connection is successful, or if things go wrong, error in connection. And then if there is an error, then what we'll do is we'll have the error message posted. Okay. And then we're going to do require student.model. So this will actually pull the model we're going to create. And so what we need to do now is create under models, we're going to create student.model. student.js. And this is where we're going to do our instructions for our student model. So first thing we want to do is we want to import Mongoose, Express, and the student model. So we've got to let's make sure we have everything. Let's capture that. So let's go over to our student model. All right, so let's make sure that we have everything. So we want to have Mongoose. And I'm going to create a new variable called student schema. This will allow us to structure what our model will look like. And this will be a new schema in using Mongoose. And our new schema is going to be full name. And we're going to break down our JSON package. So we're going to put in the instructions for what the schema would look like. So we have the type, we have required, this field is required. And the second value is going to be email. Type string. This field is required. That's the message, error message you want to send if the field isn't filled out. And our mobile phone number, this will be just a number. And we're going to have city, and the subtype will be, let's just make this a string. We're just going to try and keep this simple for right now. And this field is required. All right, so here's our schema. Looking pretty good. All right, mongoose.model, and connect this to our student model. So we want to go ahead and save that. Okay. Okay, a new folder, and this new folder is going to be called controllers. And we have a new file under controllers. And that new file is going to be called studentcontroller.js. Let's go in and see what we're going to add here. So we want to import, make sure that we're running Express. So Express is required for our controller. We also want to set up a variable for router. So router express.router. And we want to make sure we're also connecting with Mongoose. So we have a connection to MongoDB. And we also want to make sure that we have connection to our student model. So mongoose.model and our student model. And this allows us to make sure that we have this student model pulled over effectively for our controller, for our student controller. Okay, so let's go to router, get, I'm going to render this. And student/add or edit. We'll come into that in just a moment. So we want to be able to view title, and this will pull in the insert student. And we're going to use, under our views, we're going to create a new folder. And this one's going to be called student. And we're going to create a new file. And this one will be add or edit.js. Oh, HPS, sorry, for our handlebar. So you notice we don't have to put the file extension. Node.js manages all that for us. So router.post. So this will be we're going to get our content, and then we're also going to post content. So the post will go back as part of our body, and there'll be an ID. So we want to then insert the record that we'll be creating. So again, if you've worked through the Node.js API video, then you'll start seeing that there's some commonalities here of being able to insert or update a record. And we actually cover that using just a sample JSON package. This really takes it to that next level. Okay, so we want to put in a new student record, and so be student, and we're going to have their full name is going to come from our body. And we're going to also capture the email. Essentially, we're going to follow the model that we created. And our mobile phone. Finally, with a student city. And then we want to save the record that we create. Okay. All right, so we're going to manage our error message. And we're going to put in similar messages that we've put in before. So we want to redirect to our student list. And we're going to go ahead and create that in a moment. So let's create a new file, student list.hps. So list.hps. And here, so what we do is with student list, that's actually going to manage then the controls for being able to display the records in the database. And then we'll put our message. If there's an error, then we'll put an error message there and ask it to report the error message. We're going to try and not do that. All right, so now the next step we need to go through is we want to call a function to update the record. And let's go ahead and we're going to update the records, and we do the student.find1 and update command. Okay. Okay, so we will redirect to our student list as needed. If not, we'll throw an error message to our console log. Yeah, looking good. And again, this is just an example, but something that you'll be able to do yourself with your own solution. And then we want to go back to our list to then render the records. All right. And here we want to put student, and then how we're going to find the record. We'll throw a error message to our console log. So as you can see, we always throw an error message to the console log. Error messages are really useful. Okay. All right, looks good. Save that. Okay, let's do another router, and this is to, we're going to do the router against ID. This will allow us to get the content. So we'll be able to get the information by ID of the student. And what you can see is there's a lot of the work we're doing here is very repetitive, and you'll find as you create more modular code that it makes it easier for you to write your code and update and manage your code. Okay, so we're going to get our view title. We're going to put that into our document. Okay. All right, so our next router is, we want to be able to delete a record by ID. And so what we're going to do is we're going to find our records, our student record, and we're going to find it by ID. And then we'll do find ID and remove. Okay, so we're going to, once we've removed a record, we're going to redirect to our list so we can show our student list. Otherwise, we'll send an error message to our console log. Okay, so I think we have what we need. Maybe there's one more thing. Oh, I think we need to. I think this is good. Okay, so let's go to our layouts, add a new file there. We're going to call this one main layout.hbs. And here we're going to put the skeleton of our web page together. Let's write this out. So we're going to put in our HTML code. And we're just going to keep this real simple. And our header, we want a title, and this is going to be students database. Oh, maybe we'll just call it students. So we now go to, we're going to try and find out Bootstrap 4. We're going to just grab that, and we're going to use Bootstrap to get started. And there are a couple of components. There's the CSS component, and then there's the JavaScript component. So let's just go copy the CSS component. And then we're going to just link that into the header section of our web page. So, and then here's an example of different components you can create. If you haven't used Bootstrap before, it's an open source framework originally developed by Twitter. Great tool. So here in our header, we want to put in the link to the CSS. There's that. And now we'll need to also put in our own styles. So we've got here some styles that we created earlier on for the work that we're doing. You can just paste those in. So we have a box style that we want to use that will extend the box style that you get with Bootstrap. All right, so we're going to start working on our body content. Class BG info. So this is actually, BG info is a CSS class file from Bootstrap that you can use. And you're going to have the ID of box. And again, we're going to do another class. This allows us for our table structure. So a little bit of knowledge of Bootstrap is great here. So what we're going to do now is we're going to put in the content, which we're going to call body, and this will show up on the screen. So again, we're pulling from records within Bootstrap. Dig through Bootstrap, there's lots of content there for you to be able to take advantage of. Okay. So now we want to be able to add or edit a record. View title. And the French brackets allow you to be able to pull records and content directly from the code that we're writing. So we're pulling title from insert record, and that's part of our router command. And then we'll put in our form. Which will be student post. I'm just going to do a basic form here, nothing fancy. We will put in the first
record will be a hidden field. And this will be for ID. So we want to generate the ID. We don't want to have somebody put that in. And then we will put in our form elements. So we'll have, first will be a label, that'll be full name, and there'll be an input field. So it'll be text in the input field. And again, we're using form-control, which is from Bootstrap CSS. And then we'll have the full name and placeholder will be full name. So where we have name there will actually match up with the value that we're putting in our model. So here we have student full name. So we're matching everything up to the model that we created. Okay, so let's do this for our remaining form elements. And again, as you see, we can put this together really quickly. So we're going to put in form, this one will be email, and then we'll do mobile and city. And here we keep going. We'll put in form group. And we'll be able to have the type of tool for putting in mobile. So as you can see, because we're using just standard HTML here, you can actually reference external libraries such as JavaScript libraries for formatting the field that you're in, regular expressions, things like that. And let's put in our final value, which will be for city. And normally when I'd be writing this by hand, I would actually be copying and pasting sections of code and just changing the values as necessary, just to make it easier on myself. But here I'm just typing out everything for you so you can see the whole process. Okay. All right, so there are our values. Of course, remember, save your files as you're going along. Everything looks good. And we're matching up our values with our records. And we want to have a button that allows you to submit. We also want to have a button to select view all if you want to be able to view all of the records. Okay. Looking good. Okay, let's go back over to list. Now we want to be able to pull our records. So this will display the list of students in a table. Right. Let's go ahead and format that table. So we're going to put together our format here, but then we're also going to add buttons at the bottom so we can actually add a record to the database, or if we want to add or delete a particular record from the database. I'm going to call this one create a new student record for our student list. I'm just going to type all this in for you. And you'll see how we put placeholders for the values as we put them in. These are our table headers. Okay. Putting our body content. And what we're going to do here is we're going to add in an element that allows you to create a row for each item listed. So if you have 2 or more items, they'll appear as an individual row on here. And again, what we're doing is we're pulling in the values to be able to pull from the model that we created earlier on. So this being the data that's been submitted. So we're going to have it pull in the value for the email, full name, and mobile and city. We're not going to show ID. So it's pulling out all of this data that we created earlier on. So we have everything posted into our list as documents. So let's go into a HBS file, and it's our list. Let's put in our file entry here. This will be for city. Then this is just a placeholder at the end of the list. Oh yeah, what we're going to do is we're going to add in reference for the ID. So if we want to edit the document, we can. And then we want to do the same thing if we want to delete the document. So href equals student, and then just delete. Now delete based on the ID. There we go. Passing that instruction over. So click, turn, simple. I'm going to ask him, are you sure you want to delete? If somebody clicks on the record, they hit cancel, then it won't get deleted. If they hit OK, then it will get deleted.
is why you can actually write JS inline. Okay. And then we want to close out where the row will end. So have each opens and closes the record. Just tidying up some of the HTML there. Save that. Okay, looking good. Back to our root index file. So let's see now. We want to also require our model, and then we'll have our student controller also be a require, and where it's going to pull the student controller from. Okay. And this is just the instructions on where we can actually find content. Okay, looks good. So let's do node index.js. Everything's saved. We're going to rerun everything. And we got an error. Let's go check out where our error came from. So let's go into our files. This is one that we created. So error is in student controller. Let's see, where's the error? Oh, we need to have our module. We need to export our module to our router. All right, let's go open up Mongo database. And we can start seeing where the records are. It's just installing the latest updates here. So we need to go ahead and put in our connection string. So it's on localhost. And that's the port. Let's just double check that, make sure we're completely aligned. So here's our database connection. And there's our port and student database. And we did this with Mongoose for connecting to Mongo. So I'm going to connect. And here are where our records are being stored. So we're going to create a database, and we're going to call this database. It's going to be called StudentDB. So StudentDB has to be case sensitive. And the collection name is students. Let's go ahead and create a database. So there we are, there's our database. And let's go rerun our index.js file. And everything was successful. This is good. All right. So everything should have passed successfully. Good, good, good. Database connection is good. So let's go to localhost. And here we are. So we can start actually navigating through our application. So we see we have our setup. We have no records. So let's go ahead and create one. And we go through, you can actually start stepping through the different layouts that you've created. So here's our layouts, they're separate to our code. So there's some spacing we probably need to add there. So let's go ahead and just add that. And let's rerun our code. This is the fun bits where, everything is just tidying up. Okay, so it puts in one space because we didn't put in the actual HTML code for creating multiple spaces. So we're going to go in and select
insert. So let's put in Smith, and we'll do smith@gmail.com, and let's just put in, I know, random phone number. There we go. We don't have any formatting, so we could put anything in there. And the city, I know, where am I? I'm in Delhi, so submit that. Hit submit, and it takes us to a list, and voila, we actually have a list with a record in. And if we go back to our database, we can actually refresh it, and now we actually start seeing our records being created. And we see the ID is automatically created, and there's our records. Okay, let's go back. And now we can select edit. We can edit the record. So let's change our city to Bangalore. We'll hit submit. All right, city is now Bangalore. And if we want to, we can edit again. And so this is pulling in, if we do a delete, it's going to ask us, do we really want to delete? Okay. A little bit of formatting applied there. And the records are all good, so we can make that Smith Jones. But because we need to hit submit, we wouldn't update the record. So we hit submit, that updates the record. We hit delete, it's going to say, are you sure? We say, yes, we are. And, it has, couldn't grab that record. Okay, so let's go back and look at our code. And because we have everything separated, we can actually now just go to our student controller, and we'll find our delete. There goes delete, and we had a couple of minor errors there. This is where it's good to test out your code. Okay, let's run that again. And refresh everything. So we go to our database. We're going to go create a new entry. Let's call this one St. John, john@gmail.com. We'll put in a phone number. You see the formatting is just playing from our Bootstrap. So there we have. There's John. Do we want to delete? Let's say yes. Ba-boom! Yeah, easy. There we got it all solved. And we hit refresh, the record should be gone. Yep, it is. And so we've created an application where we can update applications. We can create an application, we can list all the items. And we did all of this using just open source solutions through Node.js. And that was with using Express, some of the components that come with Express, MongoDB for our database, and then Mongoose to connect to our database.
Hello everyone, and welcome to Simplilearn's YouTube channel. I hope you guys are doing well. Today, we will be taking you through the Express.js full course. This Express.js full course is designed in such a way that it will help you understand the most widely used concepts of Express.js in an exciting manner. You will see how to create a simple REST API in this video. By the end of this tutorial, you will be able to understand and deploy the Express.js. Before we begin, let me tell you guys that we have regular updates on programming videos. So if you are a programmer and want to learn something new, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any update from Simplilearn. So let's go through the agenda for this full course. First, we'll see the introduction to this course. After that, we'll see what is Express.js. Moving ahead, we'll see how to install Express.js. After that, we'll see Express.js getPost method in detail. Moving ahead, we will see what is a middleware and its function. Then we will create a middleware in Express.js. Moving ahead, we will see Express.js REST API, and then We will see React with Express.js in this. We will also see how to connect the server side to the client side. After that, we will see what is TypeScript and how to connect Node and Express.js. And in last, we will be creating an user registration form with Express. So let's begin. I hope you guys are ready to learn something new. Now, we will start our first topic. Node.js is a fast JavaScript runtime environment, but it does not support request handling functions, HTTP methods, or serving files. So Express.js comes into the picture. Express makes the Node.js code easier, as Express provides a wide range of features to develop both web and mobile applications. It is used to build single-page, multi-page, and hybrid page web applications. As Express is written in JavaScript, it is very easy to understand for the developers who know JavaScript. Until now, Express is the most popular framework of Node.js. You must have heard about MERN Stack in web development, right? Where E stands for Express.js. It is a backend part of MERN Stack. It manages routing, HTTP methods, sessions, error handling, etc. Let's see what Express.js is. Express.js is a Node.js framework designed to build APIs, web applications, cross-platform mobile apps quickly and easily. It is very high performance, fast, lightweight, and unopinionated. That is, there is no structural way to write a code. Express does not force you to write a code in a fixed manner. Express.js is used as a server-side scripting language. Let's see the need for Express.js. But before that, let me give you an example. If you have to write a REST API using the core modules of Node.js and the same using the framework Express.js, you will realize that with the help of Express, it will take 5 to 10 times less code and time. That was the reason behind creating Express.js framework for Node.js. Express.js is time efficient, fast, money efficient, very easy to learn, and asynchronous. Let's see the features of Express.js. Fast server-side development. With the features of Node.js, Express saves a lot of time. Middleware. Middleware is a request handler that has access to the application's request-response cycle. Routing. This refers to how an application's endpoints, URLs, respond to client requests. Templating. It provides templating engines to build dynamic content on the web pages by creating HTML templates on the server. Debugging. Express makes it easier as it identifies the exact part where bugs are. Let's see the advantages of Express.js. Express is unopinionated and we can customize it and use it as per our needs. As it is written in JavaScript, a single language is used for front-end and back-end development. Express is fast to link it with databases like MySQL, MongoDB, etc. Let's see the disadvantages. The disadvantage of Express.js is that there is no structural way to organize things. Sometimes the code becomes non-understandable. There are so many issues with callbacks. The error messages that will come are very challenging to understand. Now we'll see the companies that are using Express.js. The major companies are IBM, Uber, eBay, PayPal, Accenture, Fox Sports, Netflix, LinkedIn. As per the nlib.com, there are more than 34,300 companies that are using Express.js. Now, I think you guys have a brief idea about Express, as it is a lightweight framework that gives functionalities to make Node.js easy. Express.js is trending so much because it is helping so many developers to save their time. It is so awesome that most of the companies are moving towards it. If you know JavaScript and Node.js, the framework Express is what you should know to strengthen your coding skills. Now here, you'll find downloads. You can download Node from here and install it. But if you find any difficulties downloading Node.js, you can click on the link in the right corner to see how to download Node.js. Now, let's see the version for Node to verify. Here, I am using Visual Studio Code. You can go and search it and simply download VS Code. After opening your Visual Studio Code, it will look like this. Here, you will find a terminal. Click on it. The terminal window will open. Here we will write node-v. This will show us the latest version of Node.js. Now we need to update the npm, which is Node Package Manager. This bundle consists of all the repositories and packages required for development purposes. To do that, npm install npm globally. npm install npm hyphen globally. This will download all the npm packages globally. Now, let's create Express. For that, first, we need to create a separate folder where we will keep all the modules and files of Express.js. Let's clean this. cls. You can open the terminal by clicking on the shortcut also by pressing Ctrl and backtick. That will open the terminal for you. Let's make a folder mkdir. This is a command that is used to create a folder on the terminal. Then we will write our file name. I will write express by Simplilearn. Enter. Here you can see the file name express by Simplilearn has been created. You can also click here and enter your file name m.js. Press enter. As you can see, a new file has been created. Now we need to install a package manager, that is npm. We will write a npm command. Open your terminal again. Write a command npm init. Enter. Enter. Version. Enter. Description. In description you can write express tutorial by Simplilearn. Enter. 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 Git repository. If you have your Git repository, you can add yours. Enter. Enter. Author. Simplilearn. License. Enter. Press yes. After this, you can see npm created a JSON file. Now we will finally install Express.js. We will write npm install Express. Enter. Now, as you can see, our Express is installed in our system. Let's open the app.js that we have created earlier. Now, we will create an Express application with the help of Express functions that we can do by requiring the Express modules. Let's create our first program. First, constant Express require Express. In this line, we are requiring the Express module. Const file name equals to function express dot get to get the file
request response to get the request and the response of the user. Function we will need to pass callback function here. Let's write response send. This message will be shown in the server. Welcome to Simplilearn. Now here we will write a port number where the message will be shown to us. Add.lesson 4000. You can write anything. Here also we are passing the callback function. Console.log. In console log, we will see the message in the console. Listening to port number 4000. Let's close this line. Save this. Let's run it. Open your terminal, new terminal. Now, to run this file, we need to go to the Express folder. cd Express by Simplilearn. We are now in a Simplilearn folder. Now, easiest way is to write the file name. Write node space the file name app.js. Enter. Now you can see it is printing our message listening to port 4000. Now we will see a message on the server. Open your Chrome. Type localhost 4000. Press enter. And here we go. A message is successfully displayed. Welcome to Simplilearn. Get and post method are the standard HTTP requests used to create REST APIs. Get and post methods are used to send and receive significant amount of data. The client sends a request in the form of JSON file, and with the help of HTTP requests, which are get, post and other methods, it will go to the server, and then the server sends back the response to the client in the form of a message to tell what happened to the request that was sent to the server. Now, Express.js get method. Get is a method that is used to request data from the server, but mainly this method is used to read data. To handle GET request in Express is pretty straightforward. GET requests are to be cached and remains in the browser history, and that's why the GET method is not used for sensitive data. To get the data, we add parameters in the URL and get data in response. GET method is more efficient and popular than the POST method. Now we'll see Express.js POST method. POST method is used to create new or to edit already existing data. This method is used to communicate with large amount of data. The POST method is secure because the data is passed in a request body and not visible in the URL, and the user is not able to bookmark it. Mostly we use GET method only, but when we want to send a sensitive data, we use POST method. Now we will see how to get the POST and GET methods work. Now open your Visual Studio Code. I have already installed Node and Express.
If you haven't installed it, then you can click on the right corner of this video to get the setup done. Coming back to Express get and post methods. Now, what I have done here is I have created a basic Express.js app. Const app require Express. This will install all our Express modules. Now, first we will write our get method. So let's start. First we will write get method. Then we will initialize how it will be called. We'll write get request. Now we'll create a function request parameters, request and response. Then we'll write the fat arrow function. In this we will send a response to the server. Hello, this is full get request. I have not initialized the brackets. Let's see what I have not done. Oh, I forgot to write this. Now let's just save this file. We will run this file. Open your terminal and write node dot, and I think I have done something wrong. Let's again open the terminal, write node dot. So it is showing server is successfully running on port 4000. Now we'll open our Chrome and write localhost, enter. As I have told you earlier, this needs a parameter, so we'll initialize here get request. Hello, this is successful get request. So our request method is working fine. Now we'll go back to the post method and see how it goes. App dot post. Request. Response. Response send. Just like this only. Just post. Hello. This is successful post request. Now we'll save this first and then run it in the terminal. Yes, node dot server is running on 4000. We have to write this. So first copy from here only. Open your terminal. And here we can write post request, enter. So what you can see here is it can't get post request. For this to see, we need to have the postman. I'm using postman here. Here I will write post method, and here I will write the localhost 4000 and the post request method. Then we'll press send. Here in the body part we will see hello, this is successful post request. How this is working is because post method is secure and data is passed in the request body, and it cannot be fetched in the URL.
What is middleware? Middleware is a request handler that has access to the application's request response cycle. It is a function that contains the request objects, response object, and the next middleware function. Middleware can also send the response to the server before the request. The next middleware function is commonly denoted by the variable named next. Simply, middleware is a function that can only be applied using routers. With the help of middleware, we can access and modify request and response. Now, we'll see what are the functions of middleware. Middleware can execute any code. It can make changes to the request response objects. Middleware can also end the request response cycle. It can call the next middleware function in the stack. We use these functions to modify our middleware to perform many tasks. Like if you want to block our site from some country, or if you want to check the authentication of a user, etc.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now, we are going to create a simple middleware. We can create a middleware in a router file, but the best way is to create a middleware file separately and then use it. Creating and using middleware is very easy. Now, we first need to create a basic Express application. But before that, you must have all the app packages to run Express. You can take the help of our video, What is Express.js? The link will be in the description. You need to install npm express to run this. So coming back to our application, first we need const express application. So we'll write constant express require express. Now we'll write constant app equals to express function. Now to get the data, we'll write app dot get request response. Function, write response send. Welcome to Simplilearn. Now we'll copy paste this to get the home page. The better way is to copy paste it here. Here we'll write the extension of the next page. Home will say, and welcome to the Simplilearn's home page. This is a very basic middleware application we are going to create. Just home page. Now we'll make it listen to some port. So we'll write app.listen to port. We'll say port 4000. Again, that arrow function. Console log, write listening 4000. This message will be prompting to us on the console, the terminal. So we'll close these brackets. Now we'll save this file. Open your terminal. First we need to go to this folder cd express Python. Enter. Now we'll write file name app.js. Enter. So it's showing listening to port 4000. Now we'll open our Chrome local server, type localhost 4000, enter. So it is successfully showing us welcome to Simplilearn. Now we'll go to the next page. We have written there home, enter. So it's successfully showing welcome to Simplilearn's homepage. Now we'll create a middleware. Go back to that file. We'll write instant require filter. Request. You can write anything here. Request object. Response object. And next. And the fat arrow function. We'll write console log. Here we have written request filter. We'll use this by writing app.use request filter. And save this file. Now we haven't called our next parameter. In Express framework, next is a function. What we'll do is we'll call it in the bottom of our middleware. We'll write next function. Save this file. Again, we'll open a new terminal. Where we'll go to our folder express by Simplilearn. We'll write node, the file name app.js, enter. Now I'll open our file, go to the home, write localhost 4000, enter. Here it is printing welcome to Simplilearn. We'll go to the home page. /home. Here, welcome to Simplilearn's homepage. With this, we have successfully reached the end of this video. NPM, which is called as Node Package Manager, is Node.js built-in package manager by default. And Express.js is a framework of Node.js, which is fully built in JavaScript. It was first made and available for use in January 12, 2010. Let's move on to what is NPM. Let's take async as an example. NPM is incredibly easy to use, and all you need to do is to type npm install async to install the desired module in the current directory under node module folder. You may use need function on them as they use built-ins once installed in your node modules folder. The biggest software registry in the world is NPM. There are more than 80 lakh code packages in the registry. To share software, open source, developers utilize NPM. NPM is often used by businesses to control private growth. All of the Node.js packages and modules are managed through NPM, which also includes the NPM command line client. Along with the installation of Node.js, it is added to the system. NPM is used to install the necessary modules and packages in the Node project. Moving ahead, let's see what is a package. In Node.js, a package includes every file required for a module. You can add module in a JavaScript libraries to your project. Now, let's see the functions of Node Package Manager, which is NPM. Online Node.js packages, modules, repositories can be searched on nodejs.org. Use a command line tool to manage Node.js packages, dependencies, version control, and installation. Now, let's see how to install NPM. To install Node Package Manager, we have to install Node.js. For that, you have to download Node.js and install it in your system. Now, we will see the version of Node.js. Go to Terminal, New Terminal, and search here for Node-v, which is denoted as version. Enter, and this is my version of Node. Now, we will verify the NPM version. To do that, we have to run a command, write npm --version. And you can clearly see my NPM version is 8.5.3. Now, we will see how we can install Node modules using NPM. There is a very simple syntax for that. We just have to write npm install and that module name. Now, we will install the famous web framework module of Node.js. We will simply write a command npm install express. This is a very simple command you can write in your console or terminal and then press enter. You can clearly see the express is installed in our system. What is error handling? Error handling is a process in which Express catches and processes the error that occurs synchronously and asynchronously. Express comes with its own default error handlers. Simply, in error handling, the tasks are to identify errors, report them to the users, and then develop some recovery strategies and implement them to handle the errors. This whole process should not slow the overall processing time of the program. Now, how does error handling works in Express.js? Express.js comes in with a built-in error handler. This default error handling middleware function is added at the end of the middleware function stack. It automatically catches all errors in router handlers and allows developers to extend router handling functionalities by middleware function. Error handling in Express is done using middleware. This middleware is defined in the same way as other middleware functions. The error handling functions have 4 arguments: error, request, response, and next. We have next function method that matches us to the next middleware handler in middleware. In error handling, we have the next error method. This function skips all middleware and matches us to the next error handler for the router. Now, let's set up our error handling with Express. Open your Visual Studio Code.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
First, we will create a new directory. For that, open your terminal, new terminal. Let's write make directory. Now I will enter the directory name. I will write Simplilearn, or you can also write error handling. Press enter. You can see the error handling directory has been created. It's empty. Let's go inside that. cd error handling. Now we are in the error handling folder. Now let's create a new project here. We'll write npm init #y. So as you can see, the JSON file has been created in the error handling folder. Now we will install couple of packages here. Okay. First, we will install Express. Write npm install Express. Now we will also install Morgan, which logs the request. After that, we'll also install HTTP errors. This package makes it very easy to check the status code. And then last, we will install Node.env. Press enter. This will take a couple of seconds. Now, in the dependencies, you can see .env, Express, HTTP errors, and Morgan. Now, I will create a file in this error handling folder. Right, app.js, enter. Now, let's install NodeMon, which helps us not to reset our file again and again. For that, we'll write in the npm install -sign save NodeMon. Enter. This will also take a couple of seconds. Now, here you can see the NodeMon has been successfully installed. Now, open your package.json file. Here, in package.json file, you can see here this line. I will rewrite this. You can also remove it. Let's write script, and in this I will write NodeMon app.js. Yes. Save this file by pressing Ctrl S. Yes. Now open the file app.js. Here we will be importing some packages. In Node.js we use require function, right? So we'll write const express require and express. Here we need express packages. Now we will be needing Morgan. We will write const Morgan require then Morgan. Now, like this, we will need HTTP packages. Const error create error. Require HTTP errors. We also need .env packages to import our environment variables. For that, we will simply write require backend .env .config. For this command, we need an env file. We will create a file .env window. And here we have our env file where we can have our environment variables. First, we want a port for this application. So we will write the port 3000. Save this file. Now, again go back to the app.js file. Here, first we will be initializing our app. We'll write const app express function. Now we will start the application. For this, we will write const port, to which it will be called process .env .port 3000. Now we will make our application listen to port 3000. We will write app.listen port number port. It will call the port number, and here we will call the callback function, header function, and here we will make our log statement. For this, we'll write console.log backend server is running on port $sign and port. Now, let me start the application. Before that, we'll save this file. Now, to start the application, we'll write npm start. Enter. Here, it is showing error. Let's find out. Okay. Here I have wrote script. Here we need to write start. Save this file. And now clear this screen. Enter npm start. So as you can see, it is successfully running in the port 3000. REST API are the standard way to send and receive data for web services. Client sends a request which goes to the REST API, then to the database to get or put the data. After that, it will come back to the REST API and then to the client. Using an API is just like using a website in a browser, but instead clicking on the buttons, we write code to request data from the server.
It is very flexible and can handle multiple types of requests. RESTful API is very popular and very commonly used to create APIs for web-based applications. What is Express.js? Express.js is a Node.js framework designed to build APIs, web applications, and cross-platform mobile applications. It is used as a server-side scripting language. Express.js is high performance, fast, lightweight, and unopinionated. We'll see what is REST API. But before that, what is REST and what is API? REST means representational state transfer. REST is a popular architecture which is used to create web services. Now, API is an application programming interface. It is a code that allows two software programs to communicate with each other. REST API is a software that allows two applications to communicate with each other with the help of internet and various devices. Now, we will see the HTTP request types. First one is GET. It is used to request data from the server, but mainly this method is used to read data. Next one is PATH. It is used to update the data or to change or replace it. Next is POST. POST method is used to create new or to edit already existing data. After that, it is delete. Delete method is used to delete the data completely from the server. Now, we will see the complete architecture of HTTP request type. In this, client sends a request in the form of JSON file, and with the help of HTTP request, which are GET, PATCH, POST, and DELETE, it will go to the server and then sends back the response to the client in the form of message to tell what happened to the request. And now, we will create a simple RESTful API from scratch.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
First, you need to open your editor. For this, I am using VS Code. For this, you need to open your folder. Created one folder in the C drive. Express.js. Opening. For this, you need to have Node.js installed. First, open your terminal by clicking on Terminal, New Terminal. First, we'll write npm init -y. Press enter. This will create a JSON file for us. Now let's install Express.js. For that, we'll write npm install express. Press enter. This is installing Express.js. This will add all the dependencies. For now, we have only one Express installed. We need a file here to write our code. So we'll create a file called index.js. Enter. In this file, we will write all our code. Open index.js. First, we'll write const app where express
Express in this line we have imported the Express package, which itself is a function. So we'll write parentheses here to initialize it. Now we'll write const port. We'll write the port number. I'm writing 4000 here. This will call a variable which is 4000. Now we'll write app.listen. Till now, our API hasn't defined any endpoints. This app.listen tells the server to listen on specific port, which we have defined already as a variable 4000. Now, in app.listen, we will write a second argument as callback to tell us the API is working or not. Then we'll write port, comma, we'll write the callback function here, we'll write fatter function, console dot log backtick it's running on HTTP localhost $sign and port, which will come under curly braces. Now we can run this app by writing a command on a terminal. First save this file. In terminal. Now we'll write a command to run this file. Index node file name index.js. So it's successfully showing us it's running on HTTP port 4000. Open your Chrome or anything. I'm using Chrome here. I'll write localhost 4000. Enter. Localhost. Enter. Can't get. Now, if you open this URL, you will see this message. Can't get. This is because we don't have any API endpoints as of now. But Express.js is still responding with error message. You can add an API and call it. Every application consists of front-end, back-end and the database together. They form full stack. And in this video, we will be talking about React and Express.js. React was created by Meta and it is used to make web applications responsive. Express.js is unopinionated and it is used to make APIs. Express is maintained by Node.js. Let's see what is React.js. React is a JavaScript library which is used to build mobile and web applications fast and interactive. It is an open source, reusable components-based front-end library of JavaScript. Basically, with the help of React, we can create a client-side application or user interface. It is a combination of HTML and JavaScript. Let's see the features of React.js. First, JSX. It is a syntax extension of JavaScript. With the help of React.js, we can use the extension to see how the UI should look like. Virtual Document Object Model (DOM). It defines how documents are accessed and manipulated in the web page. Performance. There are several ways to speed up your React application by using virtual DOM. One-way data binding. Information flows in one direction. React receives information through arguments and pass it by returning values. React goes beyond simple UI and has many extensions for complete application support, extended with Flux and Redux among others. Debugging. It is a small browser extension to make debugging easier and faster. Let's see what is Express.js. Express is a Node.js framework designed to build APIs, web applications, cross-platform mobile apps quickly and easily. It is very high performance, fast, lightweight, and unopinionated. Express.js is used as a server-side scripting language. Let's see the features of Express.js. First, fast server-side development. With the features of Node.js, Express saves a lot of time. Middleware. Middleware is a request handler that has access to the application's request response cycle. Routing. This refers to how an application's endpoint URLs respond to client requests. Templating. It provides templating engines to build dynamic content on the web pages by creating HTML templates on the server. Debugging. Express makes it easier as it identifies the exact part where bugs are. Now, we'll see how to connect client side to the server side. First, we need to create a folder. I have created a folder named React Express. Let's see. Go to your C file. Here, I have created React Express folder. Now, we will be using a text editor. In this video, I will be using Visual Studio Code. Let's open it. Then, we will add all the npm packages and create a React application called client. Open terminal, new terminal. Let's write some command. npx create React app client. Enter. This will take some time. Until then, just wait. Yes, so it's downloaded. Now, as you can see, the client folder has been created with all the npm files. In this client folder, you will see all the npm files, node modules, JSON file also. Yeah. Now, we'll go to this folder, cd client. Now, to get this application running, type npm start. Enter. This command will start and compile this application. Now, it has opened a web page, localhost 3000. This is the first client-side application startup page. This will be now working as a client. Now, let's create a backend application. For that, first, clean this terminal. Let's open a new terminal. Type npx express generator folder name. Press enter. Okay. Now, this will take some time to install. Press yes. Why? As you can see, a API folder has been created. Now, we'll go to that API folder, cd API, enter. Now, we are in the API folder. Let's install all the packages, npm install, press enter. This will again download all the packages. So npm has installed all the packages required to run this. As you can see in the packages.json file, there are all the repositories and files that I used. Now, let's terminate this terminal. Now let's go to the client folder, cd client, press enter. Now we are in the client folder, npm this command will start and compile this application. Now we'll see the standard Express application that has got installed. We'll again go to the terminal, delete this terminal, create a new terminal. In this, we'll go to the API folder, npm start. This will start the terminal. Press enter. Now, we'll go to the Chrome, localhost 3000, refresh it. You will see the standard Express application that has got installed. What is TypeScript? TypeScript is an object-oriented programming language. It is a strongly typed superset of JavaScript, and all the code of TypeScript is compiled with JavaScript only. It is developed and maintained by Microsoft. TypeScript was created to develop large applications. It is mainly used to simplify the JavaScript code so that it can be read and debug easily. What is Node.js? Node.js is an open source cross-platform JavaScript runtime environment, and it runs on a web application outside the client browser. Node.js is used by the developers to build server-side web applications. Node.js is perfect for data-intensive applications since it uses an asynchronous, event-driven model. What is Express.js? Express.js is a Node.js framework designed to build APIs, web applications, cross-platform mobile apps quickly and easily. Express.js is unopinionated. It is high-performance, fast, lightweight framework of Node.js. Express.js makes the Node.js code easy as it is used as a server-side scripting language. Now, we'll see how to set up Node with Express and TypeScript. Open your Visual Studio Code, new folder which I have created in the C drive, TypeScript. It's an empty folder. I'll show you. Open the terminal. I'll show you it is empty. ls. So the folder is empty. Now we'll make a project inside it. We'll simply write npm init -y for all the default values. Press enter. So you have seen the package.json file has been installed in this package. Let's clear it. Now the first thing you need to install is TypeScript. Type npm d This will install the TypeScript dependencies. Now I will install 2 more dependencies. Please write npm I -node. I will also install nodemon. Enter. This will install all the dependencies that will be needed in this project. Let's clear the screen. Now we have to install Express. npm install Express. Let's wait for a couple of seconds. The npm Express has been created. Open the package or JSON file. Here you see all the dev dependencies, Express, nodemon and tsnode has been successfully installed. Now we need to create a project inside this folder. For that we need to write npx -init. Wait for a couple of seconds. Here we go. Clear the screen. Now we'll execute npx -init. So it has already been here. You can see. Yeah. Now we will be creating a source folder. For that, write mkdir rc. Enter. This would be containing all our TypeScript files here. You can see it's empty. Let's create a file here. Everything we are going to write is inside this file only. So your setup for TypeScript with Express in Node is ready. You can write anything here. The first thing you need is Node.js. Let's see. I have created one for me. You can create it by just entering a command make directory in the terminal and entering your folder name. It can be ABC or something you need, and like this it will be created, but I don't need it, so I'm going to delete it. In this I will open the terminal again. I'll write a command npm init y. This will create a JSON file for us. Like as you can see here, the JSON file has been created here. Let's clear the screen. Now we will install Express.js in this folder. For that, write a command npm install Express and press enter. This will install Express.js for us. You can also see here in the dependencies, Express has been successfully installed and all other modules are here. So let's clear the screen now. Now we will create a server file here. Let's name it app.js. Here we will write all our code. So let's create a simple Express folder. Write const express require keyword all our modules will be here. Enter. In this we are requiring express.js. Now we will also be needing port processes dot env dot port number that we'll gonna write here. I'm using port number 3000. You can write anything. This will be our port number now. Right. Create an app. In the next line we'll create an app. App express function. We have created an instance for express. Now we'll create to make it listen to our port. Let's write app dot listen port number. It will read by its own. Add arrow function. Console log. What we are gonna see backend server started at http localhost $$ to get the data of the port, and we'll write the port. It will fetch the number of the port. Here it goes. Now we have created a front end of this. I repeat, now we will create a front end of this registration form. So let's create it. First here, create a folder public. In this folder, let's create two files, index.html and the second one will name as style.css. Now in the index folder, we'll write all our front end code. So open index.html page, write doc and enter. This will create a HTML template for you. In the title, here we'll write registration form. Now in the body part, we'll write heading for this, h1, write heading, we'll just here the action will be class. So this will be heading, so we can style it afterwards. Heading. Now we'll create a form. Action here. Class will be form. Now we'll create an input types. First we'll create input type will be text, name will be write first name, this folder, this username will become inside the text box, this first name. Name. Now we'll create few more like this for password, last name, age, number. Let's copy this input. First one will be first name, second one will be last name, so we'll write the email, for this. This looks good. We'll write the email. For email we'll write password. Placeholder will write, it will be empty, so no one will see our password. This will be an empty. Let's write a place here, and we'll write in the placeholder password. Let's go to another one and let's create a first name, last name, email, password, and let's create one more, and that will be a age. For this we have to write here number. Name, we don't need name, I guess. Well, let's write age here. Age. Placeholder, what will we see inside the box in the front end? Here. Let's create a submit button. Type of the button will be submit. So we can give it style in this part. Here, submit. So our form is ready. Yeah, we'll write require here. So one will be left empty. This will help us to require every field because everything is important. We cannot make it empty, so we are writing required. So our HTML page is ready. Here, let's see how it looks on this HTML page. Here, our registration form look like this. Let me show you what require is doing. As you can see, please fill out this field. This is what required function do. Submit is. Now coming back to VS Code, we'll write some CSS code for styling. Here we'll write padding for the page will be 0. You don't have to write %. Margin will also write 0 for the overall page. Now we'll go to the body part. So the height will be 100 VH. Width will be 100 VH. Display size will be flex. Direction of the flex will be bottom. Right. Justify content will be in center. Alignment item center. This is how we will write a body part. Coming to the form of this page. Form. Height. Everything will be same. We'll copy this. Let's paste it here. Don't want the height of the form this much. It will be, let's create it 40%. Width will be 100 only. Display flex will be here. Direction of this will be column only. Justify contents. Let's see in the main. To our code. Let's make it not center. Let's make it as space. Round space. Let's make it space between. You can style it as your own, as you want. Heading. With the heading. Display will be inline block. This will make our page registration page look more clean. Back to the form. Here, input. Put the output. It will be none. We don't need it. Padding we can do 10% from this side and 20 from the input is okay. Now we'll go to, let's do something with the button. Height will be T. Padding will be 10% from this and 25 from the other side. The radius see pixel. So the color for this CP the color will look like this. It's not an issue. Sizing the submit button. Sizing will be the border box. This will look cool. Background color of the submit button will be black, and the text which is inside it will be white, so it looks clean as a registration form. It's done. You can also first save this file. Go to the file. A registration form look like this. Isn't it cool? Let's make this a little up. The heading part will give a padding for 40%. Get the CSS file, go to the form and see. Yeah, it looks cool now. Let's see, everything is working fine. Yeah. Coming back to our VS Code. Now, so our front part is ready. If there will be any changes, we'll do it later. Now, coming back to our backend part of this registration form, we'll make our first API routes. Here, it's right app.get on added on request response arrow function. Let's write here the response that the form will send. We will write the directory name of this HTML file. It's right here. Directory name plus public text.html. Let's save it. Coming back to our create post method also here. Form post and response function will be here. Request body. Here in this part, it will fetch the data in the body of the HTML page. Now let's create an API middleware. For that, use express.json .json. Here we are accepting the data in JSON format. After this, we'll use it again. I'm going to use express.url encoded function. This is basically to decode the data sent through HTML form. Dot use again. This will express dot, we will write static function will be public folder public this will use the public folder for us. Now we'll save this file first. Open your HTML file and write in the form part actions. Here we'll declare the file name app.js form class form, and we'll write method which will be post here. Everything looks good. We forgot to write inverted commas here. Save this file. Now open the terminal and write node app.js. Press enter. So our code is running fine. Let's open it. Yeah, everything looks fine.
But to name a few, a backend developer is the one who builds an effective website architecture, who also writes code to communicate with the database, and again, as mentioned, ensures data integrity and consistency. Now, essentially, a backend developer handles what you don't see. They're in charge of the backend of a website, which includes servers, database, applications, and so forth. So if you wish to become a backend developer, you can, but there are a few skills that you need to have. So let's look at the skills that you need to hone to become a successful backend developer. First up is data structures and algorithms. Now you must have a good understanding of data structures and algorithms. Understanding how the data is being stored is crucial. So concepts like stacks, queues, linked lists, sorting, and search algorithms are important. Next, we have programming languages and frameworks. One of the most critical skills of a backend developer is the in-depth knowledge of backend programming languages. This includes JavaScript and its environments like Node.js and Express.js. Java in particular was built from the ground up to be run on server side. So popular JavaScript frameworks like Spring and JSF are also important. Moving ahead, we have Python, which is the most popularly used language. Now it is flexible and easy to use, so there are frameworks like Django and Flask. Again, these are crucial and it's important to have a good understanding of these frameworks. We also have C#, which is a preferred architecture for backend programming. So it includes ASP.NET Core and .NET MVC. Now other programming languages include PHP, Perl, and Ruby. And since backend and front-end developers work so closely, it's also helpful to have a foundational understanding of front-end web technologies like HTML and CSS. Proficiency is required not only for performing daily tasks, but also for working alongside front-end developers to develop solutions. So moving ahead, we have version control. Now, version control systems help manage the project files and keep track of the entire history of users' things. So popular ones are Git, GitHub, and Subversion. Now, Git helps manage the project files. It keeps track of the entire history of things that the user is working on, right? And GitHub is a web-based service for version control using Git. Moving ahead, we have database management systems. Now, a backend developer writes code that is used to perform relational mapping to fetch data from the database. So some popularly used database management systems are MySQL, there's PostgreSQL, SQL Server, and you also have MongoDB. And lastly, we have web hosting platforms. Now, web hosting platforms allow you to deploy your product on a cloud service provider, so it can be accessed from the World Wide Web. Now, popular ones are Amazon Web Services, Google Cloud Platform, Heroku, and Microsoft Azure. Now, of course, a backend developer should also possess non-technical skills like problem solving, critical thinking, decent communication practices, and analytical skills. Now, they should be adept to working independently as well as in a collaborative team. Now that you're familiar with the skills, let's have a look at the key responsibilities and roles of a backend developer. To begin with roles, a backend developer could be assigned the following roles: backend developer, Java developer, full stack developer, DevOps engineer, software engineer, and iOS developer. And here is a list of responsibilities. First up is to form an understanding of the website's performance needs and goals to develop effective and efficient solutions. Development and management of application programming interfaces. Having a good knowledge on programming and ensuring framework utilization. Developing solutions for websites to accept and store data securely, especially for those involved with payment processing. Writing, testing, and maintaining the development solutions for code-related issues. Effectively communicating with developers, designers, and system administrators, and organization of system logic. Now, it's also crucial to ensure the development of website architecture using proper methodologies like Agile, Scrum, and Framework. And it's also important to know how to troubleshoot and debug applications. So now that you're familiar with those responsibilities and roles, Let's have a look at the backend developer's salary. According to Glassdoor, a backend developer in the United States earns around 102,000 US dollars per annum, while in India, a backend developer earns an average salary of 7,23,000 Indian rupees per annum. So now that you're familiar with backend development and know what the roles and responsibilities are, you must be wondering where to begin. Well, look no further. You can head to the official Simplilearn website and just search for backend development. A number of articles, courses, and programs will appear. You can also choose the one that suits you best. You can just click on the program and get an overview of what the course consists of. And depending on your requirements, you can opt for the course that is most appropriate for you.
Now, in the world of databases, the most common and well-popular databases are RDBMS, which is Relational Database Management Systems. Now, what if you want to develop an application which deals with a large volumes of data? Then we need to choose one such database which always provides a high-performance data storage solutions, so that we can achieve the performance in the solution in the terms of data store and the retrieval with accuracy, speed, and reliability. Now, if we categorize the database solutions, then there are mainly two types of database categories that are available. That is, the first one is RDBMS, like MySQL, SQL Server, Oracle, etc. And another type is NoSQL databases like MongoDB, CosmoDB, Cassandra, Hadoop, etc. More on that soon. But before we get started, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel to stay updated with all the latest technologies, and hit that bell icon to never miss an update from us. So without any further ado, let's get started. Firstly, let us discuss the agenda for today's session. We'll start the tutorial with a quick introduction to NoSQL, and then we'll discuss what exactly is MongoDB, and then we'll go through the history of MongoDB, which is when and how it came into existence, and after that we'll understand why we use MongoDB. Up next, we'll discuss some key salient features of MongoDB. Up next, we'll discuss how exactly MongoDB works, and then we'll go through some different applications of MongoDB in real life, and then we'll see which companies are using MongoDB in current days, and finally we'll understand when to use and when not to use the MongoDB. Now, before we understand what is MongoDB, it is important to learn what is NoSQL. Now, under the vast roof of big data, there lies a number of databases which are used to store these massive amounts of data that is generated worldwide. Now, one among them which is attracting a huge number of interest is the NoSQL database. The not only SQL or NoSQL database, which is often referred as with these two terms, is an approach that works towards managing data as well as the database design, which may come in handy for huge sets of distributed data. It consists of a number of technologies and architectures that seek a solution to the big data performance issues and scalability that cannot be addressed by the relational databases. Now, this database is used when companies and enterprises develop a need to access and analyze large amounts of unstructured data or the data stored in multiple virtual servers in the cloud. Now, there is no specific definition for what NoSQL is, but it is a common set of observation where we can describe that it is not a relational model. That is, unlike the traditional relational databases which store data in the form of tables which comprises of rows and columns, NoSQL database doesn't store in that way. Now, in NoSQL databases also we have various types of databases. Now, the first one is key value database. That is, it is the simplest type of NoSQL database, and every data element in the database is stored as a key value pair consisting of an attribute name or key and a value. So in a sense, a key value stored is like a relational database with only two columns. The key or attribute name such as anything like state, ID, your name, and the value such as let's say a country name, India. So that is one of a NoSQL database. And next we have column-based or column-oriented databases. Now, while a relational database stores data in rows and reads data row by row, a column store is organized as a set of columns. This means that when you want to run analytics on a small number of columns, you can read those columns directly without consuming memory with the unwanted data. And of course, we have the document type of database. The concept that is focused on in document databases, the documents that are stored and received from the database stored can be like a JSON or a BSON or an XML format. Now, these documents are usually similar to each other and are in a hierarchical tree data structure, that are self-describing and consist of scalar values, maps, collections, and etc. And finally, we do have graph databases, guys. Now, a graph database focuses on the relationship between data elements. Now, each data element is stored as a node, and the connections between elements are called links or relationships. In a graph database, connections of first class elements of the database stored directly. Now, in relational databases, links are implied using data to express the relationship. Now, these were some of the mainly used NoSQL database, guys. But in this tutorial, we'll be only focusing on the document database, and which is one of the most commonly used NoSQL databases out there. And the best example is MongoDB. And apart from MongoDB, we do have other document databases like Couchbase NoSQL database as well. Now that we've understood what is NoSQL databases, let us now quickly understand what is MongoDB. MongoDB is an open source document oriented or a non-relational database. Now it is different than traditional relational databases like PostgreSQL, MySQL or SQL Server because it stores the data in JSON-like documents instead of tables, and it is primarily used to store large volumes of data in the form of documents. Now traditional relational databases store data using tables and rows, right? MongoDB, on the other hand, is a non-relational database which has collections instead of tables. Now, documents are stored inside the collections in Mongo, where rows are stored in tables in traditional relational databases. Now, with MongoDB, the biggest advantage is the structure and schema of your data is flexible and not enforced by a predefined table definition, unlike relational databases, where you have to specify the schema, that is the structure of the table, the attributes and the values in it. Now, documents can vary greatly in size and shape within the same collection, whereas tables are more rigidly defined in a relational database. So when you're using MongoDB, it represents hierarchical relationship in a single record instead of joining multiple tables. So that is the main difference between a relational database and a non-relational database, and MongoDB, being a NoSQL database, follows the document data model, which is a collection of complex documents with arbitrary nested data formats and varying records formats. Now, because MongoDB does not store data in a structured table format, you cannot query it using SQL. Instead, MongoDB uses a more flexible and a dynamic query language called Mongo specific queries, which is based on JavaScript, which we'll be discussing in a certain while. Alright, I hope you understood what is MongoDB. Let us now go to the history of MongoDB, guys. Now, it is also important that when and how MongoDB has came into existence, even though we have several relational databases in the market. Now, MongoDB was first introduced in 2007. Tengen Software Company began developing MongoDB in 2007 as a component of a planned platform as a service product. So from 2007 to 2008, it was developed and it was working as a platform as a service product. Now in 2009, the company shifted to an open source development model with the company offering commercial support and other services. So from 2009, since it became an open source, the users can directly download it from the internet. In 2013, Tengen changed its name to MongoDB Inc. and it is working under the same banner. On October 2017, MongoDB became a publicly listed traded company on NASDAQ as MDB with an IPO price of $24 per share. Now, MongoDB is a global company with US headquarters in New York City and international headquarters in Dublin, and has more than 110 million download and regular users in the current times. And the latest version of it was released in 2022, which is 6.0. Let us now understand why MongoDB is used, guys. Now, since MongoDB is a NoSQL database, we need to understand when and why we need to use it in real life as well. Now, since in normal circumstances, MongoDB always preferred by the developers when our main concern is to deal with larger, huge volumes of data with a high performance. So if you want to insert thousands of records in a second, then MongoDB is the best choice for that. Now, also one of the main reasons is to overcome the limitation of relational databases or like the structured query language, guys, where the language is only used for certain databases of a limited records, right? So in order to overcome that, we use MongoDB since it is a robust and highly scalable, and it is also a powerful way of storing data in comparison to traditional databases. Now it is also highly flexible, which allows you to store and work on different data types in one document. Whereas in relational database, you store data in tables and you have to maintain a proper schema for that. So you need to join multiple tables if you want to retrieve certain amounts of data. And MongoDB also provides a lot of security, and it is also considered as a powerful query language as well. Now, as discussed earlier, MongoDB allows the user with flexible schema. That means it allows you to meet the ever-changing conditions, characteristics of big data applications if you're working on massive amounts of data on a regular basis. And also it gives you high performance with its incredible features like on-demand scaling, real-time resources, which will guarantee the user high performance of the applications. Let us now discuss some of the key features of MongoDB. Now, the first one is aggregation. Now, you might have heard about aggregation in SQL as well. Now, data records are processed by aggregation, which is grouping of data, which then produces the computed results into a single result. Now, in simple words, aggregation operations group values from multiple documents in MongoDB database together and can perform a variety of operations on the grouped data to return a single result. As said earlier, it is similar to that of SQL group by clause, where we use aggregation functions like average, sum, minimum, max, and others. Next, we have the gridfs. Now, gridfs is a specification for storing and retrieving files that exceed the JSON document size limit of 16 MB. Now, instead of storing a file in a single document, gridfs divides a file into parts, or which is called as chunks, and stores each of those chunks as a separate document. Now, by default, gridfs limits chunk size to 255 KB. Now, it uses two collections to store files. So, it is also another important feature of MongoDB. Now, next we have sharding. Now, in MongoDB, it uses sharding and replication, which are another key factors. Sharding allows partitioning of data across multiple servers using the shared key. And the technique of synchronizing all these organized data across many servers to offer redundancy is known as replication. Now, next we have document oriented. As we all know that MongoDB is a document oriented type of database. There are different documents to store different types of data, and each document has a unique system generated key. Replication, I think we have already discussed. And also MongoDB is a schema-less database. That is, it stores data in collections with no enforced schema. So in other words, incoming data can have a predefined structure and it can adhere to it. However, different documents in the same collection can have different structures if required. Indexing is also another key feature of MongoDB, which is one of the most important options to improve the search query performance. Now, as a result, we should index the fields that fit our search criteria. Like, without indexing MongoDB, it has to scan every document of the collection to get the required result that matches the query statement, right? So in order to eliminate that, we need to provide indexing for a faster query retrieval. Next, we have ad hoc queries. Now, in most cases, while designing a database schema, we don't know what queries we'll run ahead of time, right? So when we design our database, we may not be knowing the query types or the data that we process into our database. So ad hoc query is the query not known while structuring the data, or you can say that ad hoc queries are short-lived queries whose value depends on variables. So MongoDB supports these types of queries and can be also updated in real time. And finally, high performance. Performance means writing speed performance of MongoDB is far greater than any other relational database like MySQL. Those were some of the key features of MongoDB. So let us now understand how exactly MongoDB works, guys. MongoDB stores data objects in collections and documents instead of the traditional tables and rows which is used in relational databases. Now, collections comprise sets of documents which are equivalent to tables and relational database. Now, documents consist of a key value pair which are basic unit of data in MongoDB. Now, the structure of a document can be changed by simply adding a new fields or deleting existing ones. Now, documents can define a primary key as a unique identifier, and values can be of variety of data types including other documents and the array of documents. So it is basically works on a JavaScript query which is JSON, and it is further classified into BASON, which is a binary encoded object notation. So if you look at the picture in this, we have basically a host which ultimately has a server which stores the data. And further, we have databases wherein we have different collections, and in collections we have documents. So the data is stored in these documents, which is further presented into the collections and are saved into databases. So this is roughly how exactly MongoDB works. Let us now discuss some applications of MongoDB in real life as well, guys. Now, one of the main application is IoT or Internet of Things, which is one of the most appreciated technology innovations in the world today, connecting billions of devices globally. Now, with IoT, companies improve productivity, redefine their models, and leverage operational efficiency. So MongoDB helps to maximize this full potential of IoT devices. It's intelligent data platform which speeds up the operation and delivery of IoT devices. It is also extensively used in mobile applications because with the data that is being generated, like for example in social media, in internet, we need MongoDB to handle such amounts of our data, right? So it is also used in real-time analysis. Now with RDBMS databases, analytics and transactional databases were usually separate, and data from the transactional database would have to be moved to analytics environment, which requires an immense daily data load. Now with NoSQL databases like MongoDB, companies can now analyze data in real time while saving cost. For example, if you take stock market, we have tons or trillions amounts of data has been generated every day. So again in sports as well, which is a real-time data analysis, to get the insight we need the data in a quick and faster manner. So in that case we can use MongoDB as well. MongoDB is also perfect for catalog management, content management, as well as product data management, guys. It enables product data or the content related information to be managed and processed in a single central system. This allows for detailed cost analysis, increased productivity, gain new insights, and improve collaboration with the companies as well. So one of the best example if I take is the Aadhaar card, guys. It is a real world MongoDB use case where Aadhaar is India's unique identification project and world's most extensive biometric database system. Now we know that I think it was launched in early 2010s, and it has collected demographic and biometric information of over 1.5 billion people in India. So Aadhaar mostly relies on MongoDB among other databases like HBase, MySQL, Hadoop, which basically runs on massive amounts of data, which process huge amount of data in a real time. So MongoDB was one of the database systems first purchased to power the search strategy of Aadhaar card. Alright, let us now discuss some of the companies which are using MongoDB in real life, guys. So companies like Google, Facebook, Bosch, eBay are some of the companies which have extensively used MongoDB nowadays. And apart from that, we have other companies like, Toyota, Cisco, Adobe, SAP, AstraZeneca, Verizon, and other service and product-based companies use MongoDB on a regular basis. Now, apart from this, we have Shutterfly, we have MetLife, we even have Forbes, which use MongoDB on a regular basis. And that brings us to the end of today's session, guys. Now, before we wrap up the session, it is also important that you need to understand when you should be using MongoDB and when you shouldn't. Now, although MongoDB is a great database out there, there are times you shouldn't and you should use in certain circumstances. Now, MongoDB works extensively well with unstructured data, so it's great for big data analytic systems. So if you're working on huge chunks of data which needs real-time processing immediately, then you can use MongoDB. MongoDB is also used for cloud computing like Microsoft Azure, AWS, which is an ideal cloud computing platform for MongoDB because cloud-based storage needs to easily distribute data across multiple servers, and which basically suits MongoDB's nature. Now, if you do not have any database administrator, in that case, you might as well use MongoDB as well. Now, wherein you have lots of unstructured data to process and which has no storable data type limits. So in that case, you can use MongoDB. And finally, if you have schema issues, that is, if you have an unstable or undefined schema, you can use MongoDB, which is not with the case of traditional database, which requires a predefined schema before you start working on the database.
Now, since it's already installed on my system, the installation process will be different, but you just need to follow the steps there and finally install it. So once you're done with the installation, you can go to your C drive, and here you can click on program files, and you can see that MongoDB is installed. And inside of it, you have the server folder, and then you have the 4.4 folder, and then you have the bin folder, right? So here you have the application, that is your Mongo and the MongoD applications. Both are executable files. Now the MongoD file or the application is the daemon process. Now this is the background process that makes sure you retrieve the data from the database, access the data. So it does all the background tasks. So after the installation, now you need to create a path to this file. By doing this, you don't have to always go to the bin folder and then execute the file. You can directly execute the file on your command prompt, right? So for that, let's just go to our environment variables. But before that, let's just copy this path, right? And here under the user variable section, click on path and say edit, and go ahead and just paste it, right? I've already pasted mine, so just go ahead and paste it and click on OK and say OK, right? So now you've created the path successfully. Now let's head to our command prompt and run the Mongo file. So here you can just directly type Mongo since the path has already been created. So just go ahead and say Mongo, and here you can see that your Mongo server has been generated, and with this you know that your MongoDB has been successfully installed and your server is up and running, right? So just for confirmation, let's see if there are any databases and how much space they've occupied. So you can right now just type show DBS, and when you click on it, it says admin, config and localhost, and all of it is 0. So with that, you have successfully installed MongoDB on your system and it's up and running. All right.
Now, in contrast to structured query language or SQL databases, which is a relational database model where the structure of the database and its tables have been defined, MongoDB does not have or require the definition of a database or a table structure. Instead, we use data models in order to store the documents in our database. More on that soon. But before we get started, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel SimpliCode to stay updated with all the tech content. So moving ahead, let us now first discuss the agenda for today's session. We'll start the tutorial by understanding what is data modeling, and then we'll understand why we use data modeling. After that, we'll be going through how data modeling actually works in MongoDB. And next, we'll understand different types of data models in MongoDB. Up next, we'll discuss types of relationships in data models, and then we'll see some methods to create these data models. And finally, we'll understand when to use these data models as per our requirement. So without any further delay, let's get started with today's topic. Alright, so what is data modeling in MongoDB? Now basically data modeling is a process of taking unstructured data that is generated from the real world scenario and introducing it to the data server and then structuring it into a logical data model in our database. So it is basically a process of determining how data is stored and what connection exists between various entities in a relationship. Now, you don't have to create a schema before inserting data because NoSQL is flexible. This is so that MongoDB can support a dynamic database schema that makes it unnecessary to create your schema in advance. Instead, you can now store your information and make changes in accordance with your data. Now, consider data modeling in MongoDB as a relationship. Now, there is no particular relationship just like SQL where we use. Now, MongoDB relationships are the representations of how multiple documents are logically connected to each other in MongoDB. Now, since MongoDB is a document database, any document within the same collection is not mandatory. To have same set of fields or structure, you can store different types in a collections given field and can even add new fields, update fields, and delete existing fields as well. Now, for example, consider an online shopping store where we have like thousands of customers arriving daily and purchasing new products from the website. Now we get a lot of unstructured data, that is the name of the customer, their details and all, which is basically an unstructured data. Now, in order to convert into a proper structured data, we need to model them into a particular way. This is where data modeling comes into a picture, where we store the data based upon our requirement. Now, the main challenge in data modeling is balancing the application needs, guys. Now, the database engine's performance characteristics and also the data retrieval patterns. Alright, let us now move ahead and understand why we use data modeling. Now, data model basically helps us to create a simplified and optimized logical database that eliminates redundancy, reduces storage requirements, and enables efficient retrieval from the database. Now, data modeling may appear to be a complex process wherein you have to make adjustments to your database, unlike SQL where you predefine your schema and create a new table and then store the data. Now, while in MongoDB, data modeling helps us to analyze and understand what type of data and how much data has to be inserted into a database. Data modeling is necessary foundational work that allows data to be stored more easily in the database and has a positive impact on data analytics as well. Now, let us understand why exactly we use now data modeling. Now, data quality is paramount for any organization, and to ensure that, we need higher data quality when we are storing unstructured data in large amounts. Now, the visual representation of requirements and the business rules enables to anticipate what could lead to a large-scale data corruption before it occurs. So, data model enables the developers in hindsight to define rules that monitor the data quality and ensuring that there is no possibility of errors. Now, it is also important to understand how the data is flowing within the database and the characteristics of that. Creating data models forces the business to define how data is generated and moved across the application. Development and maintenance. Data modeling exposes errors and inconsistencies early in the process, making it easier and less expensive to fix. So, in order to maintain a database that is a MongoDB database, which is basically an unstructured one, it is important that we try to develop and maintain it in a regular basis. And finally, performance is another reason why we use data modeling. Now, an organized database is one that is more efficiently operated, and data modeling prevents the schema from endless searching and returns results more quickly. Those were some of the reasons on why we use data modeling, guys. Alright, let us now move ahead and discuss how data modeling works in MongoDB. Now, unlike SQL databases where you must determine and declare a table schema before inserting data or perform any operations, we need to basically provide a schema for that. Now, MongoDB's collection by default do not require the documents to have the same schema. Now, the documents in a single collection do not need to have the same set of fields, and the data type for a field can differ across documents within a collection. Now, to change the structure of the document in a collection, such as adding a new field or removing the existing field in a document or changing the field values to a new type or update the documents to the new structure. Now, basically the first step is to basically create and design a schema as per the requirement and the application need by the user. And then we have to combine documents. Now, if there is no scope for multiple documents to store into a single one, and ensure that if there is no other need for a single document to store in a multiple document, in such way we need to understand what is our requirement and combine the documents accordingly so that we can have performance as well as the optimization of the database is also improved. Now, this flexibility facilitates the mapping of documents to an entity or an object. Now, each document can match the data field of a represented entity even if the document has substantial variation from other documents in the collection. So this is how basically a data model works, wherein you have to choose as per the requirement and understand what type of documents that are being inserted into the database. Alright, let us now understand some data models that are used in MongoDB. Now, once you've understood the business requirement and the application on how it should be, as you start modeling your data, you will likely go through various steps of data analysis. Now, each step might produce different types of data models. Therefore, ensuring data models having the right one can be generally thought of as being one of the main aspect of choosing a data model, and they are conceptualized into three categories based on the level of the detail and the specificity. Now they are classified into three types. The first one is conceptual data model. The conceptual data model explains what the system should contain with regard to and how it is related. This model is usually built with the help of the user and the stakeholders. It represents the application's business logic and is often used as the basis for one or more following model. Next, we have the logical data model. Now, the logical data model will describe how the data will be structured. In this model, the relationship between the entities is established at a high level. You'll also list the attributes for the entities represented in this model. And finally, we have the physical data model, guys. The physical data model represents how the data will be stored in a specific database. Now, in this case, we have MongoDB model, where we are establishing a primary and a secondary relationship between the data in a document that is stored in the database such as MongoDB. We will also establish the data types for each of your fields that are mentioned. This will provide you with your database schema as well. Now, although MongoDB has a flexible schema, you need to data model or schema design. A good data model means that you'll establish a strong foundation for an ever-evolving data model. Now, MongoDB supports multiple ways to model relationship between the entities in a data model. Now, the first one is one-to-one. That is, in this type, one value is associated with only one document. That is, it will have a single relationship between the two connected objects or entities in the database. Next, we have one-to-many. Here, one value can be associated with more than one document or value at the same time. And finally, we have many-to-many. Now, when two or more entities within a document can have multiple relationship, that is basically is many-to-many relationship. In this type of model, multiple documents can be associated with each other. So let us now quickly understand with an example. Now consider the example for one-to-one relationship where I have a student table and contact info table. Now for each student ID, there is a unique details or the contact info. So it is basically pointing one value to another. That is student ID, which is one-to-one relation. And similarly, we have one-to-many relation wherein we have customer table and orders table. Now every customer has a different ID and a customer can place multiple orders. So it can generate multiple order IDs. So we have three different IDs like B204, B391, B448. So this is what is one-to-many, which is basically one entity is being pointed to three other values. I hope you understood one-to-one and one-to-many. So if you understood this, let us know in the comment section below what will be a good example of many-to-many relationship. Alright, moving ahead, let us now discuss the types of methods to create the data models. Now, once we are confirmed with what data model we need and the relationship that we have chosen for a document to store the data, we need a method that is to create a data model. Now, that is where we have two different data models that stores the data in documents. That is, first one is embedded data model. So in embedded data model, you can embed data in a single document or structure in MongoDB. It is also referred to as denormalized data model. It leverages the full potential of MongoDB's rich document and it uses one-to-one or one-to-many relationship, guys. Next, we have the reference data model, or in other words, it is known as normalized data model. Now, they are used to build one-to-many as well as many-to-many relationship models. Now, while working with the embedded document models, there will be times when you have to repeat the data. This is where reference data model comes into picture, which basically tackles the data redundancy. So I know it is a bit of confusing, so let's just understand this with an example here. Now, if you consider the embedded model, if you look at a document which I have taken here, which is the details of a student named Rohan, where we have a collection that is containing a document Rohan. In this document, we have embedded a document here that is contact details and his grade. So embedding data model stores relevant details in the same documents or the same database record. This way you can minimize queries and update required to perform common database operation. On the other hand, we have a reference data model or the normalized data model. So if you look at to the reference model example here, we have basically split a single document into 3 documents, and since contact details and grade have the ID from the document that is of Rohan's, you can call them whenever needed. Now, normalized data model splits the data into multiple collections by using references between the newer collections. You can update or change a single document which will update other collections automatically. This is an efficient way of updating data and is mostly used when your data goes through frequent changes. That is, if you're working on a data that has to be leveraged or changed on a daily basis, you can consider reference model. That is, which is basically one of the biggest advantages of using normalized data, where you have to model large data sets that follow a certain hierarchy, and you have to represent multiple many-to-many relationships. So that is where we use embedded model and reference model. As we know, MongoDB is a NoSQL database program that controls document-oriented data instead of a relational data model, which comprises of rows and columns. Now, the speed of MongoDB is one of its characteristics, as it handles a huge chunks of unstructured data. So, in order to perform a certain operation, MongoDB may use operators to carry out particular tasks in order to return queries more quickly and efficiently. So, in today's session, we'll be taking you through all about the MongoDB operators. What are they? The different types of MongoDB operators that are used, its functions, with the help of some examples. So, without any further ado, let's get started. So, what is MongoDB operators? Operators are basically special symbols or keywords that tell a compiler what mathematical or logical operations to perform. The operator improves MongoDB functionality by enabling the developers and programmers to construct sophisticated queries to communicate with datasets that are appropriate for their application and perform certain complex tasks to retrieve the data. Now, in general, we use the find command or method to fetch the data from collections using the query operator. Also, we need to use the prefix which is the $sign before the query operator. So, let us just quickly understand the syntax of the operators in MongoDB. The syntax is followed as db.nameofcollection.find, and within the parenthesis, we have to mention the field name and mention the semicolon, and then we have to mention the $symbol with the help of the operator that we want to use, mention the value, and finally we use the pretty method. So let us just quickly go through all these terminologies so that we'll have a better idea. Now, the name of the collection is basically according to the query operator we used in our query. This parameter is defined as the collection name from which documents have been retrieved. Next, we have the find method. Now, data can be retrieved from collections using this technique. We can also retrieve particular documents from MongoDB by using the find method with the query operator. Next, we have the field name. According to the query parameter we used in our query, this parameter is defined as the name of the field from which we are retrieving data. That is, what we are trying to retrieve data from our collection is basically the field name. Next, we have the query operator name, which must be used to retrieve the documents from the collection in accordance with the query operations. Next, we have to mention the value. The value is nothing more than the field value that we used with the query operator to conduct logical or any mathematical operations and so on. And finally, we have an optional tag, which is pretty. Now, since MongoDB output is generally in an unstructured format, so we can display our output using this technique in a structured format. And this is also optional, guys. So if there is a requirement to show the data in a proper structured way, you can use the pretty statement. So that was all about MongoDB operators, guys. So let us just move ahead. So let us now understand the different types of operators in MongoDB. Now, just like any operators in other programming languages, MongoDB operators are used to perform specific relational, mathematical, or logical operations and produce the final result. Operators in MongoDB are broadly classified into 3 types. The first one is query and projection operator. Next, we have update operator, and then finally we have aggregation pipeline operator. Now in MongoDB, the default for queries is to return all the fields in the matching documents. So basically a query and a projection operator is used to perform certain calculation, wherein a projection query is used to specify or restrict the data result returned in query result. Now by specifying a projection query, you can specify the fields you want to return or exclude. Now similarly, we have other query operators, which we'll be discussing in a while, which are used to perform certain complex calculation on the data that you're retrieving from the documents. Next, we have the update operator, which basically updates the value of all the fields of the documents, which is matching the specified condition. And finally, we have the aggregation pipeline. So it basically provides the competent results as a result of processing the data, records, and document. So it is similar to that of aggregate functions in SQL, wherein it aggregates all the values within a document and performs certain aggregation operation like sum, maximum, minimum, and so on. So these were some of the main different types of operators in MongoDB. So let us now just get into detail and how they are further classified into various types. Now query and projection operator further classified into various other types such as comparison operator, logical operator, array operator, element operator, bitwise operator, evaluation operator, and finally we have geospatial operator. Now, it is time taking to get into all of this stuff and explain each and every operator, guys. So let us just focus on the main operators that are frequently used in MongoDB. So firstly, let us discuss about the comparison operator, guys. Now, the comparison operators are basically used to compare two expressions and retrieve data from the documents. That is, the documents that we have stored. That is all the data from the collections, which are basically the group of collections, is basically a document in MongoDB that is stored in the MongoDB database. Now we have several such comparison operators in MongoDB. Now, as explained earlier, we have to use the $sign with the help of operator that we have been mentioning. So basically the operators take the $sign and then we have to mention the operator that we have taken. So let us just discuss some of the operators here. The first one is EQ, which is basically the equal operator, which matches values that are equal to the value specified in the query. Next, we have $NA, which has a full form of not equal to, which is opposite of equal, and matches all the values that are not equal to the value specified in the query. Next, we have GT and GT, which is basically greater than and greater than equals to. This operator basically matches the value that are greater than the value specified in the query, or that are even greater than or equal to the value specified in the query. Next, we have the LT or LTE, that is less than or less than equals to. Again, as the word goes, it is similar. Again, it matches the values that are less than the values specified in the query, or it matches with the less than or equal values specified in the query in the document. And finally, we have the in and NIN, which basically matches any of the value that is existing or not existing in an array specified in the query. I know it is a bit of confusing, so let us just understand this with an example here. So consider this example on your right hand side where you can see this image, which is basically a format of a document that is stored in a MongoDB database, guys. So let us say I have a collection named orders of, let's say, a stationery item database. Now I have further three different documents that are present in this collection. So basically a group of documents is basically a collection in a MongoDB database. So I hope you've understood what is a collection, document, and what is a database. So if you want to know more about it, we have a dedicated video on what is MongoDB, where we've explained clearly on all these terms and how it exactly works. Make sure you check that out, which will be quite helpful and I would highly recommend. So as you can see, we have basically three documents here. We have an ID of three different people who have purchased certain products from a stationery and have different IDs. So we have three customers here, Rahul, Pranav, and Kirti. Now, if I want to perform comparison operation for this, let us just understand how equal and not equal operation performs. So basically, I'm taking an example here which says db.orders.find, where payment mode is equals to card. So basically, the compiler finds all the documents that is present in this collection where the payment mode is made through card, which instead of cash. So basically we have here the details of two customers who have used the payment mode as card, which is customer Rahul and customer Kirti. So in this way, it will return these two following documents. And similarly, we have any, which is not equals to, and I'm taking another example, which is db.ordersFind order total is not equals to 600. Now, as you can see in the image, we have the third document of customer Kirti, whose order total is 600, right? So it basically evaluates this and returns the result, which has an order total which is not equals to 600. That is basically the first two documents. That is, it will retrieve the data from this document of the first, two documents, which is of customer Rahul and customer Pranav, whose order total is basically 2,450 and 5,800 respectively. So that is basically what is a comparison operator using EQ and NE, which is equal to and not equals to. Alright, moving ahead, let us now discuss what is GT and GT, which basically derives as greater than and greater than equals to. Again, let us consider the same, collection, same example that we have taken earlier. Now, the first query is basically for GT, that is db.orderFind order total is greater than 3,000. Alright. So we are basically performing a search query wherein we want only those documents whose order total is greater than 3,000. Now, if you look at the image, we have only, one document, which is of customer Pranav, whose order total is 5,800, which is more than 3,000. And similarly, we have for greater than equals to, which is db.ordersFind order total GTE 2,450. So basically, we should retrieve the document whose order total is more than 250. Again, we have two documents here, right? Now we have a document of customer Rahul and the customer Pranav, whose order total is 2,450, which is equals to 2,450 that we have mentioned in our query. So basically, the details of the documents of customer Rahul and customer Pranav, whose order total is greater than or equals to 2,500. Alright, moving ahead, let us now understand what is LT and LT, which is negation or complete opposite of greater than and greater than equals to. Now, in less than, we have taken an example, which is again order total, which is less than 2,000. So I guess we have only one record again here of customer Kirti, whose order total is 600. And similarly, less than or equals to 500. Now, I guess we have only one document again of Kirti, which is order total is 600. Oh, I'm sorry, less than or equals to 500, right? So we don't have any document of the customers which is less than or equals to 500, guys. Sorry, just pardon me for my mistake. I didn't check. So we don't have any customers whose order total is less than or equals to 500. So it will basically retrieve a null value. So that were some examples of comparison operator. Let us move ahead with logical operators now. So basically, logical operators return data based on the expression that evaluate the following condition to either be true or false. Now, in general, we have 4 different types of logical operators in MongoDB, which is AND, OR, NOT, and NOT, which is again similar with any other programming languages where we use a logical operator and similar to that of SQL as well. Now, basically, the AND operator returns all the documents that match the condition of both the expressions specified. And OR operator returns all documents that match the condition of either expression specified. Next, we have the NOR operator, which returns all documents that do not match the condition of either expression. This is basically an opposite of OR operator. And finally, we have the NOT operator, which basically returns documents that does not match with the query expression in a document. So again, let us just understand with an example by considering the same example, which is the order collection. Now, for first example, I'm taking AND operator, which says db.ordersFind and address city is either Delhi or payment mode is cash. Now, if I look into the collection here, I have only one such document where address city is Delhi and payment mode is cash. That is the details of customer Pranav. So it will retrieve only the document of Pranav here. Next, if I consider the OR operator, which is db.ordersFind OR city Jaipur or order total is less than or equals to 100. So we have Jaipur city whose I think it's of customer Jaipur. Yeah, it's of customer Rahul. So it will retrieve that one, and it will also retrieve those documents whose order total is less than or equals to 1000. Now we have only one document of Kirti whose order total is 600, which is again less than or equals to 100. So basically the first document and the third document will be retrieved in our query in a final resultant set. And finally we have the NOR operator, which says the city is not either Delhi or payment mode is cash. Now other than city Delhi and the payment mode cash, that is we have Pranav whose payment mode is cash and he also belongs to Siri. So basically it will remove the document of this person customer Pranav, and it will fetch the first and third documents, that is the customer Rahul's and the customer Kirti. So those were some of the logical operator examples we have used. I hope you've understood. So moving ahead, let us now discuss some element operators, guys. The element query operators are basically used to locate document, based on the fields of the document. Now, what that I mean is, so basically every document has a field, right? Now, for example, let's say in the previous example, I've taken ID, customer name, order total, and so on, which is basically a field. And now these fields have further values or elements to its name. Right, so the element operator basically finds all the documents based on the fields of the document that you're trying to search for. Now we have basically two element operator, which is exist and types. Exist operator basically returns documents that have a specific field. Now if I let us take an example. Let's say I have an collection employees, and I want to find the employee age as a field. I want to find if there is a field called employee age and his age is greater than or equals to 35. So I've taken this example which says db.employees find employee age exists true, GT 35. So if there is any field in our collection of employee age and is greater than 25 or greater than 35, it will retrieve those documents. And similarly, we have the type operator, which returns document if field is of only a specified type. Now, if I take an example here, let's say if I'm trying to find a field employee age again, and it is of double integer type. So if I want a particular field data type, I can use the type operator here. So that was all about element operator, guys. And let us move ahead and finally discuss one of the main used operator, that is array operators. Array operators in MongoDB are basically used to query documents that include a field of arrays. Now, we basically again have three different types of operators used in MongoDB. The first one is all operator. It returns documents from a collection if it matches all the values in the specified array. Next, we have the size operator. It returns documents from the collection to match an array with a provided number of elements in it. Next and finally, we have elim match, which returns those documents that match specified condition within each array element. Now, I know it is a bit of confusing, so let us just move ahead and understand with an example here. Consider the same example again, where we have three documents here. Now, for first example, I've taken the all operator, which is an array operator. So what I'm trying to find is, I'm trying to find a element of value which has, a notebook and a paper. So the query is followed as db.order.find orders item all notebook and paper. So if you look into the image, I think we have only two documents where we have this fields having notebook and paper, that is the first customer and second customer. If you look into the item name, we have notebook and paper in the first document, and second document also we have item name, notebook and paper. So it will retrieve these two documents. And next we have the size. So the size basically retrieves the number of array elements that you want in your resultant set. Now the query is followed as db.order.find where order items is of size 4. Now if you look into all the three documents that are present here, we have only one such document where it has 4 elements. Now if you look at the first document of customer Rahul, order items, we have 4 different fields. That is, he has placed an order on notebook, paper, general and postcard. Now, in contrast, if you look at to the other two documents where we have only notebook, paper and postcard for Pranav, and we have only notebook and postcard for Kirti. So which is against or which does not satisfy the size operator. So it basically retrieves only the first one, which has 4 elements or fields. So I think that was all about the array operators, guys. I hope you understood about all the query and projection operators and its different types. Now again, we have several mini operators like geospatial, comment operator and so many, but which are not that significant in its usage. But anyways, if you want us to cover in our further tutorials, let us know, wherein we'll try to cover a more detailed version of it with a hands-on experience with the MongoDB database as well. And finally, let us discuss what is update operator, guys. And basically, MongoDB offers a variety of field update operators to update the values of the fields in documents matching the specified condition. So it is basically similar to that of DML command, which is an update command, which is used to update the values in the columns. Now, similarly in MongoDB, there might be a possibility that you have to update some values, and that is where we have the update field operators. Now, there are again various such update operators. So let us just go through one by one. We have first one as current date, which is used to set the value of a field to current date, either a date or a timestamp. Next, we have INC, which is basically increment. It is used to increment the value of the field by the specified amount. Next, we have the min and max, which is used to update the field if the specified value is less than the existing field value or it is greater than the existing field value. Next, we have the MUL, which is a full form of multiply. It is used to multiply the value of the field by the specified amount. And finally, we have the rename. As a name suggests, this operator is used to rename a field within a document. So that was all about the operators in MongoDB, guys. I think we have covered almost all the important update operators that are used frequently on a general basis. I think this is quite enough for you to perform all the complex operations that you undertake to retrieve certain documents or values in your database. Now, projection in MongoDB is a special type of feature, guys, that is used to select only a certain part of the data without selecting the entire data present inside the document. So more on that soon. But before we get started, let's discuss the agenda for today's session. We'll start the tutorial by understanding what is MongoDB projection, and then we'll understand why we use projection in Mongo. And after that, we'll have how projection works in MongoDB and its syntax usage. And next, we'll discuss projection queries with the help of certain examples. And finally, we'll execute those examples in MongoDB server. I hope I made myself clear with the agenda. Alright, what is MongoDB projection? Now, MongoDB projection helps to return the specific fields from the query, or you can say from the MongoDB collection. Now, by default, when we query any collection in MongoDB, it returns all the fields in documents. Now, as you know, MongoDB is a schema-less database, which is a NoSQL database and has a different structure to that of relational database. Now, the tables in relational database are called as collection, and rows are called columns. We may not want all the records from the collection, but a few of them in the resultant set. So in that case, we use MongoDB projection using projection document, which is used to limit the amount or fields in the data present in that document. So in a nutshell, if I would say, projection means selecting only the necessary data rather than selecting the whole of the data present in the document. Now, similarly acts to that of where conditional clause that we use in SQL. Suppose if I have a document which has 10 fields, and you need to show why we use a popular NoSQL and open source document oriented database, which allows for highly scalable and flexible document structure, which is faster than relational database because of its efficient storage and indexing techniques. And being a NoSQL database, it is designed to handle large amounts of data. So DB will process a lot of unnecessary data and when you want to retrieve specific information from a large number of records. So to overcome this problem, we use projection query. Now, some of the reasons. Now, when using projection to remove unused or unused fields, the MongoDB server will have to fetch each document into its memory and then filter the results to return. Actually reduce the memory usage, but can save the significant network band for query results depending on the data model and the fields projected in your documents. And it only returns indexed query results without fetching the full documents. Which is basically the main use case of projection, which basically eliminates all the fields that are unnecessary for the user and particular fields within the document. Then he can use the projection query operator. And finally, filters data without impacting the overall database performance. Now, by default, this return all fields and matching documents. So, if you need all the fields, returning full documents is going to be more efficient, having the server manipulate the result projection, however, to improve performance. And that is one of the main consideration when we are using MongoDB projection. So these are some of the reasons on why we use MongoDB projection. Alright, let us now understand how MongoDB projection works. Now, in general, to retrieve the data from the documents, we use the find method, which retrieves data from all the fields within a document without any filtering. So let us now understand the syntax of MongoDB projection operator. Now the syntax is followed as db.collectionname.find, and within the parenthesis mention the field names, that is, I'm taking your field 1 and its corresponding value, field 2 and value 2. Now the values that I'm talking about is, if field value is set as 1, which is a Boolean expression which is equals to as, it will basically show the data in that field. Field value is, if the Boolean expression, it hides the data in the field. So let us understand this with an example, guys. Only then you will get a clear understanding of it. Now I have, let's say, a collection of certain documents. Let's say the collection name is orders, and I have 3 such documents here which has various fields like ID, customer, address, payment mode, email, order total and order items. Now, if I want to display all these documents, what I'll do, I'll basically write a query using the find method, which is followed as db.orders.find. So it will basically retrieve all the documents without restricting any of the fields that are present in our collection. Now, let's say if I want only particular field that I want to display in my resultant set. Now, let's say if I have the payment mode and the order total field, and I want only them to display in the resultant set without displaying all the fields that are present in each of the document. So in that case, I'll write a query as db.orders.find, and inside the parenthesis, I'll mention payment mode : 1 and order total is 1. Now, since I've set the field value to 1, it will only retrieve those values. And similarly for order total also, it will retrieve only that particular field value. So this will basically be the output of our resultant set. That is, it will show the ID object, the payment mode of the 3 documents, and similarly the order total of the 3 documents. Now, by default, we have the underscore ID, which is a default value which we cannot change it. So if at all, if you want to override and change it, you can mention it to 0. Now let's say I'm taking the same example here. Now instead of just writing payment mode to 1 and order total to 1, I'm adding another constraint, or I'm projecting another field which is of ID, and I'm setting it to 0. Now if you see in a resultant set, we do not have the ID field. So in this way, you can use projection in order to restrict certain fields from your resultant table set without actually retrieving all the data that is present in your documents. So let us now jump into Mongo shell and execute this example and see how it is working. So as you can see, Mongo shell has been started. Now, I don't want to get into the details of all of it. We will cover in a separate tutorial where we'll understand how to create a database and how to create a collection in MongoDB separately, guys. Stay tuned to the channel for that. So we'll just cover how we'll implement MongoDB projection with certain examples here. Now, basically, in order to retrieve the databases that are present in our MongoDB, we have to use the command as show dbs. So it will list out all the databases that are present. We have admin, config, local, and simplicode one. Now, I have already created the simplicode one in hindsight before itself, so that we can save a bit of time. And I've also created a collection in that. So before you see the collection and the documents that are present in it, you have to use the simplicode database. So for that, we'll use the simplicode one as our command. So as you can see, it is saying that switch to DB simplicode. Now, if you want to find all the collections that are present in database, you have to basically write as show collections. So it will list out all the collections in that. Now, as you can see, I have a collection that is of employee here. So for example, we'll consider this same collection. Now I have this below collection named as employee with let's say certain number of documents in that. Now if I query the collection in Mongo, the shell, if I write a command to it to return all the documents or fields from the matching documents by default, it will return all the documents. So for that, we'll use a statement like which is of db dot mention the collection name, that is employee dot find. So find method is used to list out all the documents. So you can just see that we have a lot of documents in our resultant set. Let me just scroll and go to the top. So as you can see, we have different documents, a number of documents, and it has different fields like ID, employee ID, first name, last name, email, phone number, hiring date, job ID, salary, manager ID, department ID, and so on. So you can see we have a lot of documents. So let's just count how many documents we have. For that, you can use the count statement. So db.employee.count. So you can see we have a total of 50 documents present in our employee collection. Now, if you look at our resultant set, after we used the find method, you can see it has returned all the fields of the document from the collection. Now, but what if I want to fetch only a particular field, like let's say first name, last name, email, or even their salary? How will we do that? Now, the answer is using MongoDB projection. We will project specific fields to return from the query. Now, so before proceeding to MongoDB projection, guys, let's recall how we fetch certain fields from, a traditional SQL database so that we can have a clear understanding. Now, let's say suppose the collection employee is a table in SQL, and let's say all the fields like employee ID, first name, last name, so on are its columns. Now, I want to fetch the only let's say first name, last name from the table. So in that case, what we'll write, we'll basically write a query as select first name, comma, last name from a table that is employee, right? I hope I'm clear with this. So it is similar to that in MongoDB, wherein we are executing this query as using projection. So let us now see how we do projection here. So let's just consider an example here. Now let's say I'm writing a command as db.employee.find. And let's say if I want to fetch all the documents of all the employees whose department ID is 30. So in that case, what I'll do is department. So it is case sensitive, guys. So make sure you write in the capitals or whatever the field is written as. So mention the column and within the double quotes, mention 30. So close the parenthesis and close the square brackets as well. So it will basically list out, as you can see, all the documents of the employees whose department ID is 30. So we can see we have employee ID of the employee 114, 115, 116, 117, 118 and 119 whose all their department is 30. Now again, even if I'm returning a particular field or a condition, it is also retrieving all the fields from all the documents. Now I don't want that. Now I want only a particular field. So what in that case, we will project certain fields without returning all the fields from our documents. So let us see how it works. So the query is followed as db dot mention the collection name employee, find, open the square brackets, and let's say I want to retrieve only the first name. So I'm setting it as 1. As we discussed earlier, if you want to retrieve the particular field, you have to mention 1. And similarly, I want to retrieve the last name as well. Last name, column, and 1. And also, let us take another field. Let's say salary. Right? We have salary also. Let us just retrieve that as well. 1. Alright, close the parenthesis and close the square brackets and enter. So we do not have any output here, guys. That is because we haven't mentioned the parenthesis before the find method. So let me just copy paste and we'll see how it is. So after the find, we'll have to mention the parenthesis again. And then I think we're good to go now. So as you can see in a resultant set, now since we have only mentioned the first name, last name and the salary, it is only displaying the results, only certain fields, that is the first name, last name and salary in a resultant set. Now by default, this ID object is retrieved with the command. So if you want to eliminate that as well, you can keep the ID to 0. So let us just execute that. So let me just copy this again, paste it, and mention another criteria, that is the field. Now the field should be, the field that is of ID should be 0. So close the parenthesis. So let us just execute this and we'll see how it is the output. So as you can see, now only we have the first name, last name and salary of all the employees. So we have just basically eliminated the object ID as well. So if you want only the first name, last name and salary in your output, you can just mention the field names and mention 1 if you want to display in a resultant set. And if you want to if you do not want to display those certain fields, you can mention as 0. So in this way, you can use the projection query operator in order to project only certain fields from all the documents. So yes, I guess that was all about the MongoDB projection, guys. Now, projection query operator can be quite useful when you're handling a lot of unstructured data. Let's say if the database has like 10,000 or even 1,000,000 records. In such case, if you want to return a specific number of fields only, now a document can have any number of fields like 10, 20, 30, 40 and so on. So in some cases, if you want to retrieve or specify only certain number of fields in a resultant set, in that case, projection operator can be quite useful. And I know it is quite confusing at the beginning, so you just need more practice to understand this in a more better way. So that brings us to the end of today's session, guys. I hope you've understood all the topics and concepts covered in today's session. So sorting and limiting are one of the necessary database operations. It helps to simplify and the readability of the data and sort the data as per the user requirement. Now, when you're working on huge chunks of data in a database, both sorting and limit operations can be quite handful to understand and visualize data in order to get meaningful information out of it and retrieve only the specified number of records accordingly as per your need. So in this tutorial, you will learn all about the sorting and limiting concepts and how it can be implemented in MongoDB database. But before we get started, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel Simply Code to stay updated with all the latest tech content. And hit that bell icon to never miss an update from us. So without any further ado, let's get started. So before getting into the execution part, let us quickly understand what is sorting in MongoDB. Sorting is the ordering of data in an increasing and decreasing order based on set of relationships between the various data items present in the database. Now, sorting can be done on any entities having information like ID, name, age, address, or any data type having numbers or string values. Now, sorting improves the readability and consistency of the data displayed from the database. So, in a nutshell, sorting is done just like in any other database or programming language that involves arranging data into some meaningful information to make it easier to understand, analyze, or visualize. Let us understand its syntax. The syntax is simple. It is followed as db.collection_name find.sort, and within the parenthesis mention the field and the order. So let us understand how it is. Now for sorting your MongoDB documents, you need to make use of the sort method. So this method will accept a document that has a list of fields and the order for sorting. So for indicating the sorting order, you have to set the value 1 or -1 with the specific entity based on which the ordering will be set and displayed. So if the order is 1, it will basically sort the records in ascending order, that is in an increasing manner. And if you mention the order as -1, it will basically sort the data in a descending order, that is in a decreasing manner. So 1 indicates organizing data in ascending order, while -1 indicates organizing in descending order. So that was all about the sorting in MongoDB. So let us now understand how sort method works in MongoDB with an example. Now consider collection name orders. Now if I just run a command db.orders.find, I'll get these collection which has 3 documents. So it has details of 3 customers like Rahul, Pranav, and Kirti, right? So let us now run a query where I'm using a sort method here, which is followed as db.orders.find, and within the parenthesis, I am basically projecting the query ID so that we will not have it in a resultant set. So, and also I'm sorting the data based on the customer here. So I'm mentioning customer as 1. So that means it will basically order in the ascending order. So this will be the output, guys. Now the output is, now first we'll have the customer details of Kirti, because the letter alphabet K starts first in the alphabets from A to Z. Next we have Pranav, which starts with P, and then we have Rahul, which starts with R. So this is a simple example on how sorting method works in MongoDB. Now let's say if I want to sort multiple fields in a collection, so in what way will I be able to do it? Now let us consider an example here. Let's say I have a pet info collection here, and we have various records, or you can say documents, and we have like various fields like name of the pet, type, and its weight. Now let's say if I want to sort multiple fields within this collection, so I would write a query as the collection name, which is petinfo.find.sort, and next I am sorting this collection based on its type, its weight, and finally the ID. So type, I'm giving it as 1, which will basically do in an ascending order, which is in an increasing manner, whereas I'm doing the sorting on the weight field as -1, which is in decreasing order, that is in descending order, that is from highest to lowest. And then I'm also sorting the field ID as ascending order, that is I'm giving it as 1. So when I run this command in MongoDB shell, this will what be a basically the output of the collection, right? So let us just understand how it is working. Now first I am sorting the data based on the type. Now the sorting is done based on the priority that is given, that is first you have given the sorting input as type, then weight, and the ID. So it will run the sorting based on this sequence only. So if you look at the first record of the document, we have the cat data, that is we have 3 records of cats having the same type, right? So we have Lily, Millie, and Oliver, which is of type cat. So basically it will arrange those in ascending order, since we have C, which is the starting or the alphabetical order of the alphabets, which comes the C comes first, then we have dog, next we have kangaroo. Now, since we have the same records or the same record of cat that is repeating, then it will check weight. Now, since we have given weight as -1, that is from descending order, that is why we have the record of Lily whose weight is 12 at the first place. Next, the details of Millie whose weight is 8, and finally we have Oliver whose weight is 7. So this means that if there are multiple pets of the same type, those pets are sorted by their weight in descending order. Now, if there are multiple pets with both the same type as well as weight, then those pets are sorted by the ID field, which we have given to sort them in ascending order. Now, if we hadn't included the ID field in the sorting process, then those pets of the same type and the sorting process, then those pets of the same type and weight could appear in any order, guys. So without having a sort field on a unique field such as the ID field, it would be entirely possible that the result would come back in different order when we run the query each time. So I hope you understood how the sorting works when we want to sort multiple fields within a document. So let us now understand what is limit in MongoDB. The limit method in MongoDB is used to limit the number of records. This method takes only one number type of argument, which is basically the number of documents that you want to display in your resultant set. Similarly, which we used to do in SQL also, wherein if you have like thousands of records, you use the limit clause in order to restrict a certain number of records and specify only certain records in a resultant set. Now the syntax is followed as db.collectionname.find limit and value. Now in the value you can give as per your choice. Let's say if I give the value as 5, it will display the first 5 records or the documents from that collection. And similarly, you can also use the projection where you can display the fields as per your requirement by giving the values and also the limit value. And simultaneously, you can also sort the data and the limit those collections or limit those documents in the collections as well. And the syntax is followed as db.collectionname.find.sort field order. You can give multiple field names in the sorting parenthesis and mention the limit method, and you can give the values, that is number of records that you want to fetch in your resultant table. So let us now understand again how a limit works in MongoDB. Now again, let us consider the orders collection here. Now let's say if I want to limit these collections. Now if I want to retrieve only the first 2 documents from this, then the query would be db.orders.find limit, and within the parenthesis I'm mentioning as 2. So this would be the output wherein you will get the details of Rahul and Pranav, which are basically the first 2 documents which are present in our collection order. Alright, now what if you want to sort and as well as limit the data? Now what I'm doing here is I'm basically projecting the ID field. So I'm keeping it as 0 so that we do not have this in a resultant set. Next, I'm sorting this collection orders based on the customers. So I'm giving customer as 1, which will basically sort the documents of the customers in an ascending manner, that is from lowest to highest. And then I'm limiting these documents for only 2 values. So when I run this query, this would be the output. So customer, I'm basically sorting in ascending order. So first we'll have Kirti, and similarly next we have Pranav in an alphabetical order, which is following the alphabetical condition starting from A to Z. And since I'm also using the limit clause here up to 2 values, it will only retrieve the first 2 values. So this is how limit works in MongoDB, guys. I hope you've got a better understanding on how limit works, considering this simple examples. So let us now jump into MongoDB shell with a proper execution and see how it gets executed. So as you can see, MongoDB shell has started, and let us consider the Simplicode database again. So let us write the command as use simplicode1, which will basically select the Simplicode1 database, and let us see what are the collections present in it. And we have the employee collection. So let us just retrieve the data that is present in this. So I'm using the find method, mention the collection name and mention the find method. So it will retrieve all the data that is present in it. So we have data like employee ID, first name, last name, email, phone number, hiring date, job ID, salary, manager ID, department ID. So firstly, let us discuss some examples using the sorting technique, guys. I think we already have employee IDs in in sorted order. So let us just take another field. Let us sort the manager ID field here. So the following query would be dd.employee.find, mention the sort, and within the sort mention the field name, which is manager ID. So I'm giving the order as 1, which will sort the order in ascending order. So close the parenthesis and let us execute this. So basically you can type it to retrieve all the records that are present. So let us just understand how it is working. Let me just scroll back. We have so many records, guys. So it's better we use the project field so that we can have a clear understanding. So next time we'll use that. So this is our query which we have executed. Now since I've sorted the manager ID in ascending order, which I have given the order value as 1, as you can see, since we do not have any manager ID for this employee Stephen King. Next we have the manager ID as 100, and next similarly we have 100, 100, 100, 100, and so on. And next we have 101 and 108. So as you can clearly see, 114 as well. So you can clearly see that our data has been sorted in ascending order when we are using the sorting technique. So let us now understand how we can do that with another sequence. That is, let us keep it as -1. So in that case, what it will be is db.employee find. So I'm going to project some of the fields because I don't want all these unnecessary fields in my resultant set. So I'll just opt them out. So I don't want ID field, so I'm keeping it as 0, and I want first name, my resultant set, so I'm keeping first name. Next I want last name as well, keeping it as 1, and next last name, and let's say finally manager ID only. Okay, manager ID. Let's keep it as 1, close the parenthesis. Now mention the sort keyword, open the parenthesis, mention the field that you want to sort in the way, that is manager ID. So it is important that you mention manager ID in the projection field, guys. So if you do not mention, and if you're sorting manager ID without explicitly calling it, so you will get an error, it won't display. So it is important that you mention the manager ID in the projection field also. Close the brackets. I think we are good to go. Let us just recheck our code. Okay, right. So I think there is an error in the manager ID, guys. So let me just copy this. So you might have a technical error, so make sure you give the correct name of the field's name, otherwise you'll get an error. So I think we are good to go now. So let us just execute this statement and we'll see the output. So as you can clearly see that in a resultant set, we are only fetching the first name, last name, and manager ID, since we have projected some of the fields in a resultant set, and I'm sorting the data based on the manager ID field, and since I've given it as 1, it will sort the data in ascending order, that is from lowest to highest. So if you can see, the first manager ID is 100, so list of all the employees whose manager ID is 100 has been shown. Next we have 101, 103. Similarly, if you type it, we'll have the rest of the records as well. So you can see next 108, 114, 120, and so on, 122, 123, 201, 205. So in this way you can sort various documents in order of how you want to display or show them in your resultant set. Alright, I hope you have understood this till now. Let us now sort multiple field, guys. So let me just copy this query. Now again, like as we discussed earlier in our presentation, sorting multiple fields is not a big task. It is just simply that you have to add the multiple fields here. So manager ID as well as, let's take salary also. So what I'm going to do is I'm going to sort salary in descending order. So I'm mentioning it as -1. And also let us project the field here as well. So salary as 1. All right, so let us execute this statement and we'll see the output. So as you can see in a resultant set, after sorting the data based on the fields of manager ID and salary, if we look at the output, now since we have sorted our manager ID in ascending order, since we have specified 1 as the order, it will basically sort the order in ascending order, that is from lowest to highest, and salary we have mentioned the order as -1. So it will do the opposite of that, that is it will sort the data in descending order, that is from highest to lowest. So if you look at the resultant output here, guys, now since we have no manager ID for this, which is taken as, let's say, the least value or 0, so it is displaying first. Next we have the salary -1. So if you look at to the manager IDs of the next like let's say 4. Now since we have the manager ID 100, which is the lowest value, and we have 4 or more same values, then it will move on to the next priority that we have given to sort our document, that is salary. So first, now we have 82,000 as our salary, that is from descending order. It will basically sort the data in descending order, that is from highest to lowest. So we have 82,000, next we have 80,000, next we have 79,800, next we have 6,500, 58,000, next we have 1,700, similarly, and so on. So in this way you can sort multiple fields using the sort method as well. I hope you've understood how the sort method works in MongoDB, guys, using the single field or using multiple field sorting, how you can basically arrange the data based on your need. Alright, let us now discuss some examples using the limit clause. Again, limit clause is very easy, guys. It is used to restrict or specify only certain number of records in a resultant set. And the syntax is followed as db dot mention the employee name, db dot employee dot find dot, let's say, limit. I want only 5 records of the employee collection, so I'm mentioning as 5 as my value. And when you enter, when you press the enter, you can see the resultant output has only 5 documents: 1, 2, 3, 4, and 5. So this is a simple example of how you can use limit. Now you can also use the limit using the sort method as well. So let us just copy this and we will see how it gets executed. So let me just paste it here. Now I'm just adding the limit method here. I want only, let's say, the first 4. Okay. Now what I'm doing is I'm first basically projecting some of the fields, that is the required number of fields that I want to fetch in my resultant set. Then I'm basically sorting this documents in the manner of manager ID salary in order of ascending order for manager ID since we have given 1, and in the order of descending order for salary since we have given at -1. And I'm limiting the resultant output to only 4 records. So when I press enter, you can see we have only the first 4 records. So we have no manager ID again. Next, if we consider the manager ID here 100 for Adam Fripp, whose manager ID is 100, and next 2 also we have the same manager ID here, guys. So now the next thing is it will go on to the salary, like we discussed earlier. The salary is sorted here in descending order from highest to lowest. So we have 82,000, next we have 80,000, next we have 79,000. So similarly, if you can, let's limit to another example. Let's say if I'm limiting to 10. All right. So in that case, it will basically fetch the first 10 records. So as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all of them are basically the records of the employees whose manager ID is 100, and it is basically arranging all the details of the employees whose salary in descending order, that is in the order of -1, which we have specified. So that brings us to the end of today's session, guys. I hope you all have understood all about the sort and the limit method that we use in MongoDB. A good indexing strategy is essential for ensuring that your database returns your results as quickly as possible. Now, just like any other relational databases where we perform indexing, similarly, indexing in MongoDB is also a way to organize information so that the database engine can quickly find the relevant results. More on that soon. But before we get started, let us first discuss the agenda for today's session. In today's tutorial, we'll be going through different concepts wherein we'll cover what are indexes in MongoDB, and then we'll understand why is indexing used in MongoDB. And up next, we'll discuss how does indexing work, and then we'll understand how to create an index. And after that, we'll be going through different types of indexes used in MongoDB. And finally, we'll end this session with syntax and execution in MongoDB shell. I hope I made myself clear with the agenda part. So let us just go ahead and understand what are indexes in MongoDB. So what are indexes in MongoDB? Now, MongoDB index is a special data structure on which the index is created to hold the data of specific fields of document. Now, in the absence of fields and indexing in MongoDB, there is a need to scan every collection document to select those that match the query statement. Now, this scan requires MongoDB to process a large volume of data and is highly efficient. So if there is no indexing done on a collection of, let's say, thousands of documents, your query will keep finding specific documents in order. However, MongoDB would limit and make it clear the number of documents to be searched within your collection if your documents have indexes. So with the help of indexes, when they are applied at the collection level, it can store the value of a specific field or set of fields ordered by the value of the field. So that is what indexes are in MongoDB. Let us now understand why is indexing used in MongoDB. Now, MongoDB's indexes make it unnecessary to perform a collection scan. Now, from that, what I mean is a collection scan basically involves looking through every document in a collection that matches to your query that you have returned to find a particular document or a field that you are trying to return. So when you provide an indexing on documents, let's say on a database that you have like thousands or 50,000 records, you can just simply put an index which will improve the search efficiency as well. Now, any collection in MongoDB can have one or more indexes, and those indexes can be made on one or multiple fields. And even though a MongoDB database can hold a lot of data, you need a good indexing strategy to quickly and effectively access the data you require from it. And finally, indexing is a necessary operation in MongoDB which automatically brings search efficiency in various executions of statements. Alright, moving ahead, let us now understand how to create an index. Now, creating an index in MongoDB is done by using the create index method. So let us just quickly go through the syntax. So the syntax is followed as db.collectionName.create index is the keyword, and make sure the I in index is capital, otherwise it will throw an error. Within the parentheses, mention the field name that you want to create an index on, and next we have 1 or -1. So now this following syntax shows how to add an index to our collection. So let us assume we have same like employee collection, which is an example, which has various fields name like employee ID, name, salary, or so on. But for this, I'm creating an index on employee name and I'm specifying as 1. Now the 1 parameter indicates that when the index is created with the employee name field value, they should be sorted in ascending order. Now, please, you have to note that it is different from the hashtag ID, which is the by default ID, which is created when you are creating a document. So the ID field is used to uniquely identify each document in the collection, which is created automatically in the collection by MongoDB. And the document will now be sorted as per the employee name and not the ID field. So I hope you've understood how to create an example. You'll get a clear-cut idea when we go into the execution part in MongoDB. So make sure to watch the video till the end, guys. Alright, moving ahead, let us now discuss the types of indexes used in MongoDB. Now, there are mainly 3 types of indexes in MongoDB. The first one is single field index. Next, we have the compound index. And finally, we have the multi-key index. Let us discuss about each of them in detail now. Now, we know that a field in a document in a collection can be indexed individually. So, as the name suggests, single field index is used to create an index on only a single field in a document. So below is an example and the syntax for single field index on an tab on a collection named as orders. So the syntax is db.collectionName.createIndex and within the parenthesis field name. So you can either index them in the order of ascending or descending by mentioning 1 or -1. So I've considered an example here of orders collection where I've created an index on a field called price and I'm mentioning as -1. So it will basically index in descending order, that is from highest to lowest. Next, we have the compound index. Now a compound index is formed when multiple fields are combined into a one single index. So a compound index is generally an index that holds a reference to multiple fields within a collection. So for example, I have taken another the same collection of orders and I'm creating an index where I'm creating index for multiple fields here, which is for price and for customer name. So again, the syntax is same, which is db dot mention the collection name dot create index, which is the keyword, and within the parenthesis you can give as many as field names to your name, to your collection. So I hope you have understood what is compound index as well. So and finally we have what is multi-key index. Now MongoDB supports a multi-key index for each element inside the array for an array field. So these elements consist of scalar fields like string values, integer values, or even nested objects. Now the syntax is same. You just have to mention the collection name and mention the create index keyword, and within the parenthesis mention the field name which is of only array type. So multi-key index automatically creates a multi-key index on an array by knowing its structure. So therefore you need not additionally define a multi-key index in such case. So no additional definition is required as such. So let us understand with an example here. Now let's say I have a document here, different documents, like I have three different documents in a collection of orders which has various fields such as ID, customer address, payment mode, email, order total, and order items. Now if you look at this collection, I have order items which has an array values. For example, we have for first ID for customer Rahul, we have 4 different array values of order items like item name notebook, and item name paper, item name journal, item name postcard. So if I want to create a multi-key index, I'll just simply write a query as db.orders.create index, and within the parenthesis mention the collection, mention the field name, that is which is order items, and on which you want to perform multi-key indexing. Now I want to perform indexing on price, which is a array value within a collection, right? So that is why I'm taking as order items.price, and the order in which it will index is ascending. So for that I'm giving the parameter as 1. So with that we have covered all the 3 different main types of indexes that we generally use in MongoDB. So let us now switch into MongoDB for execution part and see how they actually perform. Now we do not clearly see that how the indexing is going, but it will definitely improve the search efficiency if you're working on more than let's say thousands and thousands of records. So let us now jump into MongoDB shell for execution part. Alright, so as you can see, MongoDB shell has started, and firstly let us see what are the databases that are present. So for that I'll use the show DBS, and we'll again use the simplicode one DBS that we have all previously used. So use simplicode one, it says switch to simplicode. Now if you want to find all the collections that are present in that, you just have to write show collections. So we have one collection which is employee, so we'll use that. So in order to find the values or the documents that are present in this collection, we'll just write the db command, which is db.employee.find. So it will just display all the values, type it for all the values. So as you can see, we have various different documents in this. So we'll just perform a simple index now. We'll just create a single field index now, which is basically a normal field index that you create. So the query would be db.employee create, mention the create index keyword, and within the parenthesis. So let us just create an index on salary field here, right? So mention the salary field. mention the hyphen, and we will index this in ascending order. So I'm giving the parameter here as 1. So let us execute this statement. So when you execute this statement, it says salary underscore 1, which is basically means your index that you have created, which has been successfully executed. So now that you've created your index, and if you want to view what are the indexes that you have created, you need to use the get indexes keyword. So let us just find again. So I'll use the statement db.employee, which is a collection name. Now you need to use the get indexes. Make sure the I is capital, otherwise you will find an error. Get indexes, and when you enter this, and you'll find this a list of following indexes that you have created. Now I have already now, as I said earlier in the tutorial, the ID field is automatically created within the database, which automatically creates the index for the underscore ID. But additional to that, I've already created email index on our employee table, and just now I have created the salary index also. So you can see the list of all these indexes that you have created. Now let's say if you want to delete or drop any of the index that you have created, so in that case you have to use the drop index. So I'll just write the statement again, which is db.employee mention the keyword drop index. Okay, and within the parenthesis, mention the index that you want to drop. So let's say if I want to drop the email, I find it unnecessary now, so I'll just write the email key, which is a field, and I'll mention this 1, and I'll just close the parenthesis, and I'll close the brackets as well. So as you can see, it says okay. It says n indexes is 3 and okay 1. That means you've finally dropped the index. So we'll just use again this get index and see whether it is successfully deleted or not. Let's just copy paste here and let us enter. So now you can see that we have only 2 fields, which is the underscore ID, which is by default, which is the index that I've created by the database itself, and additionally we have the salary index that we have created earlier, and successfully we have deleted the email index from our collection or the database. So I hope you've understood till now. So that is what index is about. You just create index to improve the search efficiency. Now behind the database, the performance optimization or the efficiency can be achieved, which cannot be viewed outside. So I hope you understood how to create a single field here. Well, let us now move to compound index, and we'll see how to create it also. So as discussed earlier, you can use multiple fields in a MongoDB document to create a compound index. So I'll just create compound index on another fields. So I'll just create index, and within the parentheses, okay, let us now create index for, let's say, job ID. Job ID, I am giving it as -1, the order, mention the comma, and let us create an index for, let's say, department ID as well. Department ID, and I'm giving this parameter 1. It will basically index in the ascending order. So close the parenthesis. So as you can see, it is saying job ID 1, department ID 1. That means you have successfully created the index. So let us just confirm whether they have created or not. So let us copy paste again. So now as you can see, we have another 2 indexes that we have created, which says job ID and for department ID as well. So this is how you can create a compound index in your MongoDB database as well. So in the above compound index that we have created, the MongoDB will first sort by the job ID in the descending order. Since we have provided -1 as the parameter, it will basically sort all the documents in the descending order. Then with each department ID, it will sort in ascending order. Since we have provided the parameter as 1, now the index would create a similar data structure for the department ID also, which basically sorts the data in the ascending order. So that brings us to the final, which is multi-key index. Now, I don't think we have, array of fields or the array of data in our documents so that we can perform. But for now, I hope you understood how to implement multi-key index as well. It just supports indexing of array of data. So when you create an index for a field containing an array, MongoDB will create a separate index entries for every element in the array data. So I think we've already almost covered all the topics that we have discussed in our agenda, and I hope you guys have understood as well. So that brings us to the end of today's session, guys. I hope you've understood what are indexes and how they are used, to search the data in an efficient and a more quick way. So defining indexes are important, for faster and efficient searching of documents in a collection. And these indexes can be created by the using create index method. So I'm just recapping what we have covered. And indexes can be created on just one field by using the single field index method, or multiple fields using the compound index. And you can even create indexes on array of fields using the multi-key index as well.
So what is advanced indexing? Now we all know what indexing is MongoDB, right? Which is an essential component which improves the performance of the data retrieval speed in the database. So MongoDB indexing is a special data structure on which the index is created to hold the data of specific fields of documents. And in the absence of indexing in MongoDB, there is a need to scan every collection document to select those that match the query statement. Now, in our previous tutorial on indexing in MongoDB, we have just covered the basic, indexing techniques like on single field and compound fields, right? So now, what if the database is working on array of fields within a collection, right? So let's say if I have a student's database, and in that I am working on sub documents, that is documents that have array of fields in them. So in such case, the indexing becomes quite difficult. So if there is no indexing done on a collection of thousands of documents, your query will keep finding specific document in order, be it a single field, multiple fields, or even array of fields. So it becomes quite difficult, to retrieve the value. So indexes are applied at the collection level, and it can store the value of specific field or a set of fields. So before jumping into why, how exactly advanced indexing works on array of fields, let us understand why we need advanced indexing. In addition to the normal indexing that we do in MongoDB. So for that, let us jump into my MongoDB Compass for explanation. So as you can see, MongoDB Compass has started, and in our database Simplicode 1, we have two different collections, that is employee and new employees here. Now if I click at the new employees, it basically opens the document fields. Now you can see we have like almost around 33,000 documents, and we have one index which is basically done on the ID field. If you go to the indexes page, we have the ID field which is already indexed. Now, if you consider these many documents, right, these huge tons amounts of documents, like we have 33K, and if I try to find a particular document, let's say I want to find a name, based on the name I'm trying to field. I think we have different names here, right? So let's just take department here, right? So we have department field. So I'm just finding value, like let's say I'm trying to find all the documents which has police as the department name. So I'll just write police and try to search it. So close the brackets and let us try to find. So it will basically find all the documents or within the collection that has department as police here. Now, if I go to the explanation of this, right, let's just click on explanation. Now, if I look the query performance of this document, or the query that I've written for, to find the details of all the, employees or the people working in a company and the background, I'm trying to find what all the documents that I want here, right? So if you look at here, we have a total of 32,928 documents. And in that we have documents returned are 13,590. Now it indirectly impacts the performance, guys. Now if you see, we have 33,000 documents. It is searching each and every document where the department is police. So, and after searching each and every record, it is basically retrieving all the documents. So we have around 13,590, which is close to around 14K. And if you look at the actual query time, it is around 23 milliseconds. So that is quite a huge, amount of time for a database to process such information. Now, let's say if I have like millions, like 10 lakhs or 15 lakhs of documents, in such case, the time taken is more. So in such case, we'll basically create an index here. Now we all know how to create a single index and a multiple index. So let's just create an index and we'll see how it actually affects the the query performance. So I'm just creating an index on department field, and I'm basically indexing in ascending. So I'm just basically 1. I'm keeping it as 1. So as you can see, we have created successfully the index for the department field here. So let us now try to find the data that is the department of, that is the employees or the people working as a police. So if I try to find this, and if I go to the explanation part, so you can see now we have a total of 13,590 documents. Now instead of searching all the documents, that is 33,000, we can directly refer only those documents that are required to us. So you can see index key examine only 13,590, and you can see actual query execution time has reduced a bit more, like 17 ms. I think that is also quite huge, but I don't think that is that can affect actually. So you can see this is how index works. Now let's say if I create multiple index, let's say if I'm trying to find multiple fields. So in that case, let us see how it actually impacts. Alright, so let us now understand how it works for a compound field. So when you are trying to index multiple fields, let us see how the query performance does. So let us now find the details of the employees whose department is police, and let's say their job titles is sergeant. So in that case, I'll basically search for department field where the department is police, and put a comma, and the job title that I'm searching for is basically sergeant. So mention sergeant. Okay, close the brackets and let us now find the documents. So if you look at, it will only display all the details of employees whose basically job title is sergeant and department is police. So let us now understand how it is executing. So let us explain, click on the explain button. So you can see that the documents it is examining is basically all the documents that is present in the collection, that is 32,928. Now out of that, it is returning 1296. So as you can see, it is a time-taking process. It is going through each and every document. Now, thing is, we only have around 1300 documents where the department is police and the job title is sergeant. So instead of that, what I'll do is I'll basically index the both department as well as the job title as well. So let us just create another index here. Firstly, for department, create index. So let us create another index for job title, and let us create an index again. So as you can see, we have created the index successfully. So let us now try to find the documents. All right, it will fetch all the documents, and let us now basically click on the explain and see how it does. So as you can see, now the documents that it examined now is 1296, which we have seen earlier that all the details of employees whose department is police and the job title is sergeant. So after creating an index, it is only searching only those documents whose department is police and sergeant. As you can see, the actual query execution time is also reduced drastically from almost 432 milliseconds to almost 16 milliseconds. So it will also vary, like if you click again, it will change to 6 milliseconds now that it has found the details. So it keeps on changing. So index basically provides the user to efficiently navigate through that data which is required by them instead of searching the whole data. So now you might be wondering why we need advanced technique. Now let's say if I have sub-array fields in this documents. So in that case, I need to query those documents quickly, right? Now it will take more time than single field or a compound field. Now that is where we use advanced indexing to index sub array fields or sub documents. So let us now understand how advanced indexing works and why we have went through all that scenario on MongoDB Compass, where we have understood how indexing works for a single field as well as compounding field and the need for advanced indexing. Now let's say I have a document of students. Let's say I have their student ID, their name, age, courses. Now for courses field, I have another additional array section where I'm mentioning the course ID, course name, and course credits. So in that case, we have an array field here, right? So in such case, we'll use advanced indexing. Now, advanced indexing is basically just another process where we are using another technique, right? So let's say if I have 20 million such records, right? 20 such million documents present in my collection, it will take a lot of time. So this is where we need to use indexing process again. So let's say if you're indexing an array field, the syntax for that would be db.collection.createIndex, mention the array field name, that is, and the order. So I'm creating an index on courses, right? Which is an array field there. So the query would be db.students.createIndex courses and mention the order, that is 1. Now you can also further index subdocument fields, right? Now instead of just indexing the array field, you can also index the subdocument field. So let's just understand the syntax here. That is db.collection.createIndex field name dot subdocument field name and the order. Now why we are doing this? Now suppose that we want to search documents based on the course ID, course name, or even the course credits. Now since all these fields are part of the courses subdocument field, right, which will create an index here on all the fields of the subdocument. Now in this example, I've created an index field on a subdocument which is course ID. Similarly, you can also create for course name as well as the course credit also. So the query is followed as db.students create index courses.course ID, and I'm mentioning the order as 1. So once the index is created, we can search for any of the subdocument fields utilizing this query. Now remember that the query expression has to follow the order of the index specified, that is either 1 or -1, otherwise you will get an error. So in this way, we can use a technique which is advanced indexing in order to query the array fields as well as subdocument fields. Now in addition to that, we have some other advanced indexing techniques, which is another 3 types of indexing techniques in MongoDB, which is first one is geospatial index. Now MongoDB uses 2D index and 2D sphere to increase the efficiency of database queries while dealing with the geospatial coordinate data. Next, we also have text index, which provides support to text search queries on string content. So basically, text indexes can include any field whose value is a string or an array of string elements. And finally, we have hashed index. Now basically, hashed index keep tracks of the entries with hashes of the values of the index field, which is almost always the underscore ID field, which is created by default in all the collection. Now this kind of index is primarily necessary when you are sharding data to distribute it evenly. Now if you want to learn more about sharding, we have a dedicated video on that as well. So make sure to check that on our channel. And that brings us to the end of today's session, guys. So in this way, you can use advanced indexing to create an index on multi-key compound fields as well. So let's say if you have a document with an array field, you can just create indexing for an array field. Creating an index on an array in turn creates separate index entries for each of its fields. So it will basically create an index to an array field. So it will help you to find the documents which are having any array field values as well. So I hope you understood all the techniques and how we implement advanced indexing in MongoDB. When you first start working with MongoDB, you will most likely use the find method or command for a variety of queries. Now, however, as your queries become more complex, you will need to learn more about aggregation in MongoDB, which is used to perform various complex operations. So in this tutorial, we'll be covering the fundamentals of creating aggregate queries in MongoDB and how to use various expressions in MongoDB aggregation. And furthermore, we'll introduce the most important stages of aggregation pipeline along with examples of how to apply each one to this pipeline stages. But before we begin, if you're new to the channel and haven't subscribed already,
Consider getting subscribed to our channel Simply Code to stay updated with all the latest tech content. And hit that bell icon to never miss an update from us. So without any further ado, let's get started with today's topic. Alright, firstly let us understand what is aggregation in MongoDB. MongoDB processes the data records in the database during an aggregation operation and returns a single computed result. It actually groups multiple documents present in a collection, applies an aggregation operation to it, and then provides the user with a single result. Now, MongoDB offers a wide range of aggregation operations. Just like many other database systems in relational databases as well, MongoDB, being a NoSQL database, also provides with the same functionality. This enables you to filter data as you might with a query, as well as grouping data, sorting data into a particular order, or reorganizing for returning the documents in the collection. Now, this is just similar to the SQL, wherein we use the group by clause in our aggregation function with the help of certain operations like count, average, sum, minimum, and value to perform complex aggregation operations. In the similar way, MongoDB aggregation is also similar to that of the SQL aggregation method that we follow. So I hope you understood what is aggregation in MongoDB. Let us now understand why we use aggregation. Now, data from different sources is gathered by an aggregation method, which are then processed to a single outcome. Now, to perform an aggregate function in a relational database, the database management system typically extracts data from multiple rows of the same table. But in a document-oriented database like MongoDB, the database will gather information from various documents in the same collection. So it basically groups values from multiple documents together to a single resultant value. Now, next one is it fetches a lot of nested data to perform complex operations. Now, when using a database management system, you must run an operation known as a query, right? Each time you want to retrieve data from database. However, queries only return the information that is already present in the database. You will frequently need to carry out another type of operation, which is known as aggregation, in order to analyze your data, in order to find patterns or other information about the data. So if there is a complex operation that is needed for the data that is present in the documents, you need aggregation. And finally, it filters and sorts documents and analyze data changes. Now, MongoDB being an NoSQL database, the data model will frequently change as the data that is being inserting into the database might change over the time. So in order to analyze this unstructured data, it becomes quite important that you make a proper filtration and sorting of these documents to get a proper insights for your businesses and as well as your requirements. So in that case, aggregation can be quite useful, which simplifies the complexity of the query that you have written and fetches the data in no time. So these are some of the main reasons on why we use aggregation. Now, aggregation in MongoDB is performed using aggregation pipeline stages, which consists of 4 different methods. The first one is match, next we have group, next we have sort, and finally we have project. These 4 combinedly are known as aggregation pipeline stages, which perform aggregation as per the requirement. Now, firstly, when you take a collection, and the first thing you need to is, if you want to match only certain fields within your documents to perform aggregation, then you can use the match method. Next we have the group. Now, just like the group by clause in SQL, you can use the group function here as well in order to group all the similar or the related type of data in your present in your collections, that is the data that is present in your documents. In order to retrieve the similar kind of data, you can use the group. Next, sort. Again, sorting can be done in any other way, like from ascending order or descending order. Next, we have the project. As we discussed earlier in a previous tutorial, project is used to remove the unnecessary fields that you want in a resultant set. And finally, after matching all the 4 pipeline stages, then you get the resultant output. So let us understand this with an example wherein we'll discuss how aggregation works in MongoDB. Now, as discussed earlier, firstly the match condition specifies only the related documents that you want to consider. So for example, I have a collection name orders here, and I'm performing an aggregation operation here. So first I've mentioned the match
for status A. So I have like 4 documents here. If you see in the orders, like for 4 different customer IDs, we have the amount and status. Now I want to retrieve only those documents whose status is A. So for that, I'm using the match command here. So match command only retrieve the one that you have specified here, which is status A. So we have only 3 records that have the status as field and their value is A. So we have sorted initially with the match command. Next, we want to group the values in the order of their, let's say, IDs. And then, so if you look at here, we have 2 similar IDs, which is A123 and B212. So what group does is it will match all the similar and related fields together and produce a result. So you can see the A123 and B212 are separated into different groups. And finally, what I'm doing is I'm sorting and I'm applying an operation here with sum. So what it does is it will basically calculate the total amount here. So if you look at the first ID A123, the amount is 500 and 250. So the resultant output would be 750. And finally, we have the customer ID of B212, whose amount is just 200. So in this way, the aggregation pipeline works in a methodology of wherein it matches the values, that is the similar values from the documents. Then you can even group the data that you want to show in your resultant output, and you can perform various operations using the aggregate functions like sum, minimum, average with the help of sorting as well. So this is basically how aggregation works in MongoDB. So and finally, as discussed earlier, just like similar to SQL, we have the same 5 or the main 5 aggregation operations in SQL, which is the first one is sum. It basically adds up the values of every documents of a collection. Next, we have the average, which computes the average value of every document of a collection. Next, we have minimum or min, returns the minimum of all values from the collection. And next, we have max, which is opposite to that of minimum, which returns the maximum of all values from within the collection. And finally, we have an additional, operation, which is push operation. Since MongoDB is non-relational database, we also work on the array of elements. So in order to add the values to an array in the associated document within a collection, you can use the push operation as well. Now this might be a bit confusing for you guys now. So let us jump into MongoDB shell for execution part, where we'll perform different operations using the aggregation pipeline stages and see how they are getting implemented, and also perform a detailed analysis on the data, the collection that we have, and we will bring out some inferences using the aggregation operations using various expressions like sum, average, minimum, and maximum. So without any further delay, let us jump into MongoDB shell. So as you can see, we have opened the MongoDB shell command prompt line. So let us just use the command show dbs to find out the database present. So we have different databases like admin, config, local, and simplicode one. We'll use the simplicode one as usual. So write the database name, use simplicode one. Now let us see the collections that are present in the table. So we have the employee collection again. So let us write the command using the db.find, db.collectionName.find, which is employee.find. So it will retrieve all the values that are present in this collection. So we have different fields like employee ID, first name, last name, email, phone number, hiring date, job ID, salary, manager ID, and department ID. So alright, let us now perform the aggregate operations in a sequential way. Firstly, we'll look at the match aggregation stage, where it will match the related fields that we want in a resultant set. Now let's say if I want to match the department ID, whose all the employees who belong to the department ID, let's say 100. So in that case, the following query would be db.employee. Mention the aggregate keyword here, which is a must. Otherwise, it will throw an error. Open the parenthesis and mention the square brackets, and use the dollar symbol to write the statement for match, and put the colon and open the parenthesis and mention the department ID field, which is on which we are basically matching the records. So mention it again, the colon, and within single quotes mention the department ID name. So since we have taken as 100, I'm just taking it. Close the flower brackets 2 times, and again mention the square bracket once again, and close the
parenthesis. All right, so this is the basically the query that we have written here, which is db.employee.aggregate, and we're using the match aggregation method here, wherein we are matching all the records of the employees whose department ID belongs to 100. So let us now enter. I think there is an error here. So we had an error in the syntax, guys. So as you can see in the output, we can see only those records of the employees wherein it is showing the records whose department ID is 100. So we have the employee ID 108, 109, 110, 111 and 112, 113, and all of them have their employee department ID as 100. So I hope you understood this. So let us now go through the next stage of aggregation pipeline, wherein we'll group the values now. So for that, the following query would be db.employee.aggregate, which is the keyword again. Open the parenthesis and mention the double square brackets, open the flower brackets and use the dollar symbol again, write the group keyword and open the flower brackets again and mention the ID here. So I'll explain why we are taking this here again. So firstly, let us just write the command, and then I'll explain to you guys that why we are implementing that. So I want to group all the basically the department IDs, right? So I'm taking department ID. So mention the dollar symbol and mention the field name, which is the department ID. Close the flower brackets twice, mention the double bracket, square bracket as well. So when you enter, you can see the list of all the department IDs that are present in our collection. So we have various department IDs like 60, 10, 30, 70, 40, 110, 100, 50, 20, 98 and so on. So now you might have a doubt that why we are using the ID field here. Now we are using the group stage to group the input documents by the specified ID expression, which returns a single document containing all the cumulative values of all the department IDs that we have taken here. So in this above example, only the group stage is specified in the pipeline, whereas the group uses the ID field to calculate the value for all the input documents as a whole. So the expression ID colon the dollar symbol department ID creates a distinct group on the field department name. Since we didn't calculate any accumulated values in our document, it returns the distinct values of department IDs that are present in the table or in the document. So in this way, you can use the group aggregation method as well. So this is how you can use the match and group stages, wherein you can combine both these as well. So next, let us look at how to create an aggregation operation using one of the expression that we have, like count, average, sum or minimum. Now let's say if I want to count the total employees in a particular department, in that case I'll basically use the match statement, wherein it will group all the values of the employees whose department ID is in a particular value, and then it will count the total number of employees in that group. So for that, the following query would be db.employee.aggregate. Open the brackets and square brackets as well, and then mention the flower brackets, and then use the dollar match group stage, wherein we are matching the department ID. Let's say department ID of 60. So in that case, it would be department ID. I am taking the value as 60, mention in the double quotes and close the brackets, put a comma, and then basically we are counting, right? So I'll use the count function here. So put the dollar sign, mention the count keyword, and let's say the statement would be total employees in department 60, right? So mention the close the brackets as well. square brackets. Second. So when you press the enter in a resultant output, it states that total employees in department 60 is 5. So similarly, you can check for various other departments as well. So let us just verify if it's showing correctly or not. I'll just copy paste this. And let's say for 100, now I want the total number of employees present in the department 100. So in that case, I'll just mention it. I'll just change the values and let us now press the enter. So as you can see in the resultant set or in the output, you can see the total number of employees in department 100 is 6, wherein we have the total number of employees in department 60 is 5. So in this way, you can use the various aggregation stages using the match, group, and as well as sort as well, and perform various aggregation operations like sum, minimum, maximum as well. So I think we have covered most of the concepts that we have discussed in our tutorial. So that brings us to the end of today's session, guys. I hope you've understood what aggregation methods and how they are used in MongoDB. Alright, as you know that MongoDB relationship represents how multiple documents are logically connected to each other in MongoDB. It provides two types of relationships, namely embedded and referenced. Embedded documents capture relationship between data by storing related data in a single document structure. On the other hand, reference models store the relationship between data by including links or references from one document to another. Now, to implement a normalized database structure in MongoDB, we use the concept of reference relationship. That is, if you look at the left side of the screen here, you can have an example where it is a reference model where we have student collection and inside we have ID, and then we have another document contact details where we are referencing using this student document, right? So in that way, we can use reference model for that. So we use this concept of reference relationship, also referred to as manual references, in which we manually store the reference document ID inside another document. Now, what if the data that you're trying to search isn't present in different collection or in different database? And that's where you have to use dbrefs. Dbrefs are references from one document to another using the value of the first document ID field, collection name, and optionally its database. dbrefs basically allow you to more easily reference documents stored in multiple collections or database. So if you look at this example, I have a user collection here and a post collection here. In the user collection, I have ID, name, post as my fields, and I'm trying to fetch those from the post collection, which is another collection in that case, right? So if I'm trying to retrieve data from another collection, which may be present in another database, in such case, you have to reference the database that you're trying to search for, and that is where we use dbref. So, and that brings us to the main part. What is MongoDB database references? MongoDB database references allow you to more easily reference documents stored in multiple collections or database. So relationship between documents can be represented using this dbrefs, which offer a standard format and type. So if your database needs to communicate with a variety of frameworks and tools present in MongoDB database, the dbref format offers common links for representing the data between the documents. However, in cases where a document contains references from different collections, in that case, we have to use MongoDB derefs. So it basically represents a document rather than a specific reference type. And if you're trying to find data in more than one collection, in such case, you have to use MongoDB database references. Alright, I hope you understood what it is, and let us now move ahead and understand the various parameters that we use while writing database reference syntax. First, we have the $ref keyword. Now, ref field basically holds the name of the collection, where the reference document resides. Next, we have the ID field. The ID field basically contains the value of the ID field in the reference document. And finally, we have the optional DB, which contains the name of the database where the document or the reference document resides. So in MongoDB, these are the three important fields which should be used in order to implement dbrefs relationship as follows. Let us now understand the syntax of MongoDB database reference and how it is exactly used. Now let's say if I have an address collection here, which I'm basically creating two different fields, which is ID and city. So the command is the db.address.insert, and ID is 145 and city is Bangalore. Next we have another document, which is db.address.insert, which is the ID is 124, city is Delhi. So firstly, we have inserted 2 documents in our address collection. Now let us move ahead and see and how we can implement this using another collection which might be present in different database. Now let's say if I have another student collection and I'm inserting records, wherein I'm inserting records of student details like ID I'm providing as 1, is first name of the student is Rahul here. So as you can see here inside the address ID, which is the database reference field, which is part of the document or the collection student collection present in this collection, we are using MongoDB reference approach to refer the address ID present in another collection which we have taken from the address collection here. After defining 3 fields which are basically ref, ID and optional DB. So the ref is basically we are providing the field which you want to reference, provide a reference to the collection that you are trying to connect here. So earlier we mentioned the ID and the address in the address collection, right? So I am referring to that. That's why I'm providing the collection name as address and ID as 105, and database is optional. You can keep whatever you want. I'm just taking simply it as simply code 1. And similarly, we are again inserting another document and again we are referencing it with the dbref ID, dbref field, which is again address ID. And for reference, I'm taking again address collection and ID as 124 and db.simplycode. Now you might have a question, now what exactly and how exactly MongoDB dbref works here. Now the syntax is followed as var student db.student.find1, which we use in order to find the data. Now I'm trying to search the first name with the name of Rohan. So I want to get the details or the address of this student whose name is Rohan. So for that I'm querying as var student address equals to student.address ID, and after that mention the syntax as db within the square brackets student address dot $ref.find ID where student address dot ID. Now what does it mean? So I'm basically connecting both the address collection and the student collection, and that is what I'm referring here, student address dot reference and student address dot ID. So in order to get the address of the student Rohan, you have to basically provide a reference to both these collections. So that is what I'm doing here. So when you execute this statement, this will be the final output. Now for Rohan, we have the ID which is 145 and his city, the address is Bangalore. So this is how exactly dbref works in MongoDB. And that brings us to the end of today's session, guys. In this tutorial, we have revised the concepts of data relationships in MongoDB with the likes of manual references used for data modeling in the MongoDB, and compared it against the concepts of MongoDB dbrefs, where the former is used when the references are to be made to the documents present in the same collection. So you can use manual references when you're trying to make references in the same documents or which are present in the same collection. And the other part, which is MongoDB dbrefs approach, is used when the references are to be made to the documents present in different collections and in different database. Now the main question comes is, why is no longer MongoDB dbrefs concepts is not used? It is deprecated all around the world, and it is not a suggested method when you are trying to work on this MongoDB database. And that is the reason also MongoDB documentation recommends manual references unless you have documents referred to in multiple locations or the collections in a database. So when you have multiple collections for your references to target, we would highly recommend it's still easier to store the object ID and collection name in the own object without specifying or with a special name of dbrefs, and that won't break if someone insert the field out of the order. Now, although dbrefs haven't been deprecated in MongoDB as such, and the functionality is unlikely to go away, but hopefully you can see there are good reasons on why to use and how to avoid this function that we have discussed in this. Well, coming to today's topic, in today's session, we look at how to use covered queries and analyze those covered queries and the performance that it creates while you query a MongoDB database. So which helps us to query data more quickly. So without any further ado, let's get started. But before we begin, if you're new to the channel and haven't subscribed already, Consider getting subscribed to our channel Simply Code to stay updated with all the latest tech content, and hit that bell icon to never miss an update from us. Alright, now what are covered queries? Now we know that in every database including MongoDB, indexes play a crucial role. MongoDB queries are executed more quickly when indexes are used. As you know, we have discussed in our previous tutorials on MongoDB indexing. So if you haven't checked that out, make sure you check that out on our channel. We have a dedicated playlist on various MongoDB concepts as well, wherein we have covered MongoDB indexing as well. So you make sure you check that out. Now, indexes basically provide users with an efficient way of querying data. So if you ran a query to find specific documents, let's say in a collection of thousands or lakhs of documents without any indexes, MongoDB would have to search the entire collection in order to find the requested document in your query. However, MongoDB would use indexes if you had them to reduce the number of documents that needed to be searched in the collection. Now, there is an additional, part of indexing, that is covered queries. So you've probably heard that column indexing is an excellent way to improve query performance by reducing the number of disk access that are required. Now, covered queries is basically a MongoDB specific application of field indexing in which all the query columns are already indexed. Now, it basically avoids collection scan just like the normal indexing. So it allows the database to search through less document to satisfy a query. Without an index, MongoDB has to scan through all the documents to ensure it has answered the query correctly. Now, covered queries are extremely fast because MongoDB does not have to examine any other documents other than the ones that have been indexed. So it only examines document in your query that you have provided the indexing, that you have provided the fields that are already indexed. And finally, fetching data becomes much faster using covered queries, because covered queries return results from an index directly without having to access the source document and are therefore very efficient as well. Now, there are cases when you have to consider when to use covered queries. Now, covered queries are only used when all the fields in a query are part of the index. So let's say if you're trying to find any field in your query, it should be a part of index that you have already created. Only then covered queries can come into picture or can be used in a more efficient way. Next is all the fields returned in the query should be are in the same index. Now it can be a composite index, it can be a multi-key index, but make sure that the fields that you're returning in your query should be in the same index. And finally, no fields in the query are equal to null. That is, field value should not be null. In such case, covered queries will not be followed. Now, before getting into the execution part, let us just consider a simple example on how covered queries works in MongoDB. So let's say I have a collection here which has 3 different documents of various customers like Rahul, Pranav and Kirti, and the orders that they have placed, and the various personal details like address, their payment mode, email, order total, order items. We have an array field here wherein we are storing various fields in ordered items like item name, like notebook, paper, general or postcard, and even their price and the quantity of the items. So we have 3 different documents present in a collection here. Now, if I want to create a simple index, let's say I'm creating an index on orders item field, wherein I'm creating a particular index on the price here. So, and also payment mode, I'm creating an index. So the query would be db.orders.createIndex, orders item.price. I'm mentioning one that is in ascending order. The index is created in ascending order. And also for payment mode, I'm creating an index. Now, generally what you have to do is, what you do in general for indexing or while querying your data that is present in your collection is, you just mention the customer, or let's say if I'm trying to find the customer name here, that is Rahul. If I consider this example here, it says db.orders.find customer Rahul, orders item.price 1, payment code 1. Now we are providing all the index field that we have created, that is orders item.price and payment code. But the query that I'm trying to find is the data of customer here, that is Rahul, which we have not indexed. So let's say I'm just having 3 documents here. Now, if there are, let's say 10,000 documents that are present in collection, and maybe we have more than one Rahul, in such case, it becomes difficult, right? Even the indexes
is become an anomaly here. It is not as fast as what we have thought here. Now, instead of that, I'm just taking another query. Now, let's say I have created index on orders item.price and payment mode, right? Now, what I'm doing is I'm trying to return the data, or I'm querying for data wherein I'm trying to find the payment mode is equals to card. Now, if you look at clearly into our index query that we have created, payment mode is already included in the query index, right? We have already created earlier, and I'm trying to find it in the same way. So I'm trying to find payment mode card, which is again already created index, which is payment mode. So in that case, instead of looking through all the data present in documents, it will simply look at only the ones which are already indexed. And that is the main advantage of covered queries. It returns results from an index directly without having to access any source document, and it can be more efficient more than just indexing, right? So I hope you understood how covered queries are actually working in MongoDB. And let's just go into MongoDB shell now and get into the execution part and understand it in a more clear way. And also finally we'll analyze how this query is working and how it is different from indexing in MongoDB. So as you can see, MongoDB shell has started. So the first command would be is basically the show DBS, which will allow us to show all the database that are present in a MongoDB database. So we have the simply code one database, so we'll be using that only. Right, use simply code one. So it says switch to DB. We are good to go. Now let us see the collections that are present in this database. So we have different collections like collection name, employee, marks, and new employees. So let us just consider a collection that we've already created here, which is employee. So let's just find the details or the documents that are present in this collection. So I'm using the v.employee.find command for that. So when you enter, it will display all the records or the documents that are present in this collection. Alright, now let us now create a covered query. Now creating a covered query is similar to that of how you create an index. So the query would be db.employee.create and mention the create index keyword. Make sure the I is capital, otherwise it will throw an error. So let's just create an covered index on the fields. Let's say we have manager ID and department ID, right? So we'll be creating covered query that is on this two fields. So mention the field name, that is manager ID, keep it as 1, comma, and department ID as well. Close the brackets. Alright, and click enter. So as you can see, it says manager ID _1, department _ID _1. That means you have successfully created covered query on these two fields, that is manager ID and department ID. So now let's query or read data from this covered index. So for that, we'll again use the find operation. So let's say I'm trying to find a particular manager ID details, right? So let's say I want to find the details of employees whose manager ID is 123. In such case, I'll use a query that is db.employee.find, and inside the brackets, let's say manager ID is 123 that I'm going to search for. Close the brackets and mention the indexes that you have created here, which is again manager ID, which is 1, comma, department ID, which is again 1 here. Close the brackets. I think we're good to go. So click on enter. So as you can see in the above query, when we find document where we are trying to find manager ID, which is 123, covered index, which is on manager ID as well as department ID, is already loaded into the RAM. And as we know that,
So as we know that manager ID is already present in our component index, that is why it reads very quickly and we avoid scanning of too many documents in database. So this is just a basic example on how to create a covered query. So let's just create a another field where we understand how covered query exactly works. Now let's say I'm trying to create an index on the first name, let's say first name as well. So let's take the query as db.createIndex. I'm just copy pasting it here, and let us create another index for our collection for this. So it will be first name here. All right, first name, close the brackets. So as you can see, our query has been successfully created. Now let's say I'm trying to find the employee details using this index that you have created now. So I'll just let's say I'm trying to find an employee whose first name is Shelly. Now by default, since I've created index on manager ID as well as department ID, it will be directly indexed and display in our resultant set. So make sure you keep the first name field also, because we have created the index for that as well. So mention first name as 1, comma. All right, I think we are good to go now. Let's just see the result for this. So there was a bit error in the first name that we're trying to retrieve. Now Shelly, which we have taken her name in all caps, which is not exactly present in the same way in our collection. So make sure you keep the name as exactly which is present in our database, which is capital S, and the rest of them are small caps here. So when I try to find the resultant set for this, the final output is the first name, which is her name Shelly, and we are getting the manager ID as well as the department ID that she belongs to, which is manager ID is 101 and department ID is 110. Now if you look at this query, covered index will not be available when you use this following query, which is db.employee find first name, which is Shelly, and we are mentioning the indexes that we have created for first name, manager ID, department ID. Because when we find a document where first name is Shelly, which has covered index on basically the first name, manager ID and the department ID, which is already loaded into the RAM, but by default underscore ID is also present here. That is, the field that is not present in the covered index is also being displayed. So despite of manager ID, department ID present in our component index, we cannot avoid scanning of too many documents in our database. So we need to exclude underscore ID as well if you're trying to use covered index. So make sure you include underscore ID in your query as well. So the query now that would followed as, with the help of indexes that we have created, make sure with the first name keep the ID as 0, only then. So I'm mentioning underscore ID after the department ID, keeping it as 0. So let us just find it now. So as you can see, we are only retrieving first name Shelly, manager ID and department ID, and finally underscore ID is being eliminated or dismissed from this. So that was all about covered index, guys. Now you have to remember that covered index does not work when field on which we are trying to cover in covered index is an array or an embedded document. That is, when you're trying to retrieve data from a subdocument or a field that is present in an array field, in such case, covered index won't work. So let us now try to understand how to analyze this query. Now the performance of indexing is very crucial for our database performance, right? So we need to understand how it is being executed, in the backend as well. So for that, we'll use the explain command here. So for that, the query is same, guys. Just copy paste the query that you have, created, and after that, mention the explain keyword, which is the explain command here. So there was a bit issue or error in the copying this code, guys. So I'm just copying paste the query that we have written here, which is db.employee.find first name Shadi, first name, manager ID, department ID, and all the indexes that I've created on. And finally, you have to mention the explain command here. Now, analyzing queries is very important aspect of measuring how well or the effective the database and the indexing design is. So for that, I'm using the explain command here, which basically provides information on the query, indexes that you have used, the performance, that is the time that it has taken to execute your query, and other statistics. So it is very helpful when analyzing how well your indexes are optimized, while you are using an indexing or a covered query. So let's just see how it works here. Click on enter. So you can see it is displaying all the details of the performance or the optimization of the query that has taken place in the background here. So you can see we have various fields listed in all this here. You can see the namespace, index filter set as false, and all that. Now we are only concerned with here is this stage. Input stage is IX scan, that is index scan. The short form for this is index scan. So basically that we have performed a index scan on the query that we have created in our resultant set. So it basically says another condition where you'll find this is a collection scan, that is COLLS and scan. So you may find that is you're not providing any index, instead you're finding all the documents one by one simultaneously using a collection scan. That is another scenario in which we consider the type of scanning that we have done here. And you can also see that index name that we have created, that is first name, and it's multi-key, it's false, unique false, partial false, and so on. So it basically indicates the number of documents that have matched, that are returned here. It indicates the total number of documents that we have scanned, and indicates the total number of documents or index entities that we have scanned here. All this you can find using the explain operator here.
Well, let's go ahead with the next area, that is called working with React.js interview questions. Now, as we know it, React.js is as important as like in other tools which you've already has seen. So what is the JSX here? JSX called JavaScript syntax extension. Okay, so this syntax extension to the JavaScript in React.js is in the way how you express to bind JS and HTML together to result a JSX content. So by using JSX, you can write a HTML structure in the same file that contains the JavaScript code. That is something more innovative way. Because of that, React.js is creating more buzz in the market. So JSX actually helps to making code more easy to understand and debug, and avoids a lot of boilerplate code, okay, inside the DOM structure. Now, the next thing is, what is a virtual DOM? See, the virtual DOM is representing a DOM in a memory. Okay, that is called virtual DOM. So manipulating the real DOM is much more slower and costly affair. Okay, because you need to repaint the DOM over and over the period of time when the user changes few things. So when the state change, virtual DOM changes, and only the objects which are in real DOM, okay, update instead of updating the entire object. So that makes your page to be load far more faster. Okay, so in virtual DOM, what happens? This is the real DOM, this is a virtual DOM. So the orange color portions which you're seeing, that is basically the changes which has been made. Okay, these are called changed object. Okay, so virtual DOM is basically compare it to the previous state and understand which area it needs to send for the updates and avoid the other areas. Okay, that's what this virtual DOM really works. So what are React extensions? React extensions are many. Like you talk about, like in Flux, it is a third-party tool which is responsible to attach the state management feature. You talk about React Native, which is responsible to develop the hybrid mobile applications in JavaScript. So these are two very popular, and there are many more which are available. Okay, so like you talk about architectural support, you talk about server-side rendering. Okay, so Redux, and there are a lot many other tools are also available. So what is an event in React and how you're going to create that? So React is basically offering the ideas of handling the event very fairly easy, so that you talk about clicking anything, you talk about taking your mouse somewhere. So these kind of options generate an event. So for that, we typically say alert, and you click on this render, you click on this button, in a curly braces, you call the function to trigger to event. Now, what are the components in React? So friends, React components are nothing but a call view. Okay, like a complex view can be divided into the smaller portions. A complex UI can be distributed further to create more, better, and reusable views. Clear? So it splits the user interface into the independent pieces of code which can be developed and joins later on. Okay, so that's how you define the component in React. So in Angular and React, in both the areas, the word component is very much used. So the component meaning is very simple. You talk about a view. So what is the state in a React? So state is React is nothing but is the one which identify what was and what is now. Okay, which stores the value for the specific period of time, which changes, and React is basically detecting those. So it is changing because of some actions either taken by the users or by the applications. Okay, so it keep tracking about all those states what it was there. Like in, I'm talking about an incrementing in a counter. So that is also the state available there. Okay, so the state object is always initialized in the constructor, so it can contain the multiple properties. So this dot set state is used to change the value of the state object, and set state is responsible to perform the shallow merge between the new state and the previous state. Now the state holds the data that a component renders to the web page. Certainly, because every time the state changes, so it needs to be stored somewhere. So this is how the state is accessed. As you can see this example here, in the constructor, we are defining the super props and the states being initialized, and you're rendering the states. There are three different steps are involved: initialize the state, render the state, and update the states. What is a higher order component and pure component in React? Higher components are the component which are typically a function, okay, that takes a component and return a new component to you by manipulating few things. They're basically designed for the reusing. Okay, so the higher order components are typically a function that takes a component and return a new component. Okay, so in order to perform some reusability. A pure components are the components, okay, is a variation of React component that does a shallow comparison of props and state. Okay, shallow comparison basically checks what the equality. Are we clear now? So that's what the main job. Going ahead, what do you implement and how do you implement React routing? So to implement a React routing also comes with inbuilt React modules, and that particular module need to import it. So here we define the React modules by offering the route path, where you have a call left hand side is the name and the right hand side is the component which you would like to deliver it now.
Hello, this is Matthew, and we're going to be going through some of the simple questions that you would be asked during a Node.js interview. What we're going to do is we're actually going to break out the section into three key areas. There'll be beginner questions, there'll be intermediate questions, and advanced questions. And the expectation is, as you go through this video, is that these questions could be pushed together as you're going through the interview. Kind of think of it like this: is if you answer the beginner questions that you would get asked at the beginning of the interview with confidence and surety, then the client is going to then jump to those intermediate and advanced questions quite quickly, and they're looking for people who can help them serve and solve their problems at that more intermediate and advanced level. So let's just get started. So the first question you're probably going to be asked is, what is Node.js? Do you know what it's for? And essentially, Node.js is one of the most popular, if not the most popular, open source cross-platform JavaScript programs. It allows you to build out web applications that run on the server. It's extremely flexible. It allows you to implement a lot of solutions outside of just the core programming runtime. And it allows you to build solutions extremely quickly in an open source mindset for DevOps. It is used essentially for creating client-side web applications. We'll see this later on, and you may want to talk a little bit about using Express.js and how you can build out APIs to work with Node.js and connecting to databases such as MongoDB. And that is also really good for being able to store data-intensive applications that are asynchronous and event-driven in their model. And this is important when you're talking about creating applications that can scale rapidly. So you're going to then be asked, how does Node.js work? Well, Node.js itself is actually built on the V8 engine, and the V8 JavaScript engine is the same engine that runs JavaScript in your Chrome web browser extremely fast. It allows for high output and non-blocking through your I/O input and outputs, and is single-threaded event loop. So you're going to be then asked, where can you use Node.js? And the reality is that the applications for Node.js keep expanding, but there are some core applications that you can work with Node.js right now. So such as web applications, distributed system, and network applications. Probably referencing the web applications is a really good starting point because here you can actually talk about maybe some examples that you've done where you're building out some of these web applications. Indeed, one of the things that you want to be consistently doing and peppering your answers with is examples of work that you have done. Now, it doesn't matter if those examples are purely experimental or training examples that you've done. The fact that you've actually worked with Node.js and created a distributed system or a web application is really valuable because it shows the person that you're meeting with that you have knowledge and understanding and practical experience of applying the theory of working with Node.js with the practice of working with Node.js. So be asked about, essentially the I/O refers to the transfer of data in and out of a system. And that's really it. And there's a reason why Google calls their conference I/O. It's the transfer of data in and out of our brains at their conference. The application is the same here. It's about moving data in and out of systems through using Node.js. And that every event can be tracked, whether it's on a physical device, a network, or files within a system. Again, it's input and output. So let's go through and, you're going to be asked, can you explain the difference between front-end and back-end development? And this is a question that I get asked a lot when I'm meeting with clients. People get really confused about what is the difference between front-end and back-end development. Bottom line, front-end is what gets resolved inside of your web browser or the app on your mobile device. Backend is what gets resolved, essentially what we call the back office or server-side applications, but that's becoming more and more synonymous for what gets run in the cloud. So web applications really get a lot of the functionality of a web application gets run in the front end. Anything with CSS, HTML5, client-side JavaScript, it's all going to get run in the front end. Everything else, such as connecting to a database, gets run behind the scenes in the back end. And anything that's going to have like graphics is going to be on the front end. APIs are going to be run on the back end. And then just finally, some of the scripting languages that use it on the front end. So HTML, CSS, JavaScript, those are all common core scripting languages that you would use. You can use frameworks such as AngularJS and React.js or Vue. Those would be front-end frameworks. Back-end frameworks would include Java, PHP, Python, and Node.js are some of the back-end technologies. You could also throw in there .NET as well. It's just a whole litany of front-end and back-end technologies and frameworks that you can use. And this is actually a good point to kind of explain the experience you have outside of just working with Node.js, but other technologies that you've been working with that potentially that the client is also using. So another question you're going to be asked when you're looking at Node.js is, can you tell me about NPM? And so when somebody asks you what is NPM, the first thing you're going to respond is, do you mean Node Package Manager? And the reason why you want to respond like that is that you want to qualify their question with understanding that you know what they're talking about, but you want them to verify that. And so Node Package Manager is NPM. And it's responsible for packaging all of your modules that you're working with in Node.js. And we have a whole series of videos that we've done on Node.js, and every single one of them includes references to NPM. So you're going to be asked, okay, you told me what it is, can you go into a little bit more details, so you can provide two main functionalities. And so one of them is being able to manage online repositories of modules and packages. So you can go to like search.nodejs.org and you can find packages that you can install into your solution, such as Express.js. And it also provides a command line utility that allows you to manage your packages very quickly through terminal window or command line. I use VS Code a lot, Visual Studio Code, and it has a command line utility built right into it that allows me to interact with NPM. So what are some of the modules in Node.js? And so, modules in Node.js, they're essentially like JavaScript libraries. So you can think of some of the JavaScript libraries that you may have used. The functionality is somewhat the same, but they're designed for Node.js and to run on the server. And there are ways in which you can go ahead and create some of those modules. So for instance, if we're creating a web server, you can actually use the require command to be able to require that the server be there. So the example we have on the right-hand side shows that we really do need to have HTTP, which is a web server, and we require that to be installed. And so that if you're running that NPM package, it will actually install the HTTP server, and then you can actually write some code to actually then listen on the local host port 2000 for where you'll be running your application. And there are just, there's a whole bunch of modules that come with Node.js right out of the gate. And here are some of the modules that you have. We also referenced just earlier on, HTTP is a core module for running a web server. You have a utility function that is useful for developers to assess features within your Node.js project. You have a URL module for any URL parsing you'd be doing. And you also have a stream, which allows you to be able to stream data in and out of your system and be able to manage how that's being worked. And then zlib, which allows you to compress and decompress files so that you can keep your storage of files to a minimum. So a question you're going to be asked is, why is Node.js being preferred over backend technologies such as Java and PHP? Particularly with Java, it's a very mature, stable language. It's been around for more than 20 years. PHP runs some of the most powerful and largest websites out there, such as Facebook. So why would you use Node.js? Well, the first response is kind of a gimme, but it is really fast. And if you watched any of the videos that we've done on Node.js, building out solutions and developing the solutions, you'll see just how fast it is. The second is the really kind of the secret sauce with Node.js is the Node Package Manager. And the Node Package Manager allows you to install additional functionality such as Express or Mongo as a database into your solution really quickly. And there's over 50,000 bundles available for Node Package Manager. If you're building out a real-time application that's data intensive and you need to have APIs quickly developed, then Node.js is really the great solution for you. It allows you to build out these solutions really quickly. And there is a easy synchronization between the server and the client due to the code base. And then finally, because the structure of Node.js is JavaScript, if you are making the pivot from being a front-end web developer to Node.js, it's just going to make it a lot easier for you to pick up Node.js because you have that common language of JavaScript. And on top of that, JavaScript is the world's most popular scripting language. So let's talk about some of the differences between Angular and Node.js. And so the reason why this question may come up is the person interviewing you is seeing whether or not you do know the difference between a front-end framework and a back-end framework. And this is one of those questions where you can go, well, there are differences, but the differences are because they complement each other. So Angular is a front-end development framework, whereas Node.js is a server-side framework. Other differences, though, between the actual frameworks themselves is that Angular is written in TypeScript, which is a modification of JavaScript. Node.js is written in C and C++. Angular is used for building out single-page client-side web applications. And so that's the key word there is client-side, whereas Node.js is about building out fast and scalable server-side network applications. Again, the two complement each other. Angular splits web applications into the MVC and model view control components, whereas Node.js generates a lot of database queries. It does more than that as well, but you can think of Node.js as that glue to your database. So let's talk a little bit about when you're connecting to a database with Node.js. And so you're going to probably be asked, what is the most popular database used with Node.js? And there are a couple. MongoDB is largely the most popular NoSQL cross-platform database. MySQL is also very popular, and that's a more traditional relational database. You would go with MongoDB for really more modern solutions. When you're looking at creating an application that's going to really scale into just managing masses and masses of data that has to be created, read, updated, and deleted very, very quickly. For some of the other popular libraries that you use for Node.js, Express.js is a very popular one. I really like working with Express.js. It allows me to build out web applications really quickly. More importantly, it allows me to build out APIs very quickly, and which, APIs are essentially web applications themselves. But being able to do that very quickly with a framework like Express.js is very useful. Mongoose is an application that makes connecting to a Mongo database really easy. So here is an example of Express.js, which is in itself really a flexible but a solution that you can do lots with, and Mongoose, which is a more focused solution, which allows you make it easier to connect to your databases. So, what are the pros and cons of working with Node.js? There's lots of ways, and we explained this earlier on, that you can actually build out applications that run on the cloud. Why would what are the pros and cons? So a pro is that Node.js is extremely fast at processing an event-based model. It really is fast. A con is if you have something that is a very heavy computational task, it's not so good at that. Now, I will caveat that Node.js is getting better all the time. And so you might have to provide an example of what a very heavy computational task is. And that may be calculating a risk on an insurance application against many, many variables. That may be something that's seen as computationally very heavy. But what you can do in that example is you can then offload the task to another solution that's designed for it and use APIs to pass the data back and forth. Pro, JavaScript is used for building out your applications with Node.js. Great, lots of people know JavaScript. A restriction, and again, this is evolving as JavaScript itself evolves, is that when you do a callback, you may end up doing lots of nested callbacks if you're doing something that's very complicated. Again, another way around the con, and so this is one of the things that I always look for, is if you have a blocker or a barrier, how do you get around that barrier? And so, for instance, when you're talking to your recruiter, you can say, look, the reason why I use Node.js is that it's fast, it's event-based driven, I can use JavaScript. There are some challenges, but what I do to get around those challenges are, and that's where you can say that, you may run the complex script off and you may write that in .NET or Java or PHP, and then use an API to do the response back into Node.js. So you get the benefits of both worlds, but minimize the investment in having to manage a complex environment such as Java versus a relatively simple environment with Node.js. The Node Package Manager makes it extremely easy to access just an awful lot of functionality. With over 50,000 packages, there's a package for that. So from being able to have a tool that creates unique identifiers that you might need to have for generating content that gets posted into a database, through to being able to connect to databases, through to running so many different solutions. The NPM Package Manager, with its access to so many different packages, makes it great for getting access to all that content. Now, a con is working with relational databases with Node.js isn't as easy as a NoSQL database. Now, you can do it, and there are ways around that. And what I would do when this question comes up is always kind of pivot to say, hey, this is how you can actually then get around building out that application. Pro for Node.js, designed for streaming huge amounts of data in and out. A con is that Node.js is single-threaded, and so it can be CPU intensive. But again, there are ways around that, and a good way around that is scaling your solution in an elastic environment such as the cloud. So what is the command used to import an external library? And so to import an external library, the command is the require command. So an example we have here is you're going to start a variable, and the variable is going to be for HTTP. And you're going to then require the HTTP service. That means that the application itself won't run unless the external library, the HTTP library, is installed. Okay, so those were our introductory questions for Node.js. Let's kind of pivot and take a look at the intermediate questions that you would be asked. So what does event-driven programming mean? So event-driven programming means that if something happens, something else will happen in response. So for instance, if you click a mouse, that mouse click is an event. That means something has to respond to that event. Just think of it as cause and effect. It's just the basic motion of physics. So that's what event-driven programming means. You also look at it as a callback function so that when an element is executed, something will happen in response. So what is an event loop in Node.js? So an event loop in Node.js is when you do an asynchronous call. And what that essentially means is that you are sending out data, and then a non-blocking input-output from Node.js is pulling data back in. What is an event emitter in Node.js? So an event emitter has really two areas of focus. One is that it manages the classes that hold all the objects within your event. And we have an example of this on the right-hand side. And then whenever an event actually is thrown, the functions are then called on that event synchronously. So for instance, we have in our example on the right-hand side, we create an event, and then we have the functions that are executed in a series from that event. So let's talk about the API functions in Node.js. So there are two types. One is an asynchronous non-blocking function, and the second is a synchronous blocking function. And the difference between the two of them is asynchronous is that there is no structure to the order for how the API is resolved. Synchronous means that when the feedback from the API is received, you have to execute the response in a series for how the response is sent to you. So what is a package JSON file? So the package JSON file is at the heart of our Node.js package when we actually will initialize a solution folder to be a Node.js package. You'll find that the package itself holds all of the metadata that's particular to the project you're working on, such as project name, version, requirements. You have to have it installed in the root of the directory for the project. And again, look at any of the videos that we have on Node.js. We do have demonstrations within those videos that actually then go through and break out how to create that root package. And you'll see how you can actually then go ahead and update the instructions or the metadata within the package. So here we have an example of what that metadata looks like. So again, this kind of continues that question of what is a package JSON file? And you may be asked, what is the metadata and why is it important? And the metadata is a basic JSON collection of pairing of key details such as name, version, description, and then the custom version that you put. So for instance, under name, you could create a name for your project. There can't be any spaces. What is the version and the description? What is the main or starting path for the solution? Typically, that would be index.js, but it could be anything.js. But index.js is typical simply because index.html is the starting point for a typical web application. So how would you use a URL module in Node.js? So with the URL module, what it allows you to do is really two things. One is that it provides the resolution and parsing of a URL for utilities in your application. And then it allows you to extend your module with built-in solutions and split up the web address into a readable format. So in this example, we have the URL and the response it would give for that URL, which would then be a year and month, and it would be in a readable format. So it would read out as 2020 and then the month. So what is Express.js? Now you've heard me mention this a couple of times in the video, and we actually have a separate video on Express.js. But Express.js is a web application framework that allows you to build out web solutions for both mobile and traditional desktop right inside of Node.js. So it's very easy to use. Being able to install Web.js is as simple as requiring Express to be installed. In the example that we have here on the screen, it's a full solution of showing how to actually build out a solution with Web.js. So in this example, you start off the first two lines, require Express to be installed, and the install comes from Node Package Manager. Then we have a simple application that will then send to the browser window a hello world message confirming that Express is up and running. And then the third block of content, starting with var server, actually will define the port where your application is going to run. So in this instance, the port is going to run on localhost, and the port will be port 8081. And so you can actually go to localhost 8081. And when you do that, that will trigger the application that will forward up the message, hello world. And it's all coming from Express.js. So what are streams in Node.js? So streams are objects that allow you to read and write data continuously back and forth within your application. And there's really four different types of streams. There's readable, writable, duplex, and transform. The readable one is streams for which data can be read. The writable is streams that you can actually write to. A duplex is a stream where it is both readable and writable. And transform are streams that can manipulate the data while it is being read or written. So how do you update and delete a dependency? So Say, for instance, we want to install something like Express. So if you wanted to install Express, what you would do is you would just write inside of your project. You want to go to terminal window and write in the command npm install Express. If you want to update the dependencies within your Node package manager, to update all of them, all you have to do is write the command npm update all dependencies. And then if you want to explicitly uninstall a dependency such as Express.js, that's using the uninstall command. And so that would again be going to terminal window and you would type npm uninstall Express. And again, it's really easy to create a simple server in Node.js that will run a simple command. The HTTP service is actually built into Node.js. You don't need to use Express.js. I typically use Express.js when I want to do a web server because typically what I find is that I will want to go and do something more complicated. But if you want to do something that illustrates just the core functionality within Node.js, you can actually just require the core HTTP service that actually comes as part of Node.js. And then you can actually then go ahead and tell it to create a service and then to write in plain text a command or a text string, such as in this case, it'll be hello world, that would pop out. And then the final line is to then listen that if you go to a web browser that's on port 127.0.01 or localhost and go to port 8080, once you actually go to that, that will trigger this application and you'll get the text hello world pop up on your screen. So explain synchronous and non-blocking APIs in Node.js. So all the APIs in Node.js are asynchronous, which means that they are non-blocking, which means you can run them continuously and scale around that, which is just fantastic. It's one of the reasons why Node.js can scale so fast. And the API means that the APIs can return data, send data after it's been called, and really increase the efficiency of events as they are triggered within Node.js. So how do you implement async in Node.js? And so the example that we have on the left-hand side allows us to trigger async, and it's using the async function. And as you can see in this example, it's actually something that can be done very quickly. In this example, we're actually making a command to localhost and an app that's running on port 3000. And then depending on what we get, if there's an error message, then we'll have error message go to the console log, which is the terminal window. And if we get a response to an application, then we'll actually get a positive response, which would be fetched response. So again, very quick and easy that you use the async function to be able to build out and to get your asynchronous code. So what is the purpose of module exports? So a module export is a way to encapsulate the entire code for a solution in a single package, in a single file. And then you can then share that with other developers, so you're all working from the same environment. So what is a callback function in Node.js? A callback function is essentially that once you run and you've triggered an event.
MongoDB has consistently been ranked as one of the top 5 NoSQL database management systems. So if you're someone who's applying for a position in database management roles, you will almost certainly be working with MongoDB at some point. Now, whether you're upgrading your skills or interviewing for a database management position using MongoDB, it's a good idea to be familiar with the most frequently asked MongoDB interview questions and answers. In the latter case, it is beneficial for you to prepare for the interview so that you're not caught off guard. Even if you're just interested in learning about MongoDB for the sake of upskilling, keep in mind that acquiring this kind of knowledge may lead you to looking for a better job, which means you'll be facing an interview sooner. On that note, hey everyone, welcome to Simplilearn channel. I hope you guys are doing good and staying safe. In this tutorial, we'll be discussing some specially curated MongoDB interview questions that you must master to crack your next interview. So without any further ado, let's get started with today's topic. Well, but before we begin, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel SimpliCode to stay updated with all the latest tech content. And hit that bell icon to never miss an update from us. So let's get started with today's tutorial. So firstly, let us discuss the agenda. Now, this MongoDB interview question is intended to give you a general idea of the types of interview questions you might face. Now, we'll be covering some theoretical as well as practical questions in this tutorial. Now, typically, recruiters begin with simple questions and gradually increase the difficulty level. So, in this MongoDB interview questions tutorial, we'll start with the basics and then progress to more complex questions. Now, before we begin with the types of questions that are being asked, here's a simple and quick tip for everyone who's watching this video. Now, make sure you have the never give up attitude. I know it's that time of the year where placements are going in a rampant way, and I know you might be giving interviews regularly. And what if you didn't get an offer in one of the interviews from that? So make sure you have that attitude of never give up and prepare for your next interview. And whenever you're giving an interview, make sure you are interactive. Being interactive is one of the best way you can say in order to get hired by the recruiter. So make sure you're conversing properly with the interviewer while asking the questions. And finally, behave professionally, which is another key aspect while giving an interview. So let us now discuss the first question, which is the basic question which will be asked, which is explain what is MongoDB and its features. So this is how you can answer. MongoDB is basically an open source cross-platform NoSQL document-oriented database management system. Now, NoSQL can be utilized as a substitute for traditional relational databases like SQL and MySQL, which is dependent on the SQL language, right? So if you want to work with large data sets of distributed data, then NoSQL databases may be quite supportive, which are used to store large volumes of data in the form of documents, which will offer the developers the flexibility to work with the evolving data models, as there is no fixed schema in this. Now, relational databases such as MySQL and Oracle store data in tables and rows, right? They are based on a branch of a theory known as relational databases. Now, these relational databases are structured and tables can be linked with each other via a foreign key, which is a property of relational database, which is ACID property, which is being satisfied by the relational database. But whereas the MongoDB being a documented oriented database, it can handle only that sort of information and store as well as retrieve information from these documents only. It provides the flexibility as well as scalability that you want with the querying and indexing according to your requirement. This MongoDB basically is based on JSON-like documents where we store all the information in that. So this is how you can answer the question, which is what is MongoDB and its features. Well, the next question is, what are some alternative NoSQL databases to MongoDB? Now, we have various alternatives from MongoDB such as Cassandra. Apache Cassandra is a free and open source distributed NoSQL database management system, which is again similar to that of MongoDB to handle large amounts of unstructured data across the servers, providing high availability with no single point of failure. Apache Cassandra is a database which can be a right choice when you need scalability and also high availability without compromising performance. Next, we have Redis. Redis is actually another popular NoSQL database, which is an open source, which is implemented as a distributed key value store with optional durability. It can be also used as a cache and a message broker. Also, we have other popular NoSQL databases like Amazon DynamoDB, Apache HBase, and Neo4j. Now, HBase again is an open source non-relational distributed database, guys. It is generally written in JavaScript and it is also developed as part of the Apache Software Foundation. So these are some of the examples and can be used in alternative to MongoDB. Alright, let us now move to the next question, which is what type of NoSQL database is MongoDB? Now, in general, we have 4 different types of categories when we talk about in which category MongoDB comes under. So basically, we have key value, column-based, document database, and graph database. Now, when I talk about key value, these databases store data as an index key and value pairs. These databases store data in a schema-less way. Example of key value data store include Cassandra, Redis, DynamoDB, and etc. Next, we have column-based. Now, column-based or column store type of database is the one where these databases are designed to store data as columns of data rather than as rows as data.
If it stores in a row type of data, again it becomes a traditional, which is not a NoSQL database, right? So again, example of a column store databases are HBase. Even Cassandra comes under the column based as well. Next, we have the document database, which is actually the type of NoSQL database that we are looking for, which is MongoDB. Now, document databases are designed to store documents with each document having a unique key. And popular document databases are Couchbase and MongoDB. And finally, we also have a graph type of database where they are based on graph theory. So these databases are basically designed for data which needs to be represented as graphs. So the data that is present in this sort of database is interconnected with multiple number of relationship between them in the form of graphs and trees. And a popular graph database is Neo4j as well as Big Data. So this is what MongoDB is, and it comes under the document database type of NoSQL database. The next question is, how does MongoDB store data? Now, data in MongoDB is stored in JSON documents or the JSON style data structures. Documents contain one or more fields, and each field contains a value of a specific data type. So MongoDB stores data records as documents, which are in the form of JSON documents, which are gathered together in collections. So these documents, as we said earlier, has a sub-specific data types, including, let's say, arrays, normal general data, and these documents tend to share a similar structure, which are organized as collections. So you can say a group of documents are kept in a collection. It may be helpful to think of documents as in a comparison to the rows in a relational database. So fields are similar to columns and collections are similar to tables in MySQL database, which is again it's a relational database. So this is how MongoDB stores data. The next question is, MongoDB is a schemaless database. If yes, how do you create schema in MongoDB? Now, the schema of a database describes the structure of the data to be stored, right? In a relational database, the schema defines its tables, its fields in each table, and the relationship between each field and each table. So if you take SQL as an example, which is a schema-based database, right? So its schema is defined by the tables and the fields, that is the columns and rows that are present in it, and the relation between them. On the other hand, we have MongoDB. Now, in documented-oriented databases like MongoDB, data is stored in collections of key value pairs. Now, given that JSON is a schema-free data structure and that MongoDB depends on it, it would be more accurate to say that it has a dynamically typed data. So whenever you create and insert a document to create a schema, it will automatically create one for you. So whenever a document is added, the database will automatically create the corresponding collection. The next question is, how is MongoDB different from SQL and better than MySQL? Now, MongoDB is again a documented-oriented NoSQL database which is used to store high volume of data and which needs to process huge data in a quick session. Now, it is a database that came into picture around the mid-2000s, and it is again considered into the category of a NoSQL database. Whereas when you take SQL, SQL is a programming language used to communicate with and manipulate relational databases. For example, MySQL. Now, there are quite differences between both of these databases, right? Being one as a relational database, the other being relational and non-relational database, there are quite differences between them. So for example, if you take the structure, in SQL, data is represented in tables, whereas the data is represented in documents, and this further documents are stored in collections. Now, schema, again, SQL has a predefined schema. So whenever you're creating a table, you need to predefine its schema, whereas MongoDB does not have the implications of specifying any schema before working on it. So it has basically a dynamic schema. Next, we have this scalability. The data in SQL can be vertically scalable, and when it comes to MongoDB, both horizontal and vertical scaling of data is possible. When I talk about transactions, SQL also supports atomic operations and follows ACID properties, whereas MongoDB does not have proper support for transactions and it follows CAP theorem. And finally, the type of operations. Now, some operations that we perform in relational databases like SQL, for example, SQL supports join operation, whereas we don't have the same sort of join operation in MongoDB. So in this way, MongoDB is different from SQL, and in some ways it is better than MySQL in terms of processing a lot of unstructured data, and also has certain features like replication, sharding, and MapReduce, and some of more critical features that are not present in MySQL. Well, the next question is, what are the different data models in MongoDB? Now, data models are categorized into two types. The first one is embedded data model. The next one is referent data model. Now, if I talk about embedded data model, embedded documents capture relationship between data by storing related data in a single document structure. Whereas reference data models store the relationship between data by including any links or references from one document to another. Moving on to the next question. The next question is, how does indexing works in MongoDB? Now, a good indexing strategy, be it a relational database or a NoSQL database, it is essential for ensuring that your database returns your results as quickly as possible. Now, MongoDB indexing is a special data structure on which the index is created to hold the data of a specific fields in a document. Now, in the absence of indexing in MongoDB, there is a need to scan every collection, which is basically a collection scan. So MongoDB indexes make it unnecessary to perform a collection scan, which involves looking through every document in collection for matches to your query. It also provides effective indexing strategy. Now, any collection in MongoDB can have one or more indexes, and those indexes can be made on one or more multiple fields and even throughout a MongoDB database. So you need a good indexing strategy to quickly and, let's say, effectively access the data you require from it. And it also provides search efficiency. Now, indexing is a necessary operation in MongoDB, which will bring search efficiency in various execution of statements. So this is how indexing works in MongoDB. So moving on to the next question, what is MongoDB replication and sharding? Now, if I talk about replication, replication means duplicating the same data across multiple MongoDB servers. So the main use of replication is the data is available at an instant way, that is high availability of data, and it also supports data redundancy. And multiple copies of the data are being saved across servers. And also it provides data recovery and backup options as well. So in a nutshell, you can say that database replication is the process of copying data from one database in one server to another database in another server, ensuring that the same data is available on more than one MongoDB server. So again, the main purpose of using replication is data redundancy and high availability. So by keeping data several copies or replicas stored on physically separate servers, it will ensure that the data is protected and it is also accessible whenever we need. And also by generating multiple copies of your data, replication enables you to increase data availability, which is also another important factor. This is especially helpful if a server fails. So in that case, you can use the replication. And finally, you can also recover the data that is lost due to any uninterrupted or any hardware failure issues. Now, if I talk about sharding, sharding is also similar to that of replication, but it is a method of distributing data across multiple databases. And MongoDB supports this deployment of data with having large data sets and high throughput via sharding. So let's take an example. So you can give an example to the recruiter like this. Let's say I have a database having 2 million users and it has a capacity which is 2 million records. Now what I'm doing is I'm basically distributing the data across multiple databases and I'm storing different data in different databases. Now we have two machines which has 1 million user capacity and another 1 million user capacity. So in this way you can add more and more multiple databases in order to store your data. So by adding more capacity to a single server, such as adding more memory and processing units or adding more RAM on a single server, that can be done using sharding. Let us now move on to the next question, which is explain horizontal and vertical scaling. Now vertical scaling refers to adding more resources like CPU, RAM, or any hardware or hard drive disk space to your server, which is again a database or an application server, which is done on demand. On the other hand, horizontal scaling refers or involves adding more processing units or physical machines to your server or databases. Now MongoDB, which is a NoSQL database, handles horizontal scaling through sharding. So in a nutshell, you can say that vertical scaling can be used in order to increase or decrease the capacity of existing services, whereas horizontal scaling adds more resources like virtual machines to your system to spread out the workload across them. The next question is, when should we embed one document with another? So you should consider embedded document, that is sub-document, whenever you rely on these 4 factors. That is, when the relationship is one to few, that is, it can be one to many, but not one to one. So for unlimited use case, you should start considering separating sub-documents into another collection. The next situation is when retrieval is likely to happen together, which will improve the performance. In such case, you can embed one document with another. The next factor is when updates are likely to happen at the same time, you can use this multi-document transaction by embedding data model. And finally, when the field is rarely updated, in such case, you can use the embedded document. Well, let us now move on to the next question, which is what are replica sets, and explain primary and secondary replica sets. In MongoDB, the process of replication, as we discussed earlier, is done via using replica sets. In simple words, it is a group of MongoDB processes to keep the same data across different servers. Now, a replica set is basically a collection of related MongoDB nodes, which must have 3 nodes at least. Now, one of them must be a primary and the rest secondary ones. And a replication structure can have up to 50 nodes. So the main types of nodes that we have is primary and the secondary, or you can call them as primary and secondary replica sets. Now when I talk about primary replica set, the primary is the member in the replica set that receives the write and read operations. But read operations can be pointed out to secondary nodes, changing the configuration at the moment to perform the query. Besides, the replica set can have only one primary node at most. And talking about secondary, the secondary is the node where the data is replicated to maintain a copy. A replica set can have one or more secondary nodes, and the clients cannot write data to secondary ones, only they can read from them. And if at all there is any failed node, it works as a secondary node again until a new primary node will be replaced with that. So this is what a replica set means, and the type of replica set, which is the primary and secondary. I hope you understood this. So moving on to the next question, which is what is the use of capped collections? Now the size of collection in MongoDB is typically unrestricted, right? So the collection increases its size as more documents are being added to that. Now a capped collection is a special type of collection that has either a fixed number of documents in a collection or fixed number of elements. So it creates new documents by overriding the oldest documents present in that collection. So capped collections can have maximum size or document counts that prevent them from growing beyond the maximum threshold that is being allocated. And all capped collections must specify a maximum size and may also specify a maximum document count only. Now MongoDB removes older documents if a collection reaches the maximum size limit before it reaches the maximum document count. So overall, the structure and functionality of a capped collection supports high performance for CRUD operations like create, read, and delete. So this is what capped collections is and some of its characteristics and why we use it. Let us now move on to the next question, which is how can you store images, videos, and other large files? Now we often need to store files in our databases, but MongoDB sometimes, or it doesn't let you store any file larger than 16 MB in a normal document. So what you have to do? Instead, MongoDB has a functionality specifically for storing large files, and it goes by the name GridFS. Yes, you have heard it right. GridFS is a driver specification for uploading and retrieval of MongoDB files which are larger than 16 MB in order to store images, videos, and other large files. It is one of the most popular specifications, and it has a size limit of more than 16 MB. So you can store images, videos that have size more than of 16 MB. Now, chunks of files, like be it an audio, be it a PDF file or anything, it is being streamed as a chunks. So these are streamed into the database, and each chunk is limited to 255 KB in the size. This means that the last chunk is normally either equal to or less than 255 KB. So whenever you read from GridFS, the driver resembles all the chunks as needed. This means that you can read sections of a file as per your query range. So I hope you understood what is GridFS and what is the process to store images, videos and other large files which is of more than 16 MB. So basically the interviewer want to know that whether you are not familiar with the concept of GridFS. So that is the reason he might ask you this question. So you have to be well prepared for it. Well, the next question is explain aggregation in MongoDB. MongoDB aggregation processes the data records during an aggregation operation and returns a single computed result. Just like any other operations that are performed in a relational database, similar to that, aggregation is also used in order to act on a group of values from multiple documents present in a collection to perform operations on these grouped values and return a single computed results. Now, it actually groups multiple documents which applies an aggregation operation, and it is basically returning us the particular value that we want from that operation. Now, there are various ways on how you can perform aggregation. We have 3 different ways of carrying the aggregation process in MongoDB. The first one is aggregation pipeline. Next, we have MapReduce, and finally, we have single purpose aggregation. So you can further explain each of these aggregation depending upon the interviewer's preference. So basically, aggregation process in MongoDB is modeled on the concepts of data processing pipeline. So multiple documents enter the pipeline, and then these documents are being transformed into the aggregated results. Next, we have the MapReduce. As the name suggests, it has 2 operations, which is mapping and then reducing that operation. So it will map each document and process along with 1 or more objects for each document, and reduce phase in which output of map operations are being combined together. And finally, we have single purpose aggregation operation, where these operations aggregate all the documents from a single collection in MongoDB. Now, even though they provide a simple access to the basic aggregation operations, they lack the flexibility that are being provided by the aggregation pipeline and MapReduce operation. So these are the 3 aggregation pipeline method which they go through. First is basically the map stage, which will filter the records or the documents we need to work with. And next it performs the group operation, which basically is the aggregation. And finally, it will sort the data. So it will sort the resulting documents the way we require, that is in ascending and descending order. Now, just like any other operations given by aggregation in MongoDB, we also have 5 different types of operations that we can perform, which is sum, which will add up the values of every document. Next, we have average, which will compute the average value of every document. And we have min, which returns a minimum value from a document. And we have max, which will return the maximum value within a collection. And finally, we have push, which will add the value to an array in the document. Moving on to the next question, what is meant by ID field in MongoDB? ID is the field that uniquely identifies a document present in the MongoDB collection. So when you are trying to insert a new document into the database, MongoDB will automatically create a unique ID field which will have a unique value to its name. Now, by default, MongoDB creates a unique index on the ID field during the creation of any collection. And the ID field is always the first field in the document. And if the server receives a document that does not have any ID field first, then the server will move the field to the beginning. And also, ID field can be avoided in the document that you want to return by setting the value of the ID field as 0 in the query. So what are some utilities for backup and restoring in MongoDB? Now, by default, MongoDB shell does not include any import, export of data, or even duplication or retrieval of data from other applications. But however, MongoDB provides the utilities and database tools to take backup and perform the restore operations. Now, mainly we have 4 types of backup and restoring options, which are Mongo import, Mongo export, Mongo dump, and Mongo restore. So you can use one of these utilities like Mongo dump, import, export, and restore to move your data in and out of your MongoDB database. Now, the most commonly used are Mongo dump and Mongo restore. The Mongo dump utility creates a binary backup, of a MongoDB database. The Mongo dump tool is the preferred method of dumping data from your source MongoDB deployment. And if you're trying to restore the data that you have basically deleted or dumped, you can use the Mongo register in order to fetch back the data that you have dumped. So the next question is, can you explain about MapReduce process in MongoDB? MapReduce is basically a data processing paradigm for condensing large volumes of data into useful aggregated results. So basically, MongoDB provides the MapReduce feature for only aggregation purposes. And generally, there are two phases of the MapReduce, as you can see in the name, which is mapping and reducing. So in the first phase, each document is processed and emits common and redundant part of the document to pass a unique record for the next phase. And in the next phase, all the unique part gets together and aggregated to produce a single result. And finally, we have a query. Here we'll pass the query to filter the resultant set. So with the help of MapReduce, user can perform sorting, filtering, and document modification as per their need. So moving on to the next question, which is, how does MongoDB ensure high availability of data? In general, high availability refers to the improvement of a system or any application's availability by minimizing the downtime caused by routine maintenance or any hardware related issues. So MongoDB automatically stores copy sets and multiple copies of data distributed across servers and data centers. Now, in general, MongoDB is one such database which can provide high availability for the users by using features like replication and sharding. Now in replication, the replica sets help prevent website downtime using native duplication and automatic failures. Now MongoDB has a great support for high availability without no thought through replication set, but replica set is not enough for a production ready system. That is, it requires a bit of planning in order to deploy this. So sometimes it might be an issue, but in most of the cases, if the system crashes or the hardware or software faces any issues, MongoDB helps you recover and back up your data in the system. So the next question is, what is the role of profiler in MongoDB? Now, so far we have discussed some of the basic to moderate level questions, guys. Now from here on, you will find some practical as well as advanced level questions. So you might need to focus a little bit, and even if you're not confident and if you don't know the answer which we are discussing now, you can directly tell to the recruiter or the interviewer that you do not know the answer, but you hope that you have an idea on this and you can work on that and you can get back to him. So again, let's get back to the question, which is, what is the role of profiler in MongoDB? Now, database profiler is used to collect information regarding the queries which are executed on an individual database instance. So basically, this profiler in MongoDB database allows you to collect performance data about operations occurring on a MongoDB instance. The next question is, can we use regular expressions in MongoDB? Now in SQL, we do have regular expressions where we need, where we write a query to find certain patterns that are present in our database table, right? In a similar way, regular expressions are also used to match patterns in a document, just like finding a pattern in an SQL tables. So a regular expression basically provides patterns or sequence of characters for matching and defining a search pattern. And also retrieving an unidentified field using a certain pattern becomes easily within a document. And querying a database in order to find a smaller subset of data within a collection, we can use regular expression. So regex operator in MongoDB provides regular expression capabilities from pattern matching strings in the queries. And the syntax is followed as db.collectionname.find, mention the field name and mention the regex keyword and mention the pattern. Now the pattern can be of any of your choice. So the next question is, how do you search for documents in which a specific field has one or more values? Now you can say this is a bit of practical question, guys. The interviewer wants to know whether you are not whether or not you are comfortable and have an idea of using various operators in MongoDB. So you can use the db.collectionFind operation and also use a query operator which is $in order to specify the field and the values that you want to retrieve or you want to search for in a document. So for example, I have given an example which says that in order to return all employees whose title is product manager or executive director, in such case the query would be db.employees.find, mention the field which is title, mention the in which is a query operator here, mention the product manager and executive director which we are trying to find. So if there is any record or the person who is associated with this title of product manager or executive director, it will retrieve the record. Now we have a person name whose first name is Rahul and last name is Kumar, whose age is 29 and title is product manager. So this is how you can search for a document with a specific field which has one or more values. So the next question is, which command are used to insert single and multiple documents into a collection? Now we basically have two types of commands, which is db.collection.insert1, which will insert a single document into a MongoDB collection and it returns a document containing the inserted documents ID field. And next we have the same command but the keyword changes, which is insert many, which is insert a single or even multiple records into a MongoDB collection. Again, it returns a document containing each inserted document's ID. Well, the next question is, what is the difference between all and in operator in MongoDB? Now, both all and in operator are used to filter documents in a sub-array based on a conditional statement. So, but there are some differences or subtle differences between all and in operator. Now, when I talk about all operator retrieves all the documents which contains the subset of the value we pass, and this subset might be in any order. But whereas in operator retrieves all the documents which contains the either of the values we pass. Moving on, what is the next question is, both writes and reads become faster when you add more slaves to replica set. Is the statement true or false? Explain the reason. Well, the statement is false. Now a replica set can only have a primary at any particular time, that is having a one master with other nodes, the secondary nodes being slaves. So all write operations are performed only on the master node. Read operations on the other hand can be performed on any instance which can be a slave or a master node. So as a result, adding more slaves to a replica set accelerates only reads operation and not the writes operation. So the statement is not valid and it is a false statement. We cannot write and read both operation when you add more slave to replica set. The next question is, what is shard key, and mention the components of MongoDB sharded cluster. Now what is a shard key? Shard key is used by MongoDB to distribute the documents of a collection across shards. Now on sharding a MongoDB dataset, a shard key is automatically created by default. So the shard key can be in the form of indexed field or indexed compound fields that will be used to distribute the data among the shards. Generally, the shard key is used to distribute the MongoDB's collections documents across all the shards where the key consists of a single field or multiple fields in every document. Now the idea is to have multiple replica set with multiple primaries, which would basically divide data and load it among themselves. And each of these replica set is called a shard. Shard basically has three components, which is basically shard, Mongoose, and config server. All this together comprises of a MongoDB sharded cluster. Now when I talk about shard, what is a shard? Shard contains a subset of the sharded data. Okay, a shard is basically a single MongoDB server or a replica set that stores a partition of the application data that you have divided. Now next we have the Mongoose. Mongoose router, or it is a router of operations. Now because each shard contains only part of the cluster data, you need something to route operations to the appropriate shards. That's where Mongoose comes in. The Mongoose process is a router that directs all the reads, writes, and commands to the appropriate shard. In this way, Mongoose provides client with a single point of contact with the cluster. And finally, we have config servers. Now, Mongoose process are basically durable, should be durable. That means it must be in a position to store the metadata in order to properly manage the cluster, right, which we have formed with the shard key. So that's the job of the config server. This metadata includes the cluster configuration, the location of each database, collection, and the particular range of data therein. So this is what basically shard key is, and multiple components that are included in the MongoDB sharded cluster. So moving on to the next question, which is the join clause is a key feature of relational database systems. What is the MongoDB equivalent, if any, and are there any limitations? Now, whenever we hear about joins, we have like different operations like inner join, outer join, left join, and cross join. So similarly, we have a question here. That means if we talk about NoSQL, that means we do not have no joins. That means we do have joins or we do not have joins. That's the main question. But the thing is, we have a join equivalent in MongoDB also, which is the lookup operator, which is a significant disadvantage. That is, it does not work in sharded collection, right? So it's worth noting that rather than looking for a direct equivalent to join, MongoDB developers often simply denormalize the data, and which eliminates the need for a join, operation in a MongoDB database. So in a nutshell, you can say it performs an outer join to a collection in the same database to filter the documents from the joined collection for processing. Now the lookup operator adds a new array field to each input document, and this new array field contains the matching documents from the joined collection. So the next question is, mention some pros and cons of normalizing data in MongoDB database. Now, normalizing data is a key factor in relational database, but what about MongoDB? Now, updated documents is fast for normalized data, and it is relatively slower for denormalized data. Well, on the other hand, reading documents is fast in denormalized data and slow for normalized data. So denormalized data is hard to keep in sync and takes up more space. So RDBMS generally have this organic support for normalization and allow data to be managed as a separate entity, whereas NoSQL DBMSs like MongoDB do not have this active support for normalization. So the next question is, what are the advantages of using MongoDB? Now there are various advantages of using MongoDB. For example, it is an open source DB, that is, it is readily available for everyone to download and perform the operations right away. And it is also easy to use. The syntax is also user friendly, just like SQL. It is also highly flexible, which allows you to store and work on different data types and allows you to store unstructured data of different types in one or more documents. And the security is also a paramount feature for any user, right? So MongoDB provides advanced security features as well. And we also talked about high availability in our previous question. And it also has reliable indexing for a faster retrieval of data. It has a flexible schema design, unlike the predefined schema in relational databases. So this flexible or the dynamic schema design allows you to meet the ever-changing conditions of the big data applications, with a vast amount of data that is being incorporated into the documents. You can have a better edge on the data if you're working on large-scale applications. Then MongoDB can be a great choice for you. With all this, it also gives you high performance, which is another key feature of MongoDB and one of its greatest advantage of a NoSQL database. And that brings us to the last question of our interview question, which is, what are some applications of MongoDB? Now, MongoDB, being a NoSQL database, is widely popular in many sectors nowadays, and some of the major applications or real-time use case of MongoDB is it is used in IoT, which is Internet of Things. With the world rapidly advancing in technology, IoT plays a crucial role, and it is important that we as a user have this intention to store the data and have that data protected in any sense. Now the data is only getting larger and larger, and we also heard this phrase that data is the new oil. So in the coming years, the data is exceptionally going to rise, and we need MongoDB to store this huge volumes of data into our databases, right? So it is one of the applications of MongoDB. And we also have mobile applications and in order to perform real-time analysis. And we also have it is also used in catalog management, content management, and for product management and various other sectors as well. Now, companies also like to use NoSQL databases because of its flexible design, and the need of storing data without any predefined schema makes it a best NoSQL database. Like companies like eBay, Shutterfly, New York Times, Verizon, and many other big companies use MongoDB nowadays. And also one of the real life application or use cases, the best example you can give is Aadhaar card, which is India's unique identification, which is based on identifying a person's identity. So the Aadhaar uses MongoDB to store this massive amounts of demographic and biometric data of over more than 1.5 billion Indian users. So Aadhaar uses MongoDB in order to store the images, QR code details, the personal details of the user in its database. So these were some of the applications of MongoDB.
So this brings us to the end of this full course on MERN Stack for 2023. We hope you had a lot to learn, and if you have any suggestions or doubts, please write them down in the comment section below. Thank you so much for tuning in today, and happy learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.